Killer Master or some weird thing. But he kept saying that like everything is spheres because spheres are perfect, and then his examples were things like apples. Like,
well, he had a lot of bad stuff, but the part that was like similar to what Hutch is saying, he says, "No, the water is flat. The earth underneath the water is curved." That's what he was saying. The same thing. So maybe that's where he gets the idea. Then maybe if you have the video, send it to him, and he'll be able to hear his mirror argument from somebody else.
And I feel bad, dude. The fucking DJ didn't continue with that guy, but the other guy left too. So I can't. Fucking Phil in their DMs. Go eat a dick, Phil. I know you're listening.
He does.
Sorry, I just had to say that, man. Just go eat a dick. He was like, I'm full from breakfast.
No, the surface doesn't. You fucking idiot.
Oh, no, go ahead, dude.
All right, he's saying that, yeah, water takes the shape of its container with a freestanding surface. It's independent. The surface is independent of the fucking shape of the bottom of the container, you idiot.
Unbelievable.
Yeah, it's like we could look at water in another state and go ice. The only way you're going to get the curved top of an iceberg is if the entire ocean freezes so that it can expand in its container. But if it's ringed by ocean, it doesn't need to expand around the edges of its container, giving it a bowed surface. It's the only time that happens.
I don't know. It would be a really bumpy ride on water if it works the way that Hush thinks it works. I mean, every time you row your boat over top of like a coral reef, you'd be having a really tough time.
Yeah, Hush and Rich, okay, they say that the abyssal plane has a slope, right? A slight slope. Can you show the data that it matches the curvature rate of the Earth?
And you'll find that if you're finding that, you'll find it's the direct center point where the pressure is greatest, so it's bowing downwards, which is in the wrong direction for you to make a ball with.
I can't even imagine. I can't imagine what these people think. Like Hush, just go out there in the ocean and find all of like the sunken treasure ships just by seeing them form the shape of a treasure ship on the surface of the water. Like, what is he thinking? Just surfing around.
Yeah, like if this was true, then like all things would collect around the edges of the ocean, right? They'd disperse along this magic curve from its center point that he's saying is from all points. That doesn't happen because
you can make like a curve. But bro, you can make a curved bottom bucket, right? And the top of the bucket could be curved, and you could fill it with water, and it wouldn't spill out the sides. It's fucking so stupid, dude. It's like, Hush, dude. Like, seriously. Where's your mom? I'm gonna smack her for having you. Like, seriously.
It is dumb.
Hey, dude, I thought you smacked her before she had him.
Oh, was that her? I don't know. I don't take names. Hush, please. Come on, Hush, please. I'm actually... That's actually, like, depressing, Hush. Like, seriously. You can do better than this. Come on.
Hush, even on your ball, like with gravity, right? That would dictate that the surface conform to an overall curvature rate, not dictated by the solid surface that's underneath it. It'd be equidistant from the center, right?
Hey, saying. Maybe he's onto something. Maybe he's right. Just take that point of view. Like according to his own point of view, there should be like coral reefs and boats and whatever has sunken into the bottom of the ocean showing itself on the surface. That's not the case. Therefore, gravity doesn't exist. I mean, he debunked it in his own way, I guess, but.
Yeah, why isn't like so there's like the mid-Atlantic, what do they call it, the mid-Atlantic range? Why isn't like when you have to sail across the Atlantic, why don't you have to climb this freaking hump of water that's right above the mountain range? Unbelievable. So, hey, who's heard of the celestial theodolite?
They're doing a little presentation on it right now.
Another one? Jesus Christ, they've already done like 8. You're beating that freaking horse into the ground. It is pretty damning. I mean, I would do it too.
I think they got good times for all, like, with them at the moment, so maybe it's special for him.
Do you know what it is? Like, I just want to. Anybody that doesn't know about it, like, I kind of want to like explain it to them because it's so fucking damning for the globe, dude. It's a ripped fucking globe. So I'll just go through it real quick. So the dude, he was at his house and he can see a mountain in the distance. It's called Pikes Peak. And there's a so he was watching it, and so the stars move, right? And then what he did was, right when the star, he couldn't see the star anymore, when it moved behind the mountain peak, he wrote down the time that it happened. So then he went into Stellarium and he used like the GPS, which is supposed to use the atomic clock time. So he goes into Stellarium, which you can also set to that same time. And he entered the time. Right? So that time put the star at something like 2 degrees, 37 minutes above the horizon. Okay, so since that's the time that included the mountain, that means the mountain peak must also be 2 degrees, 37 minutes from his, above him. You know what I mean? If you took theoretically, if you took a theodolite and it measured it accurately, you would measure 2 degrees, 31 minutes. Well, it only works at a flat baseline. If you use a curved baseline from his location, because the mountain's like 57 kilometers away. So if he used a curved baseline to the mountain, that would make the mountain move down because of the curvature of the Earth. And then that would delay the time that the star was blocked by the mountain. And the time he would have had to write down would have been, if the Earth was a ball, would have been 51 seconds later, it would have been blocked from his field of view than the time he wrote down. Right? So he's basically using the peak of the mountain as the crosshair, marking down the time when it is in the center of that crosshair, i.e. blocked, and then saying, hey, what's the, does this match the flat hypothesis or does this match the globe hypothesis? Can I assume this is a flat baseline? Does it work with a flat baseline or does it work with a globe baseline? And it works with a flat baseline and not a globe baseline. Yeah, I overwood pussy and shit. Yeah,
that was a good Steelman summary of the situation.
Yeah, and the key thing is, it only matches when you shut off refraction. So if you don't shut off refraction, the star is not occluded. Right? If you assume a globe in refraction, the star is not occluded. If you assume a globe with refraction, star is not occluded. It's only occluded at that time with a flat baseline, right? In that distance. That's it. It only works on the flat Earth hypothesis. And he did it nearly 100 times. He's replicated it. And needless to say, Ruhip is so fucking pissed scared over this. Ruhip pays someone to go to the dude's house to like verify his date or some shit.
With his permission?
Yeah, I think he had permission, yeah.
Okay, that's good. Give me your data, bitch, right freaking now.
Hires some goons, you know.
Yeah, break his legs.
Yeah, so there's another thing that a lot of people don't realize when the Glovers talk about celestial navigation and these radials of degrees that map to a sphere. They only map at a certain portion. All the stars available in your field of view don't map consistently. That's why they exclude certain portions of the view, because they don't cohere with the globe. So they just tell you off the top of their head, hey, this observation doesn't adhere with my idea of a globe. Therefore, I'm going to throw it out and just call it some magic, magic, basically.
Yeah, and Hepburn's idea was to do it with the least amount of calculation. Oh, sorry, I over.
I was just saying you couldn't use that sighting to do celestial navigation using any assumptions of a globe, which is why they don't do it.
I mean, what do you think is a stronger argument? This celestial theodolite or celestial navigation? I mean, I thought it was kind of handled with celestial navigation, but
this is, I would consider this like, for no pun intended, another angle, because this is a timing observation.
Yeah.
Right? This isn't like he's just looking at the fucking star and going, what time was it blocked? Okay, at this time, sticking in Stellarium. Where was the star according to Stellarium? Star was here. Okay, what was it blocked by? The top of that mountain. I know the mountain's 57 kilometers away. Now, what surface does that have to be on to be blocked at that time? Right? Where is the mountain relative to my position, that peak of that mountain, to be in that line of sight with that star?
Yeah, so it would be like doing celestial navigation, but lining up like a 10-foot pole in front of you, then a 20-foot pole in front of you, and then so on.
But no, that's not the thing. Is he's using time. That's the thing. Is that this isn't like an angle measurement per se. It's using time, like a time. What he's measuring is a time, right? He's not measuring the mountain. Hey, what time did this happen? What time does frickin' astronomy predict that star's in that position? Which we do know very, very well, right? Because of the pattern. The pattern that we've been watching for thousands of years. We know when the star is going to be within a high degree of accuracy in a particular location. We know it better than the sun. Right? It's going to be in that place. And that's based upon like the so-called celestial sphere, right? So that whole thing, right, where the star is going to be, that's really what you're using. You're like, okay, what's the orientation of the celestial sphere relative to me at this time? Okay, so I have this terrestrial thing, and it's blocking the celestial thing out there. It's separating them, right? It's separating the celestial sphere from the terrestrial. There's a separation there because you're using the timing. The only terrestrial part is when is the star blocked from view. You know what I mean? You're going outside, you're going outside the coordinate system. You're going outside of refraction. You're going outside of dip, drop, all that in the initial observation, right? The initial observation. You don't even have to assume you're on any surface at all. Right? You could use your thumb. You stick my thumb in the air and look at it. When is this star blocked by my thumb? That's just the initial observation. And then the rest of the stuff follows from it. Okay, if my thumb is 5 feet from my face and the star is at 2 degrees, 37 minutes. What angle is my fucking arm, right? Where is my arm away from my body? Like you can figure out where your thumb is, right? The angle that your arm is tipped into the air. relative, like, you know what I mean? You can do the calculation to figure that out based upon when it was, based upon the timing and shit. And they're basically doing the same thing. Because I've heard Peter frickin' meltdown over this. I heard another dude just try to. The thing is, the main thing is the globe. If they try to go, okay, let's assume a globe. Okay, that don't work. The timing don't work. Okay, let's assume a globe with refraction. Okay, that don't work. Oh, it was a one-off. Okay, he did it almost 100 times, so that don't work. So you got to plead cosmic coincidence.
Yo.
Dude, this is very devastating. I didn't say anything about this. I've known about this for like 2 weeks. I've watched like 4 of the 5 of the presentations on it, and I've just been trying to like absorb it into my brain. It's fucking devastating for them.
Do you know why this guy, his origin story?
No, not really. I mean, I know he had something about, was it against relativity or something?
Oh, no, I mean in this topic. So he, so I'm not sure how he found out about flat Earth, but he basically was like, okay, I found out about flat Earth somehow. And I started listening to flat Earth versus globe Earth back and forths. Okay, because I wanted to be, I'm interested in the topic. I want to see what this side says and how this side responds. And I noticed a trend that Glovers had like this essentially magic bullet pull it out of their ass after everything, refraction. And yet, when asked, they were never able to quantify it in any meaningful way. It's just like it just became a catch-all term. So he said, you know what? There's a problem with that. And that piqued his interest. And so he said, I thought to myself, you know, if I want to know, and this is the excuse that's going to constantly be given, I have to come up with a way that I can do this, which gets rid of that excuse. Now, notice how he didn't say I have to define what refraction is and apply it and tell them that they're not using refraction. No, he says I'm going to remove it off the table as an excuse at all. Well, that was his idea anyway. So somehow he came up with this idea.
Yeah, going out at night. I mean, nighttime there's less, refraction because
well, I've tried to do the same thing with the reflection arguments, right? Like, hey, these reflections can't match a sphere either, right? I've tried to do similar because you can't plead that argument. Hey, it's refraction, because this is a different argument, right? It's like this reflection can't look like this because the surface is supposed to be curved, and you can't have a symmetrical reflection on a curved surface. The thing that's being reflected won't look the same. Like, so you see the object and then the reflection of the object, they can't be symmetrically the same in your vision. The curved one has to be distorted. And the thing is, they can't defend against it because half the time they're saying, if I project a globe onto a flat surface, it's going to be distorted because it's a curved surface being projected onto a flat surface. It's the same thing, right? In reverse, it's the same. You project a flat surface onto a curved surface, that you'll get distortion. There's no way around it. So, like, they have to argue against their own claims in order to argue against it. All they can say is Earth too biggy, which is also not right because quantify what it should be, because reflection is its actual law, like the law of reflection. Refraction can be manipulated because it's the angle, right? If the angle changes, the angle of reflection changes. Refraction is always equal. It's 45 degrees, bounces 45 degrees. It's 35 degrees, bounces 35 degrees. It's freaking 90 degrees, bounces 90 degrees. There's a known quantity that happens every time. And because the surface of a sphere is an ever-changing angle, you're going to get distortion because that reflection angle is going to be the same as the angle of arrival. And if the angle of reflection is constantly changing, but the angle of arrival is constantly the same, as you go further in distance, it'll get more and more distorted. It has to happen. This isn't like an optional thing, and you can't say refraction is what's doing it. But I mean, and my hats off to him for like coming up with this. This is very like a very unique thing. He also found something else that he actually quantified in theodolites, that there's a downward error, and he actually quantified what it is, and he said it's a linear downward error.
For what reason?
I think he called it a calibration error. And he did some, I don't know if he did it, he was saying something like he actually calibrated theodolites in his job, as part of his job. And what he was saying was, he did go over like the distances, the calibration distances, and they were ridiculously short. I mean, like meters.
Yeah, like for example, essentially when you if you zero a weapon, right, the sight is, could be an inch away from the barrel. So if you had them parallel, you'd always be shooting an inch low. So if you actually want them to intersect, you have to have one tilted, right? So if you hold the barrel level, the sight is going to be pointing to the ground. And depending on your sight picture, you're going to have a bad day trying to hit your target. And now, for people who don't know what a sight picture is you put your eye into the scope, and you have a front reticle and maybe like a front and a rear or a center reticle, whichever one you do. And the way your eye is in relationship to that creates an off angle to the target. So you think the crosshair is actually on the target from your point of view, but from the weapon's point of view, it actually isn't.
Yeah.
Dude, I used to ask those guys that were doing the eye-sighted ones with the angles back in the day. I asked them, how did you maintain your sight picture? And they had no clue what I was talking about. I was like, so I can't trust your measurements, dude.
You ever shot compound bows?
Yeah. Yeah, but not anything with sighting.
Like if you get the whole method right, you got to put the string on your nose, stare through the pendle on the string, then through the sight at the front of the bow, and you've got a level on that as well. So it's kind of way more complex than sighting a gun.
Well, yeah, dude, but that's sport, dude. Like, you don't want shooting a gun to be complex. You're trying to simplify that.
I think cleaning a gun is way more complex than shooting one.
Wow, hiding the gun, dude, I can't tell you guys. That's way more complicated.
Hiding it? Is that what you said? Hiding the gun is way more complicated?
Yeah.
PVC. Big ass PVC tubes and leads filled with oil and bury them in your backyard. Problem solved.
Globe days just begun.
Just hide them where no one will ever want to see their hand.
What did your Glober do? He said your line is through. They took my whole goddamn reality and threw it underneath a train.
I was going to say, if you don't mute up.
Eat the cat? Is that what you're trying to say?
So the calibration distance of a theodolite is short, but they're saying the max range is like an order of magnitude further than that calibration distance. They're just guessing. So they're calibrating it at a shorter distance than what they're saying you can use that, and then claiming, hey, at this distance, it's accurate to this. But then, like, what is the accurate part, right? Is it accurate in the measurement at the instrument, right? So, like, you'd say, hey, this instrument can measure, like, half an arc second. Well, is that the precision of the gearing or whatever they'd use to figure out how the thing is tilted in the device? Or is that the measure? Is that the accuracy of me looking through the scope out there in space, and I can measure, half an arc second angle precision of the degree of the little fucking lines in some rod that's a mile away. That precision, like, what do you like when? It's very nebulous of like what it means when they say the precision level of the device, whether it's the measurement of something out there in space versus the measurement of the instrument itself.
Yeah, I couldn't be sure. I mean, I thought it had something to do with the crosshair and how thick the crosshair is and the ratio that over time would cover up the measuring rod. But
because think about it. Say you're looking through the telescope, right, and you have the crosshair, right? But in the line of the crosshair has a thickness, and that thickness is going to block some angle. But they're claiming to measure angles that are smaller than the thickness of the crosshair itself, which never made sense to me. If you're looking at something a mile away, say, and the crosshair has like, whatever it is, 1/10 of a millimeter thickness in the optic,
right?
That's going to cover up like fucking feet, that's 2 miles away or 3 miles away.
Yeah, that's why. I mean, that's just my understanding on why you're not supposed to use it at a mile. It's only like short range. But that's for what a theodolite's used for, which is differential leveling, not really sighting the top of a mountain than the top of a star. That's just something different. I mean, the top of a mountain than a star to a star. That doesn't even really take whether the theodolite is. Well, I guess you'd have to level it also, but it doesn't really does it take that into consideration really? Yeah, I guess it would. As far as it would have to be level, of course, yeah. But I don't know if that takes the crosshair out of it, like the thickness covering it up, whatever. They just need those points that the theodolite, the mountaintop, and the star to be just coplanar in that diagonal at that time, like you said.
Yeah, that's all they need.
Yeah, with and then when they're when people are using the theodolites out in the world, they're taking like they'll use like a known object of a known height into account with their crosshair, so you can't be covering it up, whether it's a measuring rod.
So here's the other thing with that. You just made me think of it. Is they're getting the star in the true position, not the refraction corrected position. They're going in stellarium and shutting off refraction, and they're getting a true position. And this is what's making Ruhif go bananas, is because he wants to say the mountain is refracted up to make it appear in a refracted position.
Even when they turn the refraction,
but hold on, then the star is in the true position. So the star is unrefracted, but the mountain between the star and the between the observer and the star, that's refracted. So refraction only exists between the observer and the mountain, but from the mountain to the star, it does not exist.
Yeah, the refraction didn't cure it. Even when they turned it on, it didn't put it to. It still it was still much closer to the flat Earth actual position. The refraction didn't save them turning it on.
Yeah, which is what making Ruhif go bananas.
It is kind of cool, though.
I don't see why, dude. If I was Ruhif, I'd be happy. Let me tell you why I'd be happy if I was Ruhif. You see, what we just discovered, friends, is a new form of refraction. So you have your regular refraction, and then you have your extra refraction, which Ruhif gets the name after himself if he can come up with an equation for it.
It's such a nerd. Yeah.
It will be called roofraction.
Dude, Pat, you better start that shit before he does.
But see, you guys think I'm being facetious, though, but it's not unlike what initially happened with atmospheric refraction, which was invented to explain certain celestial phenomenon that didn't match their predictions of globe geometry. So they said, well, the light must be curved, therefore it is. Same reasoning. Back then, same reasoning now, same reasoning globe retards show up and try to say refraction, today. So it's all the same. We already know the Earth is a globe, therefore any observation that doesn't comport with a globe, we have to explain away somehow.
Yeah, there's provably with the quote flat Earth test, there's provably less displacement due to scattering, whatever they want to refraction, whatever they want to claim at night. Even there was the guy who did the 5 lights on the lake at different distances, all showing themselves to be along the same plane. That was done at night. There's the laser test over long distances, obviously done at night. It's shown to be the case. Yeah. Once you turn off all that different absorption of different, with the sunlight scattering all the light around, and once that's out of the way, all the stuff, buildings, everything's not bouncing, oceans bouncing light off from the sun every direction. Once you get rid of all that at nighttime, you see a much clearer picture.
Dude, you just talking keeps reminding me. That reminds me. Have you ever seen John Dee's test where he takes he looks across, I think it's Brighton to Chelsea or whatever the fuck they call it, but he takes the camera and he takes a pipe, like a 4-inch pipe that's like 10 feet long, and lays it right at the level of the water, and he looks through the pipe. Now, the thing with looking through the pipe is it gets rid of all the ambient and scattered light, because only the light that can reach the camera at the end has to be nearly in parallel to the pipe, because it'll get reflected, right? So it has to come through the opening of the pipe at one end and then reach the camera at the other end. And the only rays that's going to happen to have to be nearly parallel to the camera, so you don't get ambient light off from the sides washing out the image. So he did this 10 miles right at the level of the water and fucking sighted in the other side. No problem. When I think of this shit, the Flat Earth side has done so many fucking experiments, so many different ways. And then I hear some clown come in here and go, there's no evidence for a flat Earth. No, the evidence is overwhelming, dude. It's literally just absolutely overwhelming.
Well, maybe they're on the whole quantum, level of understanding that the evidence doesn't exist until they observe it. So. Yeah, but I would just to second that. I would say that since the recent, I guess, revival of it, right, which is only 15 years old or 10, 15 years old. Oh yeah, all the evidence points in one direction, and it is abundant, and it is overwhelmingly pointed to flat Earth. It's just in that amount of time, you got that. People put that much together. Just imagine what could be done with more time.
Yeah, so I posted that video in the chat. If anybody wants to check it out, they've never seen it.
I was about to ask. Is it the one about the pipe and the thing or something? I heard it.
Yeah, I think this is it. Let me double check. Yep, this is the one. Yeah. Nice. So if you go to he starts doing it at about.
What's the excuse that the Globers brought to the table when they see that?
So they just don't address it. Some of the experiments that are done, they just don't. They just pretend like it never happened, or they won't address it when confronted with it. Or they'll say the standard stuff like it's refraction or whatever. I'll take a screenshot of the setup.
Yeah, that's very interesting.
So look at the show. Look at this crazy setup, dude. Look at that pipe, dude. It's like a freaking. I don't know if that's metal or PVC, man. I hope it's not metal. He had to lug that thing all the way down there. But he's got like 3 levels like attached to this, right? So he knows this pipe is like absolutely rubble, and he just sticks the camera in one end, dude. And when he zooms in, right, like when you zoom in, the zoom ends up making this opening, like the field of view of the camera. And you can see all the way to the other side, dude.
They will have to claim that the light will just bend again and go into a straight path inside the pipe.
Yeah, exactly. It only bends until it gets to the pipe, and then it goes straight.
Yeah, exactly. Because if it's continue bending, it won't reach the lens at all.
This is another ingenious experiment. I wish someone would like replicate this a couple times.
It will be interesting, and with the matte or some painting that is light absorbent in the inside the pipe. So you take away also that bouncing light from the surface of the pipe inside the pipe. So I know it's not. It's not. Like,
well, you could calculate you could calculate the maximum angle that it could enter the pipe and reach the camera lens, right? By the length of the pipe, right? You take the edge of the opening and write the angle along freaking that length till it reaches the camera. You could actually figure out what the maximum angle outside of parallel it could be.
Correct.
All right, Glovers, I figured out why because he may use a black pipe which absorbs the light. That's why it starts to flatten out at the black pipe. Yeah, figured it out. Straightening it out to the straight pipe because it's absorbing it.
Yeah, the light must bend.
It bends everywhere where the black pipe is not. Yeah,
exactly. It must bend at the entrance of that pipe to be a straight beam of light that will reach that lens at the end of the pipe. That's stupid.
Bro, these dudes will crisscross light paths in midair so that the image is upside down, even though it's right side up, to try to prove their globe. So trust me, they'll tell you that the light's coming in crooked and straight simultaneously. They're that desperate.
Just invent radiance on the go. It's really annoying. Be like, all light is radiant from its emission point, and then they'll go, well, unless I need it to be 15 degrees hither or thither.
president compared to what they're claiming is the pitfalls of them trying to go back in present day, right? So, yeah, if you really start going down this rabbit hole, you'll see it's pretty crazy.
I will definitely try to find a NASA spokesman who said that regarding the technology. But like working in IT, I'm not that like perplexed because when I see how the higher holding, like the people with higher positions speak to the business and what things they say, because like usually the spokesman is not the person who's best at the job. It's just the person who communicates with the other sides. And usually technical knowledge of them is not that great. And the things I've seen that people say in IT, it's ridiculous. And both sides buying it. Oh, yeah, sorry.
I know, bro. You cannot discard this guy. This guy that said that, he is the top, the cream of the crop. This guy is the one that has been, this is the astronaut, the guy that claims he did it. And then he tells you, we cannot do it anymore because we destroyed what we had.
Was it spokesperson or an astronaut?
No, a spokesperson, an astronaut. The actual guy.
Do you...
Was it Don Pettit?
Who was it?
So, Tom Pettit.
Yeah,
one of the astronauts.
Tom what?
Don
what?
Don Pettit.
Pettit.
Don Pettit. I don't know how you spell it, but yeah. Maybe someone in here has the short, or maybe can post one of the videos of him saying that.
Yeah, I don't know what it's under on the home server, so I'll just ask for a list.
I go to the moon in a nanosecond. But we just don't have the technology. We destroyed that technology.
Do you know approximately when did he say that? Was it like after the landing, or like immediately after the landing, or
recently, like in the last 10 years or so, or something like that? I mean, he's currently head astronaut of the ISS, basically head coordinator or whatever. I don't know his exact position, but yeah.
Sorry, whose microphone is rubbing against something? Can you hear that?
If you check the side chat, I posted the clip where he's just straight up telling you that they destroyed the technology.
Oh, it's this.
It's just an excuse because they know it's an impulsive ball and it doesn't work in reality. That's what they have.
The fuck is this? Let me just.
Jemsy, what happened to your mic, brother?
I'm switching between earphones and the phone mic. So yeah, the phone mic sounds better like this, and then when I switch to the other one, it's probably messing up.
I've saved that on the home server under nanosecond.
I'll make a sound file of that too, so I can add it to the soundboard.
Yeah, this is crazy. I'm gonna find the whole interview. It looks high, to be honest, in the video, but
Don Pettit's a weird dude. You should hear him talking about coffee. Chugga chugga.
Every good American starts their day off with a cup of coffee.
You do such a good impression of him.
It's because I loathe him so.
Yeah, it's interesting. If he's not crazy, I would say he was probably choosing really bad words to describe what he was wanting to say. I don't know. I don't want to make assumptions, but in my opinion, the nanosecond part was to his decision. Like when he says, I would go to the moon in a nanosecond, like I think he wanted to say that he wouldn't spend time considering, he would go right away. He would agree to go again. And regarding the destruction part, sorry, was anybody talking?
I was just saying that I agree that he was being like metaphorical. It was a joke, but the destroyed the technology part isn't.
I mean, destroy is a strong word, but like back then they didn't have reusable rockets, right? So basically, if you state factually, when you use a rocket, you destroy it. Like you let it fall to the atmosphere and it destroys, it falls back to the earth. So
how many times did they claim to have gone to the moon?
Sorry?
How many times did they claim to have gone to the moon? 6 times? But then that was
I think it was the Saturn. I think it was the Saturn V was the one that they used for like the first 3 or something.
Like whatever they use, the first stage is you're gonna lose it. Like you don't have any way to bring it back safely to Earth, right?
Plus, if you look at the schematics, I think it was F.E. Batman who pointed out to me that there would have been no way for them to get to the lander the way that it was designed. Like how would they have gotten? Yeah, I forget exactly what he said, but yeah, it was like how would they have gotten into the lunar lander from where they were at rocket launch, based on the schematics. And it was a really great point.
I don't know, like you don't really have to go to the moon to see that, but currently I'm watching the SpaceX Falcon Heavy launch, and I clearly can see the curvature of the Earth, and I clearly can see that it's not a fisheye because the part of the rocket is there and it's not distorted, but the Earth is curved. But
things in the foreground may be less distorted than something in the background, and it's like if you've got something as large as a horizon, it may show more distortion than smaller things in the foreground.
Like, but it's a straight line. I mean, you can look at it yourself, but it's really a straight line. There's not much to distort.
Yeah, it was like, bro, it's just we don't know how that video was produced. You don't know.
Yeah,
you weren't there.
Yeah, I know. Like, I can 100% evidently show you that it was on the rocket. But to state that,
you don't know that
it's a conspiracy, and
you don't know
to us, and it's generated.
You don't.
It's kind of.
Yeah, it's not because we know that the Earth isn't curving. We know that if they show imagery and it shows a curved surface of the Earth, then they're lying. If they're not, like, if they've specifically said this is raw footage, it's not doctored in any way, it's not a fisheye lens, like this is an accurate representation of reality, then we know they're lying, because the surface of Earth, we can determine that the surface of Earth does not curve. We can determine that gas pressure requires a container. So if they claim to be going into an outer space vacuum, right, we know that's a lie.
Yeah. I've looked into the curvature issue, like most famous Chicago skyline issue. So basically, globe earthers' most common answer to that is that, like, you have to take into consideration the angle at which you look at the horizon, and also you have to take into consideration the refraction of the sun, for example. But yeah.
No, we're not begging the question with you, bro. For to make allowances for something, that something must have been demonstrated to be true in the first instance.
Allowance? Did you say allowance?
Allowance, yeah. To make allowance for something, you must have demonstrated that that something exists in the first instance. You can't just declare it exists, and then when you don't observe it, don't measure it, don't practically use it, say, well, there's reasons for that, there's excuses, this and that. No, demonstrate that it exists first.
Do you mean
then you can have as many excuses for why you don't observe it, right?
So do you mean the refraction that they use to explain why it's like visible?
Yeah, that's just an explain away. Who says it's true in the first instance?
The atmospheric refraction.
No, the curvature. That you're saying that the refraction is responsible for us not seeing and measuring.
Like, I mean, you can see a very far away object half cut by the horizon, right? Like bottom part of the far away objects cut off by the horizon. Like you can take a look at the pictures in the internet and see like far away objects.
I've never seen it myself. Never seen it myself with my own eyes. I've seen imagery of that. The problem is it would have to begin at 1.225 miles times the square root of the observer's height in feet, because now you're throwing refraction away and saying that the horizon is geometric. That's the physical Earth curvature blocking your view.
Okay, I'm not throwing it away. I'm saying there is a refraction, but even if the refraction makes something like more visible, then it actually should be. I mean, if it's far away enough, you would see it's cut off halfway bottom, right? And I don't know. Have you seen the Dr. Stone, the anime? I was watching.
You can't do that though. You can't declare that the Earth is a sphere based on that alone. You need to verify that it exists in the first instance. You could say that a potential reason I can't see the bottom of that boat is because the surface of the Earth is curving down and away from me at distance. And that object has gone over the point beyond which I cannot see the surface anymore, thus obstructing my view of that object. But you can say that, right? Now you have to demonstrate that that's true. You can't use it the other way around and say, because I can't see the bottom of the boat, the Earth is most definitely a sphere and the surface is curving.
I can see the curvature, like hiding away the bottom part of the mountain. Like, isn't that enough?
No, you can't. No, all you're saying is you can't see the bottom of the mountain. You're declaring the reason why. You're declaring the reason why is because of curvature, but you haven't established that that curvature exists in the first instance for you be able to be able to declare it. Otherwise, you'll be
curvature in the
committing.
Picture. It's in front of the mountain. It's covering the bottom half of the mountain.
No, that doesn't mean it's curvature.
But what else is it? You can see clearly everything in the picture.
Bro, that's a burden of proof reversal fallacy. You must demonstrate the curvature exists in the first place.
You can see it in the picture, dude. Like,
you're affirming the consequent, bro. You're saying if the Earth is a sphere, I won't be able to see the bottom of that object at distance. I can't see the bottom of that object at distance. Therefore, the Earth is a sphere.
You can see
you haven't eliminated other potential reasons, like, for example, it being an optical effect, because you're more than willing to, to appeal to optical effects and distortion of light and things like that when it comes to observations made where it's not being blocked or you're not seeing the geometry.
But
when you are, you throw that out the window. You're going to ignore that part, But
how that? I mean, how the light effect would work only on the middle of the distance between you and the target object?
What example are you talking about exactly?
I've seen the picture of. Let me see the picture where they can see the picture where you can see the furthest point, like furthest documented point. Let me.
So all you can do is say that, well, it could be a reason why. Now you're going to have to test it to see if that is the reason, right?
I mean, it couldn't be the curvature of the Earth. By your logic, Earth is flat, so there's nothing in the middle that could obstruct. If it would be in the middle, it would be the curvature, right? So we can't say that.
What, like a wave? Is it over water?
Yeah, it couldn't be a hump. It couldn't be a hump between one point and the next because you're talking about a downward drop that is exponential from your point of view. Now, the way your vision works, right? The ground ramps up and the sky ramps down. That's just the way your vision works, right? So the point being, right, if you're going to claim that it's curvature, there has to be a literal geometric horizon that comports with the radius value, right? So that's what I'm saying.
Radius value? Oh, okay, yeah, I see.
If the alleged radius value, if the alleged radius value says at, like let's say at your observer height is 2 meters, right? So that means your geometric horizon is going to be at 3 miles, like just over 3 miles, right? So anything beyond that you wouldn't be able to see, and you might see things peaking up. Yes, you might see things that are taller than that peaking up. Yeah, but if you're going to bring up refraction, you have to show that light can make things appear beyond a solid, from behind a solid object, right? You would need to show that, so you'd be able to recreate the conditions. Say, okay, with this type of humidity at this temperature, light will bend around this object, right? We can prove it in a lab, right? If you can't show that light is going to bend and show things that are hidden by physical things, right? Which hasn't been shown, right? That's the thing. It hasn't been proven.
My point is, would you be ready to put aside the refraction and just accept that it might be different distance than expected, but nevertheless be a cutoff on the target object from the bottom half?
Hello, guys.
You have to look at different observations too, brother. Like if with the black swan, in for example, right? You have your oil rigs as distance demarcation markers, right? So they're marking the distance from the observer, right? You have one at 6 miles, you have another one at 9.41 miles, and then in the distance beyond that distance marker, that 9.41 mile distance marker from the observer, you see a horizon that's well beyond that, right? So knowing that the geometric horizon should be at 3.4 miles away from the observer's location, now you know that you're looking at something that has to be over 12 miles away, right? I mean, you could just even say it's at 9.41, it's over 9.41 miles away. Either way, you're looking at something that's 3 times further than what you're supposed to be seeing, right? So that would change your radius value. That would increase your radius value times 3, just right there with that one observation. But the fact that you're not seeing any drop over distance there, right, should lead you to believe that you're not even on a ball of any size, right? You can't have light bending at all of those different distances from your point of view, just to trick you into thinking the Earth is flat. I mean, like how illogical does that seem? That light just does that just to trick you into thinking you're on a flat Earth.
Clarify. Like, I'm interested. Would you be able to accept the refraction over distance? Like, it would change the actual distance between like visible part of the target, because like if you count out the refraction, the distance doesn't add up, right? Would you? Well, bro, would you be?
There's nothing to do with anything when you can measure it to be flat. So you're seeing has nothing to do with anything if you're moving across something and measuring it over a great distance. Those measurements are solid state.
And even so, refraction makes you see less anyways. It doesn't make you see more.
Make you see what?
Refraction causes you to see. Refraction causes you to see less. It's a distortion.
No, it distorts the image, but it shows image at the point where beyond refraction you wouldn't see it.
Yeah, but refraction's not going to lift things up beyond a curve so you can see it. Is what we're trying to say.
It's actually
right, because
for example,
we're talking about distance to the horizon, right?
Like,
yeah, because you're claiming. Think about this.
Yeah,
Mr. Stark, think about this. Like, if that was a type of technology, right? If there was a condition that you could create to make you see around solid objects, you don't think that this would have been exploited by now technologically? Like, somebody would have used this in some type of device and been looking around corners. You know what I mean? Oh, I could look around this corner. I could see what's over that mountain.
You cannot make that portable, though. You cannot make it portable, though. You can see behind objects. Like, for example, take a look at this. I don't know if I can share the pictures here. Take a look at this example from the pool.
That's what you're saying, dude. Go in the Earth curvature calculator. Put in how much curvature there should be after 56 miles. And then tell me that that's not what you're saying. Tell me that's not what you're saying, though. You're saying that we can see something that's hiding behind a physical barrier. That's what you're saying.
Yeah.
Okay. If you're gonna listen, if you're gonna claim refraction, then prove to us that refraction lets you see around objects.
What do you mean round objects? What does the shape of the object matter? It can be any shape.
Well, you're telling us that refraction is allowing us to see beyond the curve of Earth. So prove that refraction allows you to see around physical objects.
Yeah, if you open the image I sent you.
What I'm saying is, if you're gonna say, okay, at this specific temperature with this specific humidity, right? You have these specifics, and at this distance on the other side of that hill, if we create this conditions, right? We create the temperature, we create the humidity level. We're going to be able to see that person hiding on the other side of that hill. Like, that's what you're saying. You're saying, like, with certain conditions, we'll be able to do it.
There's an example. Just take a look at the picture.
Yeah, you're just showing us a picture. You're showing a picture. So what? That doesn't prove anything.
It's an example of refraction.
It's not analogous. This is water, glass, and air. You're showing us.
Refraction is the traversing of
one single medium, bro.
Huh?
You'd only have one medium out looking across the water. Your air, that's it, just air, and there's no glass and water out there.
Yeah, where's your glass
densities of air?
Yeah, but that's not a glass container where light is bending through it. That's just air. Prove that air does that.
Need a container. It needs a different medium or medium with different density.
Okay, prove that. Give us a citation. Show us a citation where it states that.
Let me Google it. But I don't know if you're gonna believe to the Google.
Oh my gosh, brother! You're talking about several different things here. We're talking about it would require you to be able to see beyond a physical barrier, not an optical illusion barrier, right? So because of the way your eyes work, and I was trying to explain this to you, the ground appears to ramp up and the sky appears to ramp down. Now, in reality, it's still level, okay? That's the way our vision works. It's the way cameras work. It's the way video cameras work. Everything that we perceive appears to be ramping up and ramping down towards the convergence point, towards the vanishing point, right? So this is the issue. You have this compression. You have this compression.
It really seems like you're shifting the goalpost, guys.
No, we're not shifting the goalposts. Think about this.
It actually kind of seems like you do. I don't want to be rude, but
think about this. On a foggy day, you can't see very far, right? You can't see very far on a foggy day. That's correct.
Yeah.
Okay. So on a clear day, when there's very little humidity, very little vapor in the air, you see further, right? That you can't see, there wouldn't be more refraction under those conditions. There would be less refraction under those conditions. Do you not agree? There's less in the air, correct?
When it's foggy?
No, I said I said on a foggy day, you can't see very far, right? But on a clear day where it's cool and there's not a lot of humidity in the air, you can see further. Those are the times where you can see the farthest. And during those times, there's going to be very little refraction, if none, happening. And that's when we have our record observations, is on those days where there wouldn't be any miraging effects happening. There wouldn't be all of these claimed things that people are saying is bending light upwards to make us see further. And
refraction doesn't necessarily requires muddy like air and in clear
it requires mediums. It requires stuff in the air for the light to interact with, does it not?
It requires it requires medium with a different density. The water can be completely clear, right?
No, you're wrong. Do you got the citation that says that it requires different densities of air? Show that citation that says that.
Okay, before going there, just on the point that you're moving goalpost. Initially, I said that refraction is allowing you to see.
See what? Hello?
Hello.
Mic check.
I can hear you.
What's happening?
Good. I don't know. Maybe he's just looking something up real quick, or he's changing his batteries. Anyway, just for the audience,
you can see.
We didn't hear a lot of what you said, bro.
You didn't.
Yeah, you cut out, man.
No, you cut out for like 2 minutes or something.
Yeah, we couldn't hear you. That's why we kept asking.
Is this better? Is this better?
Yeah, we can hear you now.
Oh, that's great. My point is that my initial statement was that because of the refraction, according to some people, you can see objects behind the cover, for example, behind the horizon. And you said provide like something, evidence that you can see objects behind cover using refraction. I've sent you a photo where you clearly can see that example, that the bottom half of the man body is like a meter away from him. And if you cover the like bottom half of the man in front of you, you still can see, because the actual refraction makes him like a meter to the left. Afterwards, you said like that the atmosphere is not does not made of glass and water. So that's a kind of moving goalpost, because initial question was how can we see objects behind the cover using refraction? Are you convinced that you can see objects behind the cover with refraction?
No, bro. No. No, the claim is of geometry, right? So distance to the horizon, or a specific rate of curvature. That needs to be justified in the first instance before you can say that it's responsible for anything.
No, without like Earth curvature, like not speaking about Earth, are you convinced that at all refractions in general can make you see objects that are covered directly, but when there's a refraction, you can see them beside the cover?
No. See, because we've got examples where the thing that's supposed to be blocking the objects is behind the objects. So you need to demonstrate refraction can do that for a start. Like put a mountain behind the building that it's supposed to be blocking from view.
Again, I'm talking in general regarding refractions without like Earth.
Yeah, me too.
Or like you're saying about mountains.
If there's a building,
a pool, right? You have seen
yeah, bro.
You can clearly see that the image is shifted like a meter away.
Yeah, it's not going to isolate the object. It's not going to isolate the object, bro. It's going to move everything.
Yeah, but
right?
But you know where the object actually is, right? It's not where the refraction is showing you, right?
Yeah, and all I'm saying is that if you're claiming that light distortion is responsible for allowing you to see around the curve, then show us the curve exists in the first instance.
You can see in the images when the bottom half of tall objects are being cut off by the Earth in front of them.
No, you need to demonstrate the curvature of the Earth is responsible for that. You can't just declare it's the case. You've got a possible. You've got a reason, right? You've found a potential reason why you can't see the bottom of something at distance, right? You haven't demonstrated it to be true yet.
You can see the curvature in front of that. I really don't get.
You cannot. You see a flat surface. A flat surface. It does not look curved, right? You can't see the bottom of something. Okay, demonstrate the reason for that is because the surface of the Earth is curving.
Okay, let's try to demonstrate that logically.
Well, hold on. Second of all, you can make objects disappear from the bottom up on flat surfaces. So your curve doesn't even... Yeah, refraction is two different mediums, two isotropic media. You do not have two isotropic media.
We do not have, or we do have.
The atmosphere is not two separate isotropic mediums.
So how would you get bottom half of the object disappear on the flat Earth?
Because it's an optical illusion.
What kind
it's a
of
mirage.
Illusion?
There's Fata Morgana. There's all kinds of optical illusions.
So how it works? Like, why is the bottom half is invisible?
For a start, like, you've got minimal angle of view with distance, right? Okay, so the less
minimal angle of view.
Yes, so angular resolution. So with distance, you're going to be able to resolve less, particularly when it's meeting a surface and it's got so far away from you, you won't be able to distinguish the difference between the bottom of something and the surface that it's touching, right? Like a brick, just a single brick, if you extended it out along a horizontal plane far enough away, right, you are not going to be able to make out the difference between that brick and the surface it's sitting on. It will blend together. You won't be able to see the brick. It's too small for your eyes to resolve.
Yeah,
right?
But it's clearly large enough to cover entire bottom half of the mountain, right? If you can clearly see the edge of the top half, and you cannot see the bottom half at all.
Okay. It's just one reason, right?
Okay.
And then you've got other things that, like, was brought up by John. So, but this is a burden of proof reversal. You need to demonstrate your claim.
I don't want to put the burden of proof on you. Let me ask you an experiment. Would you be convinced with that experiment? If I take a strong laser, right, and put it on somewhere on the lake, and the other half of the lake, I would put a cardboard. So basically, if the Earth is flat, the laser pointer should be at the same height on the cardboard as the laser pointer itself, right? On the flat Earth.
Yeah, I'm sure that DJ presented to you examples of this earlier, right? Where people have taken lasers to lakes, right, and shot them across the lake.
We have hundreds. We have hundreds of proofs of lasers going across 20, 30, 40 miles and hitting its target.
I've seen the one where it didn't work. Could you please send me an example where it works? Because I've seen one where it didn't work.
You've seen a Netflix mockumentary, is what you see.
No, dude. I've seen it on the YouTube, and it was an experiment by people who were trying to do the same as I'm going to do. Like, will it convince you if the pointer, like the laser dot, is not at the same height as the pointer? Or is there any explanation why it shouldn't be there?
No, we have on our home Discord, 24/7 Flat Earth Discord, there's sections where we have laser tests. Like I said, anywhere from 5 miles up to 42 miles, I think it is, on frozen lakes, on regular lakes during the nighttime, with infrared, with different colored lasers, so you're kind of separating out the refraction. They even take the temperature of the air, so you know what temperature it's at each level. So you can't really claim refraction. You can, but it's kind of accounted for. But there's plenty of evidence for that on the home server if you want to go look at it.
Well, I just posted one for you, right? It's 21 miles across the Great Salt Lake in Utah. Okay, so the guy set up his tripod and his camera at 5 foot, I think, at the edge of the lake, and for his camera, and his friend was on the other side with a laser at 5 foot, and it hits the target, it hits the camera, right? Not only to mention that, but during the daytime, because that was done at night, and during the daytime, he took photography. You can watch the film, and you'll see that he's just zooming in across to the other side of the lake. Right at 5 foot, there should be a horizon distance of about 2.6 miles to the horizon, beyond which anything behind that point will become obstructed from view. You see straight across to the shoreline on the other side, right? There's nothing. There's no horizon there blocking it. There's no hump of water in between. It's a really good example. Old Dude's posted another one there for you, done by a group called FE Core. I think that was 40 kilometers. Those guys set up a very expensive laser system, detecting no deviation between the line of the laser and the surface of the water. Yeah, but like John said, we can direct you to the home server where we've got a channel fully dedicated to laser tests. Plus, there's long distance observations that are made.
So just saying it not enough, because I've seen examples where it didn't work, so I have to try it for myself. I just want to see if I have a good distance to try to do that experiment and get good equipment.
Can you post the video that shows that then, what you're saying? Post that video in chat.
Okay, let me just find it and send it to you.
Yeah, thank you. I'd like to see that.
Ich bin tot.
I think it was this one.
Yeah, so that mockumentary was very vague about that, right?
Yeah,
and you don't know the full story.
The Jaren video.
Yeah, so that wasn't even a laser that they used. their laser broke, and he decided to use a flashlight, right?
So does flashlight any worse than laser? If you can see.
Yeah, especially through an aperture up close, you're gonna have information loss and diffraction, right?
Well, and the fact is that when he did put the flashlight through the hole, he would have had to have been 23 feet tall, anyways. So that debunks you right there.
Right. It's not on the same spot. It should be on the same height, right?
No, and the diagram is just so just stupid because it's not supposed to be a hump in the middle that they're detecting. It's a drop over distance that they're supposed to be detecting.
It's not hump in the middle, like there's nothing covering it. It's just not at the same height. The hole is not at the same height.
But do you understand? Do you understand that's a flashlight? He's shining a flashlight through the hole. Do you know what light does from a flashlight? It cones out in direction. It's not accumulated like a laser.
You know that laser is also dispersing over the distance, right?
Right. If there was no hump in the middle, right, like you said, right, then it wouldn't matter which hole he shone it through. As long as you angled the light towards the target, you'd see it. So it wouldn't matter. He held it above the whole cardboard thing or through any hole of it. All right.
Could you please repeat? I don't get what did you say?
Because it's okay. Why couldn't he see the light?
Because the cardboards are on the different distance, on the different heights.
No, bro. Look, so you're saying when he lifted it up, it was at the same level as the target?
Yep.
No, that should be dropped down and away from him.
What do you mean drop down? If your
light is level,
down, the way you
right?
say.
Okay. Do you know what a tangent plane is? Do you know what a tangent plane is?
I have to press my space bar just in case, because I know what a tangent is to a curvature. Yeah, of course.
Right. So you can imagine that light is a tangent plane, right? So it's extending out in a straight line.
No, it's not.
No?
It might be tangent to a middle point, but it won't be tangent.
So you see, this is what you're going with the diagram now, and you're saying there's a hump in the middle. If you're on a sphere and you establish something as vertical, it's not going to have and then you have another one on the other side that's vertical, right? And then you shine a laser through the hole of that thing, it's going to go up and away from that thing. It's not going to go towards the target. It's going to go at an angle into the air.
Both grown men, right? You know what a tangent is. So tangent should be a relative to 2 points on the curvature. So when you say this line is tangent to what point of the Earth?
Underneath. Exactly. Underneath the point where it's
which point?
The source.
Source and the receiver.
So the target would be below the line of sight.
No, it should be above.
No, if the light was level, right, and it's being emanated from a tangent point, then the target will be below the line of sight. You would have to angle the light down towards the target.
Okay. Let me just, I don't know, can I? Can you hear me? I'm forgetting to press my space bar. Let's do a small experiment, right?
So
the avatars have round borders, right, for everyone. let's choose an avatar that has a high contrast, like the Musox 2. It has a really nice white border on it, right? Let's do the same experiment and see that you have to put it higher, right? So let's start at the top part of the sphere of this Musox 2, right? Let's say you're shining a light to the right. The light is tangential to the top part of the sphere, right? Are you agreeing that the light is tangential to the top pixel of the sphere?
Yeah, okay. Yeah.
Okay, so imagine if the Earth is round and you're standing 90 degrees below, right? I mean, it's of course it's too much. You won't see it. Let's say like 5 degrees to the right. You're standing. If you're standing, like up for you is a line to the center of the sphere, right? When you're holding something up, it's not directly to the north on this picture, but from the center of this circle, right? Are you agreeing with that? So if you put a light to the right, which is direct line, would you have to put something up to reach that line or down to reach that line? T-Dub, can you hear me? Can anybody hear me, guys?
Yeah, we can hear you.
Yeah.
So would it be up or down?
I'm not sure I understand what you mean, bro. Seriously. I don't.
Okay.
But who cares about the stupid video that you sent of Jaren? There's hundreds of them.
Simple geometry. It's definitely, maybe you're against the curvatures, but it's definitely should be getting up to reach the light, not down.
Well, anywhere if you got a laser, listen, if you got a laser that's shooting straight across on a globe, that light is going to be up in the air. You would have to angle the light down in order to get to the hole. If you shoot it straight,
the target, or lift the target, not lift the light.
Of course, the target. We're speaking about target.
He lifted the light. He had to lift the light.
Lifted the light.
Okay, I thought you were talking about the target. Okay.
Yeah, that's what he was. That's where the confusion was. Yeah, I've been listening. I'm like, why is this not being conveyed properly or comprehended properly? Yeah, so you get it, right, Mr. Stark? Like from your position, 10 miles away from you, your target's going to be 66 feet below your point of view, right? So you would have to angle downward and go through some water, or if you're going over a lake,
he lifts it up, right? He lifts up, not down, the light.
That's right. That's right.
So this video is not good enough because it has a flashlight instead of laser, right?
Yeah, Jaren. Yeah, that guy. I mean, they had a laser, right, that they were going to perform that experiment with, and he broke it. I mean, the guy, yeah, I wouldn't want him around any of my equipment to do any tests.
He's a clown.
Yeah, that's why okay. So that's why I want to do the same experiment myself.
With the proper laser. That would be cool. I'd love to see the video.
Yeah, I don't think that
clown it
you
up
need
like
a laser,
Jaren
but yeah. I mean, there's you don't have to go that far away, like 42 miles or shit like that. if you can prove the same thing on the smaller distances, it's the same thing, because if there's a curvature in the smaller distances, it should be even more curvature on the larger distances. Wouldn't you agree?
Yeah, I mean, you do it 3.5 miles, 4 miles, I mean, you're going to be able to, you should be able to measure drop over distance if you're on a sphere, right? If you're on a globe, it's got to be there. So
yeah, they did an experiment like that with a boat and a flag back in the 1800s. It was called the Bedford Levels experiment.
But Mr. Stark, you could also use mirrors. You and a friend could get on two sides of a lake. You know what I mean, with mirrors and flash the sun's light across a mirror. Across the lake using a mirror.
That kind of wouldn't work because of the refraction, because sun comes above the atmosphere. But if you use a light source below the atmosphere, I'm not sure, but I think it should
think about it.
minimize minimize the refraction.
Think about this. Think about this real quick. So if you're on one side of the lake, right, and the lake, let's just say the lake's 6 miles across. Okay, you're on one side of the lake, your friend's on the other side of the lake. You should not be able to see that mirror flash. Does that make sense? Especially if he's like on his knees on the ground with the mirror, and it's a small mirror. You wouldn't be able to see that mirror flash. Do you agree?
I don't really get how you should level the mirror to get exactly like tangential line to your location. It's kind of hard to do with a mirror, don't you think? To get a straight line.
If he's got that mirror like less than 12 inches from the surface of the lake, and you see that, you don't see the problem there? You don't think that if the Earth was a globe, you'd be able to see that mirror flash?
The point is to flash the sun to somebody, you have to pick up a particular angle. How would you ensure that the angle is straight line?
You move the mirror around until you see the flash. You wouldn't be able to see a flash from the mirror, period. And if you see one, you say, "Oh, okay." That's what I mean. It's like you have to devise the observation, knowing where each one of you are going to be relative to one another. Okay, you say, "Okay, I'm going to be here. You go all the way over there, and then you aim towards me." I just said round about 6 miles.
I have to constantly convert to kilometers. Let me just.
Oh, sorry about that.
So at 6 miles, you shouldn't see the mirror at the ground level. You said, was it on the ground level?
Yeah, like you could go 12 inches off the ground. You could go 2 feet off the ground. I mean, anywhere in that neighborhood, you're at 1 foot. Your geometric horizon should be 1.22 miles away. So
if you get further away, is there any point where the light disappears? Did anybody try to do that?
Depends on the day's conditions. It really does. If it's a foggy day, light's not going to travel very far, right? So
yeah, light attenuates in a medium.
Yeah. Okay. But on the clear day, did anybody try to get further away instead of like confirming the actual number they are expecting to be debunked? Like, is there any like one who did the experiment, debunked the actual number, and tried to go further back away just in case to see if it's like disappearing behind the horizon? But maybe the people who did the math on the curvature are wrong. Maybe the formula is missing something. Have anybody tried to go further away? I don't know. And I really don't know why would you use mirrors if you can use lasers, like.
Powerful lasers, like, powerful
No, I mean,
lasers
if you can see the
expensive.
reflection of the sun from the mirror, I mean, you don't need that.
I'm just saying it's cheap. It's a cheap way. It's a cheap way of doing it if you can't afford a mirror. I mean, if you can't afford a laser, that's powerful enough to not spread out, to keep a really focused beam. You know what I mean?
Let me see how long it can shoot.
What did you need, Mr. Stark?
Hmm?
Did you need something? Were you wanting to ask something?
What do you mean?
Oh, I thought you were trying to ask someone something and nobody was responding.
No, not at all.
No, we were just talking about
what kind of laser I need to get, like how long it's gonna go in the atmosphere.
Yeah, we were just talking about laser tests.
Right on.
And yeah.
Yeah, we highly encourage it, man. Like if you do something and you happen to document it and you find some abnormal findings or whatever, anything that you document, we'd love to hear about it and have a conversation about it.
Yes.
Like I know my observation is.
Actually, the videos I've shown, like sent to the group, that stated the opposite of what is expected as an outcome in the flat Earth, not model, but ideology. They say like this person is stupid, this experiment is not clean, like I don't believe this. Like usually if I get something that contradicts what people believe, most likely they would accept that, but just ignore it.
Well, here's the thing about here's the thing about the globe. The globe is the thing that's in contention, right? So when you point to the planets or you point to gravity, you point to all these other things except for the curvature of the Earth, you're now begging the question on everything else.
No, I'm talking about the curvature, dude.
Yeah, no. But as far as curvature tests and everything, all you need to do is have something that makes a tangent over the surface, and then you just go out and look for the deviation from the tangent.
Yeah, and when I show videos that have different outcomes than expected in flat Earth ideology, people usually dismiss those videos saying it's not good, something's wrong, the person is stupid or something like that.
What do you mean? Like, I'm curious as to like here's the weird thing about it, right? Whenever
he's referring to Jaren Sheepdog. He's referring to Jaren.
There's a great word that I heard a couple of times here today. I don't remember exactly how you say that, guys. Fakementary? Did you say fakementary?
Oh, mockumentary.
Mockumentary.
Oh, you're talking about the behind the curve.
Yeah, that's what he's talking
Sorry about
the YouTube.
So here's the weird thing, right? They wouldn't release all of the videos that were taken there. They took the videos that they had. So I'll give you a summary of what happened in this thing, but the video that I gave you, thank you, Bob, explains everything.
I really watched it. I really, dude. I really watched it.
You didn't have to watch it. It was just more of a listen.
Huh?
It was more of an audio, more of a listen than anything else.
Yeah, but I've seen the video. Like, it's a video. I cannot say I've listened to it. I've watched it.
Right.
I didn't
What,
close
the
video.
documentary, or are you talking about, or the
I'm
or the
talking
other
about
guy?
the explanation. I'm talking about 10-minute explanation why, like, they didn't let him. I mean, at the point, that person didn't have anything to say back. He later came up with ether to explain why the light rotates, right? And it's kind of.
You're looking way past the point, man. Like, you're looking for some kind of a draw to pull on, so you can say, "Look, it doesn't work." All we're trying to show you in that video is that what happened is a film crew had contacted some flat earthers, said, "Hey, would you like to do a flat earth documentary?" They said, "Yeah." Well, in order to get the budget that they wanted, they had to the flat earthers had to sign off on all of the creative rights of all the video editing that occurred in this documentary. What that meant was, when the filming was done, they had no say-so in how it was edited for the final cut. And what ended up happening is did you actually watch the whole documentary, or did you just watch the piece
I've
that
never
disproved
seen
the
the
letter?
documentary. I've watched the explanation why the documentary.
Watch the documentary, because really what happens is they go through all these conversations and everything like that. It's real interesting. But at the end, you see this failed observation that may look like curvature of the Earth, but I'll tell you why it's not curvature of the Earth in just a moment. But it's a failed observation. It looks like it may be curvature of the Earth, and then you hear one of the flat earthers say, "That's interesting," and then it ends. Right?
Yeah, in the explanation, the dude said that he didn't have an answer at that moment. It's not like they cut on the answer and left the answer behind. The person, the Bob or whoever he is, said that he didn't have an explanation at the moment. He was perplexed, and then later he did experiments and came up with.
He didn't understand certain things. He didn't understand certain things. He didn't know that there was a Sagnac effect. He didn't know that there was a lot of other things going on that he knew later on once he did a little bit more research. So they went into this observation, this hunt, very unprepared, because they didn't really know what they were doing. Have you ever gone out to, like, prepare for something, and then when you go out to actually do it, you realize you spend the entire day trying to set up for one perfect piece, but it takes the whole day to do it because you don't know what you're doing?
Yeah, it happens.
Right. So that's kind of really what happened in this documentary. And every time I say documentary, imagine air quotation marks going on, okay? So what happened is they went out unprepared. They learned a lot. They learned a lot of things in the process. I give you an example. The guy who was running the ring laser gyroscope, or actually the fiber optic gyroscope, he every time he starts it up, he's supposed to calibrate it. He doesn't calibrate it. He doesn't do what he's supposed to do every time he sets it up. And so that's a fail on his part right there. So they're already getting all kinds of weird readings right off the bat.
The issue is just to negate the observation, just to do that, to invent ether, to explain that, and then how would you even prove that ether exists? It's kind of ridiculous. That dude doesn't say the readings were wrong, right? That dude doesn't say they were, like, wrong in doing, like, equipment was broken or the readings were wrong. It says there is a rotation, but it's not the Earth, it's the ether. Like, do you imagine light squiggles around while
that's not what he said.
I watched the video the guy sent me.
I know you watched it, but you're misunderstanding, misrepresenting what he said.
How can I misunderstand? He gave a.
Do you know anything about the Sagnac effect? Do you know what the Sagnac effect is?
Sagnac?
Sagnac. Sagnac.
No.
It's actually pronounced Sagnac.
No.
I say Sagnac so you can hear the letters.
No, I don't know. Let me just quickly
go right. So that is part of the reason why they had the issue with the fiber optic gyroscope that they were using in one of the observations, because it was two observations, right? They were looking for the spin of the Earth and they were looking for the curve of the Earth, right? And so when they were doing this fiber optic gyroscope, the guy that was running it incorrectly, number one. So the whole entire thing was bugged. Then when they go and do the curvature observation, what they don't show you is they got a null result for both the flat Earth and the globe. And instead of saying that, because they did the globe first and they got a null result. And then when they did the flat Earth one, they got a null result. And Jaron was like, "That's interesting."
I didn't watch the documentary. I didn't watch it. I watched the explanation. And in the explanation, the dude said there is a rotation and there's a two explanation. Either the Earth is rotating or the light are rotating. So how we know it's not the Earth? Because it's an ether. It's basically what he said. He's explaining the rotation by something called ether that swirls around the light, like in
Why are you hanging up on this?
He said that the reason we know it's not the Earth is because it's inconsistent with the Earth. Because if it was the Earth rotating and it was actually moving based on the Earth rotating, it would be consistent, and it was inconsistent.
Okay, so it's
inconsistent. Do you know why it was inconsistent?
With what it's consistent?
What was the measurement that they got?
15 degree.
No. That's the answer you need to get Earth rotation, but that's not what they got.
Yeah, if they got 15 degrees an hour,
basically
then
stating he has from Pikes Mountain 15 degrees per hour. He's just stating in the video he got that reading, dude. I'm not lying to you. I'm saying what's in the
I understand. We know you're not lying, but if he got 15 degrees an hour, he'd have to be at one of the poles.
They got different readings, and whenever they went to different altitudes, they got different readings from the other altitude readings.
Exactly.
They got as high as like 20s. They got as low as less than 10, and then it was all inconsistent. And they took a bunch of readings.
So why is that?
You tell me. It's not Earth rotation, because if it was Earth rotation, it would be consistent.
So
because it would be directly sensing the Earth in motion, which is supposed to be consistent because you're attached to the ground, and relative to the ground, you're moving with the ground.
Yeah, the Earth isn't speeding up and slowing down, bud.
Okay, let's say the Earth is constant, then what's moving? Is it the ether? Do you agree with ether theory?
Nobody knows. It could have been a machine malfunction because the guy wasn't operating it correctly.
No, dude. They did experiment later, more again and again and again. They did it.
So how do you know the machine was operated correctly, Mr. Stark?
I said they did it correctly afterwards.
That's what I heard that bit. I heard that bit exceptionally clearly. I want to know how you personally know that it was operated correctly.
Because the person, assumably...
Because it gave the answer that you want to hear?
No, because they stated...
Affirming the consequent, perhaps, my friend?
Dude, because the person who you think is right stated that the readings were different. And if they're stupid, if they do it...
So if the readings were different, that means it's inaccurate. Therefore, your answer is null. It has failed.
Do you know what you're talking about? Do you know what we are talking about? What's the issue?
So the problem you've got, Mr. Stark, is you're trying to focus on one particular aspect. Hey, look, I think it rotates because these guys did a laser gyroscope test. You've still got a very important problem that you need to get yourself around, is that there is zero measured curvature.
Dude, I don't know. You just bought in to argue or what?
Yeah, the problem is you're rolling on about stuff that's non-sequitur to the shape of the ground.
Are you saying there's an error in the measurement, or are you saying there isn't?
You're the one that said it. You said that it gives off different readings. It would be consistent.
So are you
perhaps you should start listening to some of the other chats?
Hey, Matrix, why don't we
what's your point here? I said that the person in the video said that there's different readings. So are you saying how do I know if the measurements were accurate? So either the person is really not good with this technology, which should like it's not a
You made the claim quite clear that he is operating the machinery perfectly. And my question to you still stands: how do you personally know?
Matrix, here's the thing, all right? We know far more now, several years later, about interferometry than we did back then. And you're just going to have to chalk it up as an error because there were too many factors that were unaccounted for in that observation.
I don't know if it's clear.
Mr. Stark,
I don't know if it's accurate.
Mr. Stark, let me explain to you what else happened in the video. Because there was far more that happened in that conversation than you're letting me continue on because you're hung up on the 15 degrees per hour that happened like once or twice out of like 15 observations. So what happened?
This dude asked me a question. I tried to answer his.
What happened?
How do I know if it's
what happened in this? What happened in this video? What happened in this video is so when it was all said and done, they made this documentary and it completely shat on the flat earth, making them look stupid. Well, these flat earthers ran into the producers, I think in North Carolina, and they had a conversation with the producers, say, hey, what gives, man? We want the rest of the footage because you're not giving the whole story. Their answer was because children were going to watch this documentary, they couldn't have little kids growing up questioning whether or not the earth was a globe. There was too many good arguments for them in that documentary for them to allow anything unbiased to occur. So they made it biased.
I see. Do you think that the video the guys sent me, the Thank You Ben one, that happened after the documentary and that the person did by himself a couple of times, a lot of times, as he said, on the different locations? Do you think that measurements are accurate? Because this person asked me a couple of times, and I don't know, like, why would he like even put into consideration if it's accurate? If not,
how many measurements did he make?
More than 5.
More than 5. Okay, how many of them measured 15 degrees per hour?
I don't know. I don't even care about 15 degrees per hour.
Okay, well then what's your point?
My point is, what is rotating if not the Earth?
What is rotating if not the Earth? I don't know. It could be an internal malfunction of the machine. I don't know the entirety of that machine. That machine has all kinds of errors anyway. It has to be recalibrated every hour.
But none of them showed 0 all of the time. Do you think every time they did it, he said like he stated
it could have just drifted, man. It could have just drifted.
Is anyone able to give me perms so that I can post the data?
So you don't believe in that?
You're a mod in here, dude.
I'll send it to you. I know, I'm a mod over in politics. I'm not over here. I had like a 10-month vacation.
I'll put it in. I don't know what it is, man. I don't know what it is.
Not that you don't know what it is. So you believe that video is not accurate? The explanation you sent me.
Real quick.
There is a hypothesis out there, Mr. Stark, that the ether may be a possibility, but that's neither here nor there. Because the idea that the ether, if the ether even exists, it permeates through everything. So you can't put your finger on it and wiggle it and say that's the independent variable right there. You can't poke a hole in it and separate it from the rest of itself.
I'm really don't getting it. So do you believe there's a rotation in that video, or don't you? Like, it's either rotation, if not, if there is a rotation, it's ether. If there isn't, it's malfunction of the devices.
Okay, do you know anything about Michelson Morley? Do you know anything about Michelson Morley?
About what? Could you write it down?
Michelson and Morley, the Michelson-Morley experiment.
The people who did disprove the ether, yeah.
They didn't disprove the ether.
They proved it?
No, they were looking for the motion of the Earth through the luminiferous ether. They assumed a stationary ether. They assumed the Earth was in motion, interferometry measures things in motion, and what they got was a null result when they were looking for 30 kilometers per second.
So does it mean that the Earth not moving or the ether is not real?
Well, instead of getting 30 kilometers per second, they got 4 to 6 kilometers per second, which is much slower and matches sidereal rotation.
So there is a rotation after all. It's not stationary.
It's in the sky, sidereal rotation. Like you see the stars move, right?
Yeah, but it's not the Earth. It's not the stars. It's the ether. It seems. I don't know. Like
you know what Einstein says about. You know what Einstein said after Michelson Morley and all these other observations that occurred trying to detect the motion of the Earth. Because even Aries was it George Airy? Have you ever heard of him? George Bedell Airy. He was looking for the spin of the Earth. He was using his telescope, and he made an observation of a star, and then poured water down his telescope to see if the star would refract into his telescope. This would have matched the spin of the Earth, and instead he got a complete failure. There was no motion.
In the video, I don't know if you think that this Ben is a smart person or not, if he's accurate with the equipment or not.
George Bedell Airy?
The video.
George Bedell Airy?
Thank you, Ben.
Yeah, read the GIF in the chat, and just plain and simple, it's the sky moves, not the Earth. That's the end of the story right there.
Yeah, you can't prove any motion of the Earth from the Earth. And all observations from Edwin Hubble, he says all observations look like the Earth is the center of the universe.
They just what?
So all observations appear to make Earth the center of the universe.
Because at any point it would be a center, because it stretches out from all points uniformly. Okay, this Thank You Bob video you've sent me. Do you believe that Bob is a smart person? Do you believe he's accurate? Do you believe his measurements are accurate?
He was a smart person. He died a few years ago.
God, I don't know, God bless him, or how would you say that? Let his soul be in peace, okay? But my point is that person clearly states how the rotation is happening. And for that, he's bringing up ether, which is replacing electromagnetic space. So he says like electromagnetic waves travel to ether and ether rotates. And if ether rotates, why the rest of the lines?
And I'm not going to get into the ether conversation with you in this chat. If you want to have an ether conversation somewhere else, we can go somewhere else and have that conversation. But I promise you, it's just going to leave you with more questions than answers.
You've sent me a video where the explanation of the rotation is the ether. That's why I'm asking.
Right.
You said,
like I said, we can have the ether conversation somewhere else.
So I sent you the data in your DM, dog.
All right, hold on. So I want to say this, okay? The whole point of the video is to explain how they took all the data from the videos that they took and everything, and they edited the video to make Flat Earth look stupid. Even the name of the documentary was to make Flat Earth stupid, because the idea that somebody is behind the curve means that they're not quite up with the rest of the class. Is it me that's busting out, or somebody else busting out?
Somebody else.
Yeah, you know what? You're confirming everything that I thought. Because towards the end of his life, before he passed, not that he was dying in the process, but when he was making these observations and learning about it, if you look, the average was all consistent with the Sagnac effect. And so you're just confirming everything I already knew, Tactical Droid. Matter of fact, you know what? No, I can't do that. Not until after you make your observations, Mr. Stark.
We got some new people. We got some new people in the chat. If anybody wants to jump in after Stark is done.
I was just going to say, Mr. Stark, once you make your observations over water and you've got your measured your measurements and everything like that, then we can have a conversation about the ether, and I'll introduce you to another part of Discord. But right now, you need to stay focused on the actual measurements of the curvature of the Earth.
Is that the only way to prove that Earth is curved?
Is that the only way? Yeah. You wanna actually look at the surface of the Earth. You don't need to
really
go millions of miles away.
Is it the only way, actually?
Yeah, it's the only way.
What other way is there?
Because all you have is the circumference of a circle, right? You're on the surface. If you want another way to try and derive the radius value of the Earth, and you either need to dig all the way through, get the diameter, and then divide that by 2 to get your radius value. So, yeah, all you have is circumference, arc measurement.
Yeah, you can do that, but if it's really big, it can be really hard, right? So there are other methods that you can see that it's a globe, rather than just
Mr. Stark.
Take
Mr. Stark, if you went out and made an observation, right, and there was no measurable curvature, what would that tell you?
Either the Earth is flat, either it's too big, or either my measurements are not accurate.
Okay. So
3 options from the top of my head.
Okay, 3 options off the top of your head. So then you would double check your measurements to make sure they're accurate, right? Measure twice, cut once.
I would do to the best of my abilities, but as I'm not a scientist, it might still be not enough.
Well, you don't have to be a scientist to make a measurement, man.
You don't have to, but it might not be accurate if you're not.
You don't have to be a scientist. Dude, if I hand you a 2x4 that's 8 feet long, tell you to cut me 3 feet, are you going to go get a scientist?
If you're going to use specialized equipment to do that measurement, it's important that you know how to use that specialized equipment.
You're hot micing Tactical. I don't know if that was so intentional. I put your images in the chat, just so you know, Tactical. Okay, so the other 2 options is that either it's flat or it's bigger than we thought, right?
It's bigger than the calculation shows.
Okay. So if it's bigger than that, then that means we don't have an accurate distance to our satellites anymore, right? Because the satellites are orbiting our Earth that is 3,959 miles in radius.
If it's bigger, it means that if the curve is further away, it means that the formula that I used to calculate how far should the horizon be is not what.
Okay, well that's based off of a globe of 3,959 miles. If you want, I'll even put in the chat the NASA protocol and data sheet for all the specifics of the Earth, because NASA's done all these measurements for you. So all you got to do is go and check and verify that.
So I would be grateful if you do that. In that case, let me ask you a question. So you saw three options that I have, right? I'm wondering about your options. I'm not that I'm very aware of the globe model, But on the globe, I can surely know that there's a North Pole and South Pole, right? So if I go to the South Pole, like to the Latin America, and look at the sky, I would see the same stars as if I would look at the, let's say, Australia, because they both, on the globe model, they both look to the south, and it's kind of normal when you see the same stuff when you look at the south. It's going to be reversed 180 degrees because you're looking from the opposite sides, but you're looking at the same thing. Same on the north, right? If you look from the opposite sides of the globe to the north, from the north part, you're going to see the same stars, right? And you're going to see completely different night view on the northern hemisphere and the southern hemisphere. So let's say the center is the north, right? It's not a disk. We don't know its shape, but north is in the center because let's just assume the north in the center. If the north in the center, south cannot be at the same place. On the flat surface, the south of the globe model cannot be on the same place. So basically, south on the flat plane that you don't know the shape of, we don't know, we cannot assume, are completely, the people on the Australian person and the Australian person in the Latin America are completely looking in the opposite directions. How can they see the same stars when they look at the opposite direction and not see the north part of the stars?
Right. So I'm going to explain a few things to you first. When you use the azimuthal equidistant map, you know which map I'm talking about, the Gleason map?
The what map?
The Gleason map, the azimuthal, the AE map.
Let me just Google it. I'm not quite sure what you're talking about.
Just Google Gleason map.
Okay. Okay, I see the map. So what about this?
Okay, so you're saying that in South Africa, South America, and Australia all see the same stars at the same time?
What do you mean same time? Yeah, they see the same night sky.
Right. No, they don't.
The people in the Australia don't see the same, and Latin America don't see the same constellations.
They see the same constellations, but not at the same time.
Okay, let's go with constellations. How they can see the same constellations and not see the constellations that are the North Pole? We're assuming that North Pole in the center. It could be vice versa, right? It could be South Pole in the center and North Pole on the sides. Doesn't change the fact.
I get it, man. You want this thing to be a circular disc because the sun and the moon move in a circuit. We don't know how the fuck the Earth works, right?
No. I'm not saying it's exactly circular, but at some point of the Earth must be the center, right?
The sun and the moon and the stars move in a circular circuit, right? That's what you're trying to straw man?
No, I'm not talking about sun and the moon. I'm talking about the constellations.
The stars, the sun, the moon, all the luminaries move in a circuit, right?
I don't think they move. What do you mean?
Okay, you have southern star trails and you have northern star trails, right?
Star trails? What do you mean by trails?
Oh my God, bro! Like you're trying to straw man this, and you don't even know what you're talking about.
Do you say star trails? What do you mean by trails?
Have you ever seen time lapse photography?
Yeah, I've seen, but I'm speaking about person looking, not a photography. There's no trails when you look at the sky, right? I'm speaking about person watching the sky.
Right. When you look south, things move in a circular pattern. When you look north, things move in a circular pattern. Is that what you're saying?
No, I'm not saying the movement. I'm not talking about the movement, dude. I'm talking about the constellation. Why people on the southern hemisphere see the same constellations. Not the movement of them, but the same constellations.
Right, because the sky moves.
I'm not talking about movement. How the sky moves? What do you mean?
When Australia sees the stars that they see, then the stars are over Australia. When South America sees the stars they see, then the stars are over South America. It's pretty simple, man.
So they cannot see it simultaneously.
They don't see them simultaneously.
So
there's always a piece. There's always a piece of daylight in the way. There's always a piece of daylight in the way.
Of course, but if you watch it for 8 hours, right, in the winter on the northern hemisphere, southern hemisphere, sorry, if you watch for 6 hours, for 8 hours, and part of that 8 hours should overlap, right, with the night time of the Latin America.
I'm not going to speak with hypotheticals with you. I'm going to show you a video for you to watch. It's a pilot flying. Hold on. Who is that?
So saying that the sky.
Hold on, Claudia. So, if you watch this video too late, Google just proved Earth is flat. So this pilot is flying from the northern hemisphere to the southern hemisphere, and you can see the night sky as he's flying south, and he shows you the difference of what it would look like if it was on a ball Earth, because Google Earth makes it look a certain way. But the way when he flies, it looks completely different. It's almost like he's flying to the stars and then they're coming into his view versus.
I will watch the video. I will watch the video. But
sorry,
during
I'm
the conversation, right?
Hold on, Claudia.
Okay.
So your take on that was that the night sky is moving, rotating, and at some time of day
So I don't know. I don't pretend to know what goes on in the southern hemisphere. I'm not from the southern hemisphere. I've never been to the southern hemisphere. My wife is from the southern hemisphere, and someday I might go down and live in South America, or retire down there or something like that. You know what I mean? But for now, I'm stuck with what I have up here. But I can't wait to go down there because then I'll get to see some of the observations that everybody's talking about. It's just this video right here doesn't line up with the story that
I will definitely
people.
You see, thank you, Bob. The video, I've watched it.
Yeah.
I'm not lying. When you send something,
I know you got stuck on the ether because ether makes people turn sideways a little bit because nobody can really prove the ether. But it was a known thing for over 5,000 years.
Yeah,
and then Einstein tried to get rid of it.
Field is kind of like a fall guy here. You should remove it and use ether instead of it. Yeah, but
you can't have an electric field without a background medium. So
not electric
neither
field,
here nor there.
Electromagnetic field, not electric.
You can't have a field. There's that thing that's gripping everything else, magnets and shit. When you have two magnets at a distance and they start pulling towards each other, if you put a magnet through a ferrocell cell. You see those lines? It needs a medium to create those fucking lines. And if you don't have a medium, then you have nothing. Huh?
Okay. Dude, so first thing that in your head, I get it. I just mentioned that I watched the video and I'm going to watch this one too. My point is, so first thing that will come to your head is that the night sky is rotating and partially it's available for the southern hemisphere and partially it's available for the northern hemisphere.
Right. And when you go around the Earth, what should happen is the stars should roll up over the Earth as you go over the Earth, right? But that's not what's shown when this pilot is flying. What's shown is he's just moving to another location, and it's almost like, have you ever seen like Christmas lights where they're like a whole bunch of them are like dangling overhead, and it looks like there's a bunch of stars above your head, but there's like hundreds of them, right? And then like as you move underneath them, others come to view and others get hidden as you move further away from them and things like that. That's kind of what's going on in this observation.
I will watch the video.
Now, what's happening with the stars? I gave you an example. Have you ever been in a large warehouse?
I've been in the large warehouse.
Okay, so being in a large warehouse or a large large store or something like that, when you look up, now you know there's no walls in between you and the other side of the store, but you're at one end of the store. You look up, you can see the ceiling above you, but you can't see the ceiling all the way down at the other end. You can't see the sky all the way down at the other end. I don't know how to explain this to you. I'm going to try to be as simple as possible. Do you know what a celestial sphere is?
Celestial sphere?
Yeah.
No.
All right. So when you look around you, you're looking through perspective all the time. You have no orthogonal observation. The only way you could truly have an orthogonal view is if you were like extremely far away. Even if you were up close, everything would still bend in your field of view around you, kind of like a 3D TV or a 3D mask or something like that.
I agree with you. We don't have we're looking through the perspective.
Right. Constantly. We have no other option. There's no way to take us out of perspective and give us a Euclidean observation. Right. So with that being said, that's why everything looks circular on maps when they draw those lines, and then they have circles and they're pieing off cities and things like that. It's because they're trying to piece together what perspective is giving them in their observation. So like a great example of an observation is take a string, all right, and then take a thumbtack and put it on one end of the string, and then take a pencil and tie it around the other end of the string, and then take that pencil, put the thumbtack down, like smash it into something or whatever, take that pencil, stretch that string all the way out. That is your direct line of sight. The very front end of your line of sight is the furthest you can see in any direction. Now, if you turn, you're gonna create an arc in your vision because that's your field of view, that's your perspective. So if you turn left, if you rotate, if you take that pencil and try to draw a straight line with the string all the way extended out, what's going to happen? You're going to draw a circle, right?
Yeah, because string is pulling back the pencil.
Right, but so that because of that, that's the physical representation of what your vision is doing. Your vision, you have your direct line of sight, and then you have your peripheral, which is not as strong as your direct line of sight. Correct?
Dude, like the perspective is a great thing to talk about, but like it doesn't, like you can't use the perspective to say that like constellation that people see on the southern hemisphere are not true or distorted.
You're only able to see the stars in your dome of vision, dude. You're not allowed to see the stars forever. You can't see forever and ever and ever and ever.
But those are enough. Those are enough. The stars
dome of your vision has
limitations. The stars you can see in your dome of the vision are the same in the Australia and the same in the Latin America. And your first thought, I gave you 3 explanations off the top of my head, one of which was that Earth is flat. So you gave me only one very strange explanation that the night sky is moving with the daily cycle. Like at some point of night, it's on the Australia side, on the other time, it's on the Latin America side. But the interesting thing is that the constellation on the North Pole doesn't change, that doesn't rotate, but the whole night sky is rotating. Don't you have any other explanation at the top of your head? Wouldn't you think
here, do you want me to give you one? Do you want me to give you one? I'll show you an example, but you're not going to like it.
That's at least more than one. That would be.
I can explain it to you all day long, but you're not going to like it because it doesn't.
I mean,
it rips away your globe idea.
I mean, more. I don't think I'm gonna hate it more than the rotating sky. Like everything is rotating.
Are we able to get another guest because he's been here 12 hours now? Still not talking about the ground and proving the ground has curvature.
No, I know. It's anything but the ground. Go ahead, introduce the other person. I don't have the
if you don't see,
I'm going to put the video. I'm going to put the video in the side chat. I'm going to put the video in the side chat for you to watch. Okay.
Hey guys, sorry that I have coughs like this.
What's your question, bud?
I found out that so I searched up Google and it said that Google said that but the Earth is not flat. It is an upright spheroid, which is a sphere that is slightly squashed at the poles.
Well, yeah, man. Have you ever seen curvature yourself, or does the Earth look really big and flat?
I think it really looks spheroid.
It really looks like a spheroid.
Yeah.
Yeah, is that from the images you saw online?
Yes, it's from
How
NASA.
old are you, dude? Full stop.
10.
How old are you, kid?
10 years old.
Oh no, you can't be here, man.
Oops, sorry.
I'm sorry. You can come back in 3 years.
Yeah, there's a age limit to that. I'm so sorry, Claudia.
Feel free to listen on YouTube.
Yeah, thanks.
Anyone else?
Yeah, good catch there, ET. I could have been.
Hey, that kid was more polite than half the people who come in here, so I appreciate that. I hope he comes back in 3 years, just not now. Sorry.
Yeah, sure. But that could have been could have gotten weird. Good stuff.
Yeah, I sent you a 40-second video, Mr. Stark, and it explains how the celestial dome works. I can send another one too.
I'll take a look if I have the time. Thanks.
Let me ask you something. How do you explain oh gosh, crepuscular rays on a globe?
I didn't hear you. Were you talking to me?
Yeah.
Could you repeat?
How do you explain crepuscular rays on a globe? Crepuscular sun rays.
The perspective you were mentioning about before.
Yeah, maybe coming at you, but like, what about when they're angling down off in front of you?
Yeah, the same thing. The perspective.
Well, let me show you a video here that explains more about what I'm talking about.
I can see the image in the chat.
Yeah, that's not perspective. I put a video to explain.
Dude, to be honest, honestly, people are not too happy for me, trying to find another way to explain that the Earth is globe. So it seems like so far the only reasonable explanation for most people would be direct measurement of the curvature of the Earth. Anything other than that is useless. So let's not talk about side effects like the stars and the rays, because it's not interesting to people. Usually it seems like, as far as I understand, people really need direct measurement of the curvature. So anything other than that wouldn't fly. So why bother?
Right. Because in order to prove the shape of the table, I would measure the table. If I wanted to prove if the table had a curve to it, I would measure the table. I wouldn't look at the ceiling fan. I wouldn't look at the kitchen cabinets. I wouldn't look at the paint on the walls. I would look at the table.
Mm-hmm.
Now, if you wanted to talk about the things that happen in the sky, if you want to talk about the things that happen in the sky, we could talk about the things that happen in the sky. But If you're going to ask us what's the cause of such things, we don't know. You don't know. Nobody knows.
I asked a specific person because he asked a hypothetical question to me. I gave him back one. I specifically asked Shipduck, and I didn't expect him to know the exact answer. I'm not saying that I know the right one, right? Because we're disagreeing. I'm saying I wanted to see his options. That's all.
Well, so here's the weird thing, right? Timeanddate.com never puts any of those locations in the southern hemisphere as having the same sky 24 hours, except for down by Antarctica, right?
What do you mean 24 hours?
24 hours at nighttime.
I'm not saying they're going to be the same 24 hours. I'm saying even if they are the same for 1 second, it's enough to not have explanation on a flat Earth. I'm not saying they should be the same during whole 24 hours. Even for 1 second, if the skies are the same, it's not working on the flat model.
There's no flat model. That's what I don't have an explanation for it.
Usually, yeah. I'm not saying that was a mistake on my part. What I wanted to say, like, it doesn't work on the flat Earth.
Like I get it, bro. Like you see the flat Earth map, and you're like, okay, that's a good example of what I think flat Earth should look like.
I don't know the flat Earth that you're talking about looks like, because you said that you don't know.
Let's see how all this looks. And like, okay, well, my sky observations don't match up on this particular observation. So how do we explain how everything works in the sky on a flat Earth, right?
No, not everything. I'm saying that this particular thing cannot work on the flat Earth. I'm not saying, like, because this is this way, everything else should be working that and that way. I'm saying this thing, even if for 1 second, the people who should be very, very far away from each other and looking at a different direction, seeing the same thing, is not possible on the flat Earth. I'm not saying
you know what I want to
No, you're begging the question that it doesn't happen on a flat Earth. If the ground measures flat and is objectively flat, then the objects in the sky do not have anything to do with the texture of the ground. If the ground is flat and the shit in the sky is moving in a pattern, then the shit in the sky moving in a pattern is because it's moving in a pattern in the sky, and it has nothing to do with what's going on with the ground. What you're requiring is an explanation for the pattern that happens in the sky. And because we can't go to the sky and see, like, oh, well, it's actually an object that's producing light and it's strung up in a pattern, or we can't go up into the sky and see that these lights are attached to gears and the gears are moving in these specific patterns, and we're watching gears move in the sky. Because we can't go there and tell you, yeah, it's actually gears, then it's possible that it's not actually gears causing lights that are attached to them to move. You can come up with any speculation that you want.
Dude, it's not a speculation.
The things that happen in the sky happen in the sky, whether you're in the north or in the south, in the east or the west, or wherever location you want to put yourself at, the things in the sky do the things in the sky.
And I know what you're saying.
Observations doesn't
you're going to
matter,
have.
Let me just
I know what you're asking. You're saying, why do we see the Southern Cross?
Let me respond to tactical drone.
Why do we see the Southern Cross in different parts of the Southern Hemisphere at the same time, right? How could that possibly happen?
Let me please respond to most like more or less something like that. Let me please just respond to Technical Droid. Thank you. So basically what I got from your response, that the observations doesn't matter if it's not exactly measurement of the curvature. Any other observation doesn't have anything to do with the Earth, right? So sky is completely separate thing, and if it's acting magical on the flat Earth map model, but flat Earth possible flat Earth, it doesn't matter if it's acting like magic, right? So if two person back to back starting on the North Pole and walking towards South Pole with the same speed and meeting each other, it doesn't matter. That observation doesn't matter unless you measure the curvature, right?
People walking in the two different directions away from each other and meeting in the south, then you would have something else going on. But we're talking about the lights in the sky. We're not talking about people on the ground. You're making
so it's a different
connection that is not there to be made. Non sequitur.
Okay.
People standing back to back in the north, walking into the south, and then magically jumping in front of each other and being like, "Hey." Yeah, there would be something going on. Okay.
So
but we're talking about the lights in the sky that we can't go to and experience and measure and take samples of to identify what it is that they are. All we see is them doing patterns in the sky.
So if it's in the sky, it's different matter. Okay, let me ask you a question. If I
Is that
and
what
you
I
stand
said?
back to back, and see the same thing, right? In the air,
If I
the same
stand back
thing.
to back with somebody and we're obviously looking in different directions, we're obviously going to be seeing something different in the sky.
If it's
Like
the
if
same.
my face is facing towards Polaris and somebody is behind me facing Orion, then obviously we're going to be looking at something different.
So if it's the same but not on Earth, but rather in the sky, doesn't it make any difference? Should it like necessarily be on the Earth to make a difference? Like how it's not convincing to you. So just because it's in the sky, it doesn't matter actually whatsoever. It's kind of strange
it
that you're
has
ignoring
nothing
the
to
whole.
do with the shape of the ground.
Okay,
What goes
I
on in
see.
the sky is
I got
not
you.
the ground.
That's an unfortunate thing, Mr. Stark. You're talking about geometry, right? When you're talking about you have a curved line, you have a curved surface, and you want to measure that surface, and you find out that surface measures flat. Then you look up at the sky and say, "Oh shit, what are all those things doing up there?" Then that's the thing.
Yeah, it could be the case
No,
that
I'm not
the
bringing
lights
this
in the
up as a
sky.
counter argument to the
It could be
measurement
the
of the
case that the
curvature.
lights in the sky. It could be the case that the lights in the sky are not actually physical objects, and they're more of an apparent thing, similar to a rainbow. A rainbow doesn't exist in three-dimensional free space, but it does exist in your eyeballs, and people can walk in between you and a rainbow can exist in front of somebody.
What do you mean rainbow doesn't exist in the three-dimensional space? It's a refraction of light.
You can't walk. You
Exactly.
can't walk from one location underneath the rainbow to another location. It's always going to be
So
in that
it's
location
like it
until
doesn't
you
make the
leave
rainbow
the
metaphysical.
point of
It
prism.
doesn't exist.
The rainbow
No, it's just
exists
a
in
point
your
of refraction. Yeah.
because the light
Yeah,
is stimulating
is.
the retina in the back of your eye. The
Yeah,
cones and
the same
rods are
way.
picking up the light. Okay, so then the brain makes a rainbow because the cones and rods are seeing these different wavelengths of light. The rainbow isn't actually out in front of you. You can't reach out, grab the rainbow, and you can't taste the rainbow, but you see it.
That's why they tell you that there's always a pot of gold at the end of the rainbow, because you'll never find it.
Just because you can see and touch something doesn't mean like the light itself, the source of the light really like natural, it's existing, the sun exists, the source of the refracted light exists. Like it's saying like when you watch a person in the pool that refracted, you like saying like the person doesn't exist, the source of the light exists, the person exists, you're just seeing it in a different
Yeah, you missed exactly what I was saying, because what I was saying is that it could be the case that the lights in the sky are not physical and they're actually just apparent within your eyes. So then all of the lights in the sky are only viewed by the person viewing the sky, meaning
in that
the
case.
celestial sphere is a personal apparition.
In that case, rainbow is a bad example because although the positioning of the rainbow is relative, the source of the light that comes from the rainbow is really physical and it's not relative. So if the stars are not physical and apparent,
If
the
I'm on
source
the
should
North
be.
American continent and somebody else is in Australia and it's daytime for me and it's nighttime for them, then it would be similar because if I'm standing and I see the rainbow and somebody else is 45 degrees to the rainbow off in the distance, they don't see the rainbow. It's similar.
How does it have to do with the thing I said? I said the source of the rainbow,
You're
source of the
saying
light is
this
physical.
entire conversation is that the sky tells you the shape of the ground. You are accepting that the lights in the sky are physical objects and they have a physical location in three-dimensional space. Okay?
The question wasn't directed to you, and the point of the question weren't to prove
Do
curvature.
not exist in three-dimensional space. They're apparent to the observer.
That's your speculation. That's your opinion.
Yeah, I know that is.
First of all, the question wasn't directed to you, tactical droid.
What are the other examples that can be made for these things that happen if it's not a globe? I've given you this conversation, and now you're upset that I'm giving you a speculation.
I told you. I never said the speculation word. Don't put words in my mouth.
I don't care
and
if the
I'm telling you again.
Works or not.
I said that's your opinion, and I'm saying again. I stated once before.
Hold on,
this question was directed to
Mr. Stark, hold on. We got what's up, 20 cups.
My apologies, guys. I just wanted to chime in here because Mr. Stark, I heard you say something that I'm not so sure about. When Tactical was giving the comparison of the rainbow to the stars or whatever it was in the last conversation, you made a statement about something about the source of the light for the rainbows. What was it? Could you forgive me? Can you complete that?
I'll stillman him. It's the sunlight. The rainbow is coming from some light source somewhere in order to create that fractal or that prism effect where it's dividing the light. That light originated somewhere, and that's why he's saying it's a physical thing.
Okay. Could you substantiate your statement about the light being from a physical source? How do you know that?
How do I know that it's coming from the sun?
I didn't say that.
What's your exact question? So the first part of your question were answered by Sheepdog, right? And the second part is how can I substantiate the thing that Sheepdog said, right? He's kind of restated my point. I'm
going to interject something real quick. Hold on, I'm going to interject one thing real quick. 20 cups.
Yeah.
Mr. Stark. Just so you know, sometimes when you make claims here, like people ask for clarification, you're just going to have to walk down the road of logic, man. Okay? Like, don't get upset. Don't get all frustrated with this.
So
you may think these are stupid questions, but these are people.
Really,
we're trying to gain a mutual understanding.
Really, like couple of minutes ago, I stated that people here are wanting exact measurement of curvature. So there's no point going further. But you constantly keep asking me questions. So I just stated, let's not talk about this because people won't be satisfied with anything else than measurement of the curvature. But
it's fine. I'm just letting you know. That. And whenever it's me talking, and I'm the only one talking, and there's nobody else is piping in or anything like that, I don't mind taking the conversations in different directions, but we're not going to stray too far away on hypotheticals because the problem is things that you can't substantiate, you can't really have a conversation about, right?
By you, sorry, just to clarify, but you was plural. I'm not saying that you exactly. Some people try to continue the conversation, continue everything. I'm just stating, as far as I observed in this
I just wanted you to know, so that way 20
nothing besides measurement of the curvature would satisfy people here. So there's
for most people, even myself.
So there's no point really naturally, logically. You say you should follow the logic. Logically, there's no point to.
The idea is to get you out of your own imagination and get you into the real world.
That's rich, dude, coming from you.
Oh, you're damn right it is, man. It's a very rich topic here. It's a very rich topic, dude. Absolutely.
It's a very rich topic, but my conclusion was that there's no point continuing it because anything else that than the measurement of the curvature gonna satisfy this discussion. Us people in this group mentioned like anything but the ground, anything but the measurement of the curvature. So I'm saying there's no point in continuing conversation in many interesting other ways because that doesn't matter to people, most of the people in this group.
I tend to agree with that. I tend to agree with that. Absolutely. But I might I then just put forth to you to recognize kind of like what Sheepdog was highlighting, that statement that you made, right, about the light or the source of the light is physical. A statement like that is something that you might want to reconsider making if you can't substantiate it, whether it's on topic or not. Just in general, right? Because you can see, like, now that I'm pressing you on it, you're kind of, now that you're being pressed on it, you're emphasizing the need to change topics, right? So we can move on.
I really don't go. I really don't want to go there, but for
now that
English is not my native language. Could you please explain what substantiating meaning?
Thank you very much. So I'm going to finish my statement, right? So now that I'm pressing you on it, let it be known and recognized that now you're emphasizing the need to change topic because had we actually gone forward with it, you wouldn't be able to substantiate it. So anyway, now we can move on. Go ahead.
Because, as I'm saying again, for starters, I told that 10 minutes ago, not now, not after your question. Right. I told it before your question.
You're right.
Just to state that it's not consequence of your question. And as the English is not my native language, could you please explain me what do you mean by substantiating?
Backing something up, right? So I make a statement. Somebody asks how or why or what do you mean or why are you saying that? Whatever. I can say, oh, well, because this, and we know this other thing, and therefore, what I said before was true.
Oh yeah, I definitely can back up that light is real, but we.
But that wasn't the contention. That wasn't the contention.
Contention? What's contention? Could you please?
That was not the problem. That's fine. That was not the problem. The problem was not, I wasn't butting in to poke at a statement like, oh, light is real. That wasn't the issue. The issue was you made a statement that the source of the light comes from a physical source. Right?
Okay.
Now, if you
definitely can back that up. I definitely can back that up by logic. Not prove it, back that up. Yeah.
Well, right. So that's the issue, right? And when you say physical, just to be clear, right? So when you're saying the term physical, you mean something like, for example, in the heliocentric model, it's a giant gas ball, plasma.
It's in reality. Right? Yeah.
Okay, so you don't necessarily mean it. Well, I'm not saying it's virtual either, but my point is, when you invoke that statement, are you or are you not sort of implying some sort of giant gas ball burning up there and therefore emitting light that we see?
It doesn't matter.
Oh, it doesn't matter. Oh, well, I mean, that's the first thing that comes to mind when you say physical in terms of the sun, because that's the model.
Yeah, it's heliocentric model, definitely. But we can agree and we can know that the light is real, right? We can measure it. We can see its speed. Light is physical. Yeah. Wouldn't you agree?
We see light, yeah. We can measure it, yeah.
We can measure it, so it's physical. It's
I get
real.
that. I get that. But again, like, that was not the problem. That wasn't what I was jumping in about.
In my logic, something
here's the weird thing, Mr. Stark. The weirdest thing about this thing, we can create artificial light and we can manipulate it, demonstrate it. We can give it a source. We can't duplicate the sunlight. I think that's what 20 Cups is trying to get at.
Okay. I don't know if that was the implication, but so far by logic, I think that if something if something is real and it's being emitted for something, by logic, the thing also should be real. If it's not real and creating real things, it's kind of magic, don't you think? It's like creating physical things out of non-physical things.
Do you know about moonlight? Have you ever heard the story about like the difference between moonlight and sunlight?
I mean, it's a refraction, but I don't know.
That's what they tell you. That's what they tell you. It's a reflection of the sunlight, right?
It's a reflection, yeah.
It's a reflection, not refraction. The moon is reflecting the light from the sun
Yes,
down.
refraction. Sorry, I meant reflection.
So that's what they tell us. But what's weird about it is if you go outside with a thermometer, like a laser thermometer, and you measure the temperature of the ground in the moonlight, and you measure the temperature of the ground in the moon shade, the moon light is typically a little bit more colder than the moon shade, which you would think that light would make things warmer, not colder.
Okay, I never heard about that. I never encountered that, but it's really kind of thing that breaks the reality of the physics that we have today.
Oh, for sure.
Yeah, I never heard it. Yeah, for sure.
Yeah, you can.
Of course, it does.
I would give you a video, but I think you can Google it. And people do videos about it all the time. It's like a new phenomenon.
That one is pretty easy to replicate. I mean, you can try that. Yeah, that's most of the easiest things that we discussed today. But that's my assumption. Yeah, I will take a look at that. Thank you. But 20 cups. My assumption, my logic was behind my statement that physical things cannot start from the not physical things, right? Except obvious exceptions like singularity. But in reality, like when you can see like emission of photons coming from a point in the sky, most likely that point is not just apparent but physical, because physical matter, not matter, but physical things coming out of it.
Understood.
It might be maybe I'm wrong. Maybe apparent things can bring up physical things.
Right. I don't think you're wrong in that, because you did caveat your statement with most likely. Right. And that is correct. What we experience, I have a light bulb here, right? It goes on, it emits light. I can go up to the light bulb, examine it. It's got, a physical structure. It's got glass, metal, and all the shit, right? Yeah, that's what we're mostly used to. So it's fair to assume that any, light source that we see has probably got some physicality to it. But in the case with the sun, right, we can't actually go verify that, right? So we've got these stories, right, of, it's this giant gas ball 95 or 93 million miles away, and it's burning light. Burning and emitting light, right? So that's a fair assumption that fits in the heliocentric model and all that.
Burning, but yeah, I get your point.
Whatever, it's it's undergoing fusion or whatever shit, right?
Yeah.
The point is, like I was saying before, you did caveat correctly your statement. It's most likely, because that's your experience. The problem here in this discussion is, I'm just highlighting the point that you can't actually verify that, right? So therefore, going back to the previous statement of, when you were talking about the rainbow, or quote unquote, you said that, it's something to the effect of the light is from a physical source, i.e. a thing that you can go and examine, touch and feel and all that, like a light bulb, right? You can't actually do that with the sun, right? So there's a leap of logic in that. And I just wanted to highlight that and, point it out for you, for you to consider.
Is like the real way to confirm existence, like physicality of something, is to go and touch it?
Not necessarily, but in this case, right, we are talking about something like a light source, like a light bulb, whatever. And you made the claim that it would have some sort of source. But when we examine physical sources of source, right, we take, many different vantage point observations. We examine it by other means, and we assess it that way.
I really see what you're saying here. It might be like kind of tough to agree on physicality of the sun, because the sun is a bit different thing on the flat Earth than in heliocentric model. A lot of different things, like a lot more different. But like at least we can agree that photons themselves are physical and the rainbow is just a refraction of the photons. So it's a physical thing that makes the rainbow in the end.
I understand that. Yeah, that's fine. But this was important, though, to highlight, because the rainbow bit, right? Let's say you see a rainbow and it looks to you like, let's say it's about 2-3 miles away from the sky, right? From where you are. If you were to walk out in that direction 2-3 miles and you look up, you would not see the rainbow anymore, right? Because it's not actually there. It's apparently there from where you were in the first place, right? There's no real way to really verify, oh, it is 2-3 miles out, so let me walk in that direction and get under it, right? For all you know, it was, a couple hundred feet. We don't know, and you pass it. Like, it doesn't have substance to it. It's an apparent phenomena. That's all that Tactical is trying to point out to you.
Okay, I see your point. Thank you.
Right, the phenomena is real. Like, you're really seeing what you see. No one's saying you're hallucinating, right? If you took a spectrometer or whatever from where you were standing initially, and you pointed up there, I would think, I don't know how sensitive these things are, but you would think that you would register various wavelengths from that thing in that area. Yeah, it's not right. That's not a problem. But to say that it's got physicality to it or substance to it is a misnomer. That's all.
Hey, Mr. Stark.
There's a rocket.
Oh, go ahead. Go ahead. Finish your thing, but I got a question for you after that.
Does it have anything to do with flat Earth again?
Well, it has to do with observing things from a distance and not being able to touch it and know what it is.
Okay, go ahead. Ask your question. I don't want to be rude, but I stated, and I'm stating for the third time, anything related to the flat Earth, it's pointless to discuss with me, at least, because my point is not about measuring the curvature.
No, yeah, I'm just talking about, when you look at the sky, the things in the sky, and you say, oh, the things in the sky look spherical, right? And you got the planets and the sun and the moon. So at 51 minutes past the hour, I put a picture in there. I tagged you in it, so it should highlight for you so you can find it pretty quick. And you're going to see what looks like 4 balls. I was just wondering if you could tell me how many of those are balls and which ones are balls.
How many of those are appearing to be a ball?
No, how many? Well, appearing to be, they look like balls, but how many of them are actually balls? And I'll show you the GIF afterwards after you guess. How many of them are balls, and which one are the balls?
I really cannot tell you from the picture. The one that most looks like the ball is the third one from the left, right? But I really cannot tell which are the balls and which are, maybe there's none of them are round ball. Maybe all of them are round balls. But I really can't deduce from the picture. I don't have enough information to do that.
Right, and so that's our point when when people tell us to look at the sky and say, "Oh, everything in the sky looks spherical, so the Earth must be spherical also." First of all, you can't compare
enough evidence in this picture. You don't.
Right. The same thing with the stars and the sun and the moon. We don't have enough evidence because we only ever always see the same side.
Don't you think?
We only ever always see the same side of the sun, and we only ever always see the same side of the moon.
Okay, but there are other spherical objects, right, in the sky.
It could be. I don't know. We can't go up there and verify that for ourselves. Correct?
Have you seen the Uranus?
It just everything looks circular, man. Everything looks circular and it looks lit up.
Dude, planets are in motion. The Earth also in motion. You can you have enough data in the real world to calculate the distance from Earth to celestial objects, to calculate, to see are they spinning around or are they disks or what. So basically, yeah, you have enough evidence in real life. In this photo, you don't have any enough information. It's just a two-dimensional grid of pixels. You don't have any physical information, like you can see it from different angles. You cannot see it in the perspective. It's just not enough information. They're not moving in time. They're not rotating. There's nothing. There's just a grid of pixels. But in real life, you have a lot of variations, a lot of data that you can use to get information. Those are not present in this image.
I'm sorry, sir. How do you know Uranus is a ball again? Because I don't know. I look at, either photos or videos of it, allegedly of it, and it looks like, what Sheepdog posted.
By the gravitational pull.
Oh, by gravity? What do you mean by that? How do you measure the gravitational pull?
Okay.
Are we going to get to Fantasyland? Keep in mind, we're going into Fantasyland now.
What do you mean?
Now you're in the realm of Fantasyland.
You're
yeah, I've heard you, but
you're applying Earth physics to a thing in the sky.
Yeah, that same thing did Newton called like a lot of time ago, right? So what's preventing me from doing that?
Okay, well let's start. For starters, right? You would need to know the distance to that thing. You would need to know the size of it. You would need to know the composition of it, right, to get its mass and all this shit. How was any of that done, sir?
The mass is not calculated with its composition because you cannot know the composition of its core from looking, right? You can calculate the mass of the objects in the space by the gravitational pull, by how they interact with each other and how they change the trajectory of each other, right? In astrophysics, you have things called predictions, right? You can predict the movement of the comet, right?
Slow down. Right. If you're going to measure a gravitational pull between two objects, right? If you're going to invoke Newton, or you have M1, M2, the distance, all this shit to, each one, right? You would have to have some sort of comparison or a relative, a relation between the masses, right? Some sort of ratio between them. So you would need to know one or the other in the first place, right? So how any of those? Hey?
Like the Earth.
Sure. Oh, okay. Do you know the mass of the Earth, sir?
Yeah, we have like pretty close approximation of the mass.
Okay, what aspects of the Earth do we know for sure?
We know its composition, we know its radius, we know its circumference, we know its distance from the sun.
Oh, do we? Okay, so let's start with the radius, right? I want to get to the distance to the sun bit in a second. Okay, how do we know the radius of the Earth, sir?
I don't know. Dudes in ancient Greek may find a way to calculate it. We can use the same thing to do it very, very primitively. I can look it up if you're interested, but most probably you've heard about it already.
Of course. Yeah, it's a non-starter, right? Because as you pointed out, he calculated it. He calculated a would-be radius of the Earth if all the assumptions in his model were accurate. Right now, you're talking about Eratosthenes, taking sticks and shadows or wells and shadows, and calculating the circumference based off of the shadow lengths and the distance between them. All this shit, right?
Mm-hmm.
Right. So I didn't ask for a calculation; I asked for a measurement. Because if you calculate something with a bunch of unknowns in your method, right? The way you're constructing your calculation, if you don't confirm that by some other means, well, you're kind of just...
You can confirm that.
Oh, really? Okay, so how was the Earth's radius confirmed, sir?
Dude, so I think you already know like what I'm gonna say, but you're asking anyway. So in the
No, I don't actually. I kind of figured you were going to go with Eratosthenes, right? But most people who come in here, hang on. Most people who come in here and talk about Eratosthenes, right? They use the terms similar to he proved the radius of the Earth or he measured the radius of the Earth. You actually correctly stated it that he calculated it, right? But if he calculated it and didn't confirm it by other means, right?
Okay.
I mean, other people they would say that is the go-to, right? So they're thereby not needing any other method of confirming. But in this case, you're actually correctly stating it. So therefore, there must have been something else to back that up and to confirm it. So that I'm not aware of.
Basically, in astrophysics and in science generally, you have things called predictions. And based on your calculations, you can make predictions. And if your calculations are wrong, those predictions, most likely there might be some luck involved, but not like a lot of times that you make those predictions. They're going to come true. If your calculations are true, for starters, you are going to be able to make predictions based on your model and your calculations. If those predictions are true, your calculations are true. And let me give you an example, right? So let's say you have a tablecloth.
Hang on. So do you mean to say that you're going to give a pass and allow for and affirming the consequent because it's astrophysics?
So sorry, could you repeat the last part? I didn't hear you.
So you mean to say that because it's astrophysics, basically, and we're, speaking of such grand, scales and shit like that, you're going to allow for and affirming the consequent?
I'm going to allow for what?
Do you know what affirming the consequent means?
Like stating the consequence?
Affirming the consequent is a formal logical fallacy.
Formal logical fallacy.
It's like when we tell you to prove gravity, and then you point it at the Earth.
Yeah, like watch this, dude. Okay, I'm going to give you an example. Okay? Contrast these two statements and you tell me what's wrong with either or both or whatnot. Okay. I take an apple, I hold it in the air and I let it go and it falls to the ground. Therefore, gravity. Okay. Gravity is because the Earth is, the mass of the Earth is pulling the apple down. Okay. Now, contrast that with I take an apple, I hold it up in the air and I let it go. It falls to the ground because gravity. And gravity is basically these giant these tiny invisible leprechauns and unicorns flying around that have a tendency or a desire to push heavy things or more dense things down to the ground. Okay? Oh, well, I let go of the apple and it falls to the ground. Therefore, there are indeed invisible leprechauns and unicorns flying around because look, they push the apple down to the ground. Therefore,
I see
invisible leprechauns and unicorns exist.
Let me ask you a question. Are those leprechauns work consistently every time in every place as the gravitation formula?
They have a desire, right, to consistently accelerate dense objects in air down to the ground at a rate of approximately 9.8 meters per second squared. Every time they really like. I'm going to finish my statement, sir. They really like to have that acceleration of 9. I don't know. They have a certain affinity for it. They love it. They have a little boner for 9.8 meters per second squared. Okay, so because the apple falls to the ground at a rate of 9.8 meters per second squared. That means that there are indeed invisible leprechauns and unicorns flying around. Because look, it happens every time.
Okay, can I respond to that?
Yeah.
Okay, so if the leprechauns work consistently with the formula, if they... Sorry, somebody playing music?
Somebody's hot micing.
In just a second. I'm just...
That's okay, I got him. Go ahead, sir.
Thank you. So basically, if the leprechauns working basically the same way as the Newton's formula, and they don't have mass, then don't interact with light, then don't interact with anything else that wouldn't be there without them. I'm not against calling it leprechauns, because when the Newton stated the formula, you can say that it was a Santa Claus, invisible, maskless Santa Claus, leprechauns, elves, God, or something else, but it should be behaving the way the formula predicts. And if you can make a prediction out of it, it doesn't matter what do you call it. If it works and you don't have better explanation for it, if it's predictable and you can make provable prediction out of it, it means that it's true. You don't have the full picture.
Incorrect. Okay, so here's what is true: that on average, things that are denser than the medium of air tend to accelerate downwards at approximately 9.8 meters per second squared. That measurement, right, is tested time and time again, and we get approximately that. So we know that that's happening. To state why that's happening, right? Unless you can
happen outside of the Earth.
Unless you can scientifically verify it, you're just going to come up with a story, right? So again, right? The statement that the items fall downwards, that's a no-brainer. Everybody can witness that. They can test it, whatever, right? And to measure it at a certain rate and get something consistent, that can also be repeated over and over again. That's not a problem. That's not a problem at all. But to state
I think it's a flat Earth explanation for gravity. I'm assuming, I don't know.
No, it's not, sir. This is called avoiding affirming the consequent. It's actually being accurate and poignant in the observation and the statement of knowledge.
Isn't it like explanation of the gravity on the flat Earth?
No, it's not, sir. Because you and
there's other explanation.
No, sir. No.
There's ain't other?
I don't know. I'm not going to invoke one, because that's not the point. The point here is that the whole point here is that you basically said that if we can predict it, okay, it basically means what we said about it is true, and that's not correct. What you can say is our predictions match reality. So the measurements that we get from reality fit the mathematical model, which is just a statement of whatever phenomena or whatever, right? That maps out to reality. That's fine. But the philosophical underpinning, okay, the explanation or the story behind that, unless you can confirm that by some other means, it's just a story. You follow?
I follow.
You can respond, but I want to interject after this.
Go ahead.
You can respond, Mr. Stark, and then I want to interject.
Okay, great. So my point is that the example you've provided doesn't fit into the formula and doesn't fit into the predictions. That's why it's not true. We can definitely say it's not true.
Really?
But about leprechauns, it can be true. It cannot. It might be true. It might not be true. It doesn't change the prediction. So
of course not.
Is it leprechaun? Is it Santa Claus? Doesn't actually matter.
Well, like I said, right? The leprechauns and unicorns, they prefer, for whatever reason, right, to have an acceleration of approximately 9.8 meters per second squared, and it happens every time. Therefore, the leprechauns exist. That's effectively the equivalent of what you're saying.
So,
go ahead.
In physics, just like leprechauns, mass has no meaning. So it's just a made-up story.
Yeah. Sure. Yeah, there's another one. That's a whole other story.
Repeat? The mass of leprechaun doesn't exist?
Go ahead. You can tell him about that. He probably doesn't know that yet. That mass has no meaning in physics.
Yeah, Sheep, do you want to take that one? I want to jump in anyway.
The definition of mass is just a state of inertia, which is really fucking weird. But anyway, no, like the thing I wanted to ask is like, just because you can math something out doesn't mean that you can describe what's going on. You can't, that you're sciencing what's going on. I can give you a demonstration of 1 + 1 = 3, and I can prove to you through mathematical construct that 1 + 1 = 3, but that doesn't make 1 + 1 = 3 to be true, right? Did I lose everybody?
No, you're here.
I'm here.
All right.
I don't understand that though.
Of course, if you prove it, it makes it true. It's 100% true if you can prove it without any assumptions and like predicaments. I don't know.
Well, then math lies. You can lie with math too.
Of course, it's axioms, but the issue is like when I predict the diameter of something and like calculate the diameter of something and say like a thing with this diameter would pass through. If it passes, that means the diameter, at least that the way the thing that I said. Like if I say the diameter of this is at least 2x, and something 1 and the 99999x diameter passes through that thing, that means I'm true. It cannot be, and if it's not passes, that means I'm wrong. So if
but how was that done with the Earth, sir? This is the problem. Sorry? How was that done with the Earth? Because you can do that with an apple. You can do that with a basketball. You can predict it. Using some other somewhat related variable that you compare and then math out, and then boom, you get a value, right? Because you have something to compare it to that you can actually confirm. But when it comes to the Earth, all you have, for example, right? You have a basketball. Let's say, for example, I have a basketball, and I have an apple. And I look at the apple, I look at the basketball, and I compare it, and I say that the width of the basketball is 3 apples wide, right? So the diameter is 3 apples. So the unit of measurement is the width of an apple, right? There's my unit. It's a very crude unit, but I have a comparison, because a measurement is a measurement. All measurement is comparison. An inch, a mile, right? It's a standard length, right, that you're comparing to things and seeing how many of them match up, how many you need to span the entire thing, right? Okay. Just like in the old days, right? A foot was literally the length of a foot, approximately, right, or the average. Okay. Right? You're comparing the length of a foot to a stuff, right? So so in the context of the Earth, you don't have a means to validate the comparison. You're inferring a would-be measurement by other things like the movements up of stuff in the sky or something that happens down here, but you don't have the full context of what's going on up there or what's in between up and there, potentially having an effect on what we see here. So you can't confirm it with just Eratosthenes' method alone. That's why I was asking you if you have a way to have verified that or confirm it by some other means, and you said you did. So I'm curious what that actually might be.
I see. So you're stating that the measurement is using units of measurements, right? Like the mass and the length. So I'm really not seeing the issue here. What's the issue that we're using comparison of?
He's wanting to know the miles or the kilometers of the circumference of the Earth.
Yeah, and how that was attained by direct means. Because earlier you invoked Eratosthenes, wherein he performed a calculation of a would-be circumference of the Earth, right? Assuming all his stuff is actually true. Now, without confirming all those things, or even without using them or having to invoke them, how can we actually confirm that?
Well, let me give an example, right? And this is going to be my last example. I don't know if it's going to satisfy you or not, but I have a work to do. So, yeah. Let's say you have a really long cloth, right? For example, like it's tablecloth that's 6 meters, right? Or 6 foot, right? 6 of your foots, exactly your feet, right? Not the empirical. And you only have 2 feet, right? Only have 2 feet, or you even only have 1 because the other might be slightly different. So what you're trying to do is you're folding it 6 times measuring and you're seeing that it's this 1/6 of that cloth is off your foot, you can calculate that the whole cloth gonna be 6 foot. That's not actual measurement, that's a calculation. Can you be sure that you're true?
Well, here's the thing. How did you know that the cloth was 6 foot?
I brought an example with 6 foot just to make calculations right.
No,
to not use metric system, to use your feet.
Well, here's the thing, dude. Here's
the feet is not the problem. How'd you get the 6?
Okay, let's say it's 7. Let's say it's 7.
You have a certain cloth of a certain length, and you only know 1 foot of it or 2 foot of it or whatever you said. But you assumed that it was 6 foot, and then you started doing calculations of your 1 foot to the 6 foot. What we're saying is you don't have the 6 foot. You don't know what that number is.
Let's go from the other side because you don't like this side. You don't know how many times to fold.
This is fine. This is fine. Right? Because we can
6 times and you find out that it's your feet.
Yeah. That's fine, dude. Right? Because here's the thing. You can work with that. But it's not exactly a proper comparison. Okay? Because in this case, you're actually measuring a section of the thing. Okay? And you're comparing it with your foot. And that's fine. And you know that you folded it up 6 times. So therefore you multiply it. Like there's no what I'm saying here is there's nothing wrong with performing calculations. It's not. I'm not saying calculations is an evil word or it shouldn't be used. Okay, I write software for a living. Okay, I know what calculation is all about. It's everything. It's cool. The point is you have to know what's going into the function, doing the operations, to be sure of what the output's going to give you. Okay, in the context with Eratosthenes, like I said before, there are sets of unknowns, at least 2. Somebody can argue more, but even that's enough, right? You have 2 unknowns, you have 5 variables or 6 variables or something like that. One of them or 2 of them are kind of like estimates. Okay, we can go with that. 2 of them are sort of implied by one of the assumptions, and then there's 2 unknowns. Like there's so much lack of knowledge that you have to take as for granted as being true for the output to have any validity. This is the problem. And it's almost akin to like if you take your cloth example, right? You look at the cloth, okay, it's 6 feet, whatever, you fold it in 6, you have 1 foot, it's one, it's your foot it matches up to it, okay, it's 6 feet. But you're assuming that the cloth is not shrunk, right? Because, for example, if it wasn't shrunk by your dryer or something like that, it would probably span 6 feet 5 inches. But you're assuming that it wasn't distorted before you did the measurement, right? But if you don't care about that, and you take for granted that whatever it is now, shrunk or not, it is what it is. Boom, I measure it 6 feet. That's fine, right? You don't care about any of the other stuff. But in this case, okay, it's necessary to know whether the assumptions are accurate, are true or not, right? Because of the specificity of the state.
I just assumed we can fold it, making sure it's not like shrunk. Because when you fold something, you try to straighten it up,
and that's fine.
Okay,
right? Whether it's shrunk or not, right?
I
If you care,
agree with you.
Right?
You cannot absolutely know the size.
No, but what I mean,
you never can know absolute size.
What I mean is in your example, if it was important for you to know whether or not it was shrunk before you measured it, okay, then you would have to know before you actually did the measurement. If you don't care about that, then it doesn't matter. It doesn't need to be that accurate. It doesn't need to be that specific.
Of course you don't. Right? You don't care because you need to know the exact size. If it's shrunk, you need to know the shrunk size. If it doesn't shrunk, you don't.
But if you did need to, because what if, for example, you have to make a cut or something like that, it needs to be to size or whatever, but then you do your thing, and then it undergoes, some wash or whatever in cold water, and then it expands again. And then your thing's off.
It's going to expand proportionally, right?
Yeah, exactly. But my point is, it would only do that if it did actually shrink in the first place. You see what I mean? So, like in those contexts, you would actually have to know these details before you did your thing. So your assumption may or may not apply.
No, my point was. I see what you're saying. It depends on what your target is. It depends what your goal is.
What I'm getting at here with the sun bit, okay, these assumptions are critical. Okay? So you have to be sure of that.
I needed to know the length of the clothes that I have.
Yeah.
If it's X,
and that's fine, right? So
X.
I'm not even gonna. Yeah. So there's nothing wrong, right, with what you're saying. I don't have a problem with it because you actually made a measurement. You see?
Partial measurement.
It was a partial yet direct partial measurement, and then you calculated. You calculated
the difference. You can do the same, right? You can directly partially measure the Earth, like you can measure the length of your home.
This is the problem. You're not actually doing that. You're measuring a length of a shadow. You're measuring an angle, or two lengths of a shadow and two angles, right?
What do you mean?
And then you're also measuring a distance between shadow 1 and shadow 2 at different times when the sun is above one of them and not at the other, or whatever. Right? And then the assumptions come in. Number one, that you're on a ball or a spherical or curved surface to begin with. And then number two is that the light is coming in parallel enough such that you can, that the sun is far away enough such that you can approximate parallel light. Right? So there's two assumptions.
The light has to do with the measuring of your.
It's critical. It's critical because the light coming in parallel, okay, onto a curved surface. If the light is on top of one object, it's not going to cast a shadow anywhere, right?
You're talking about actual measurement. I thought about the house. Okay, sorry.
I'm talking about in the context of Veritaseum.
You're talking about actual measurement of the Earth. Okay.
Yeah, Veritaseum, right? So, yeah, exactly, right? So you have to assume that, and that's what you did. But then that's where, you're talking about distances to these objects in the sky and shit like that. You said something about Uranus, and then you invoke, gravitational pull and all this stuff. It's like, whoa, relax. One step at a time, right? You have to, we don't know these things.
I really get your point. You're saying that there's assumptions about certain things. That's why you cannot take that calculations. I will take a look at the internet and see.
Right? No, yeah, well, exactly. So that approach alone, if these things are true, then that would be a good rough estimate. And that's why I was pressing you earlier, asking if
it was a rough estimate. Actually, it's not exactly. It's pretty close, but it's not exact. And the measurement that we have today is not exact. Also, you can never get exact measurement down to the atom because the Earth is
no, of course not. But you can get closer and closer, right? Higher precision.
It's changing constantly. You can't have exact measurement.
Yeah, you get higher precision, of course. Right? So that's why I was asking you, what is this other method used to confirm Eratosthenes was within a certain error margin?
What? Sorry, could you repeat? What other methods is there to confirm?
What method was used to confirm that Eratosthenes was in the right ballpark? Like if he measured, if he calculated 3,700 miles radius, right? But now we know it's 3,959, so he was a couple hundred miles off or whatever, right? What is the second method to confirm that he was pretty close? Because we're closer now, because we know we're closer. Like, what is that method?
My point was that if you can make predictions based on that size and predictions come true, the predictions can confirm the size. But you don't accept that point. So I will take a look at the precise way, like in the modern, you can measure the circumference of the Earth, but something tells me that you ain't gonna accept anything. Like if it's based on the light, you might just argue that speed of light is not constant. If it's measured on the on the mass or something else, you can always disagree with the basic axioms of the physics, right? There's something that you need to have as a constant, right? So you can say that mass doesn't exist, and like the way I measure it, you just don't agree with that, right?
But no, dude. Instead of saying that, how about you put something forth, right? So just keep it all the while keeping in mind.
I said
all the while keeping in mind what I said before, right? If all you're doing is a calculation and you have a crap load of assumptions in it, if those hold true, then your output is going to be accurate. But there has to be a means to confirm that your assumptions were true after the math to then go backwards and retroactively, confirm the suspicion in the first place.
Like, I'll give you an example, Mr. Stark. Eratosthenes proved the circumference of the Earth using sticks and shadows to a close enough degree, but now we know because of satellites. But we had to put satellites in the orbit, so we had to know the circumference of the Earth to begin with.
I see. Yeah, I guess that's about the thing, but yeah. Guys, I already told you I have work to do, so I provided my example with the cloth, and it's the 20K caps said that it's not applicable because like it's different. There's assumption in the ancient method, but yeah, I see.
Yeah,
I will look up more accurate, more modern, and more foolproof method to. I don't think it's a foolproof. It might be really difficult, like. Certainly, like I wouldn't be able to do that because it's probably like requiring special equipment. But I will take a look how it can be, or how it is measured nowadays, because we have measurement.
Just know that he assumed the sun to be an infinite miles away, and he assumed that all the light rays were parallel coming to Earth.
Appreciate the time, man. Thank you very much.
Good conversation,
Okay, thank you very much.
Yeah, man, have a good night, or morning, or I don't know what your time zone is.
So, I've got work to do. I'm not going to sleep anyway. Okay, thank you.
Sorry, man. Drink coffee.
Yeah.
Sorry, Sheepdog. I didn't mean to steamroll over that. It's just I was just, shaking my boots over here, every second statement from this guy, I had to jump in. So appreciate you. Appreciate you letting me take that.
For the earlier conversations as well, too. Like he's been in here for he was in here for 12 fucking hours, dude.
Wow.
Excuse my language. He was engaging with most people for a majority of the 12 hours, probably around at least a good 8 or 9 hours for sure.
Has he been here before, or is this his first day?
Yeah.
No, he's been here before.
Okay.
He's a lot softer than he used to be. He came in real stock in the beginning, but we're kind of breaking him down to him understanding that, basically, if you want to measure curvature. This is the way I explained it to him, and he said it makes sense. If you want to measure curvature, you draw a tangent over the curved surface, and then you measure the deviation from the tangent over distance. It's plain and simple. And if you draw a tangent over a surface, and the surface is parallel to the tangent, then you don't have a curved surface.
Right on.
Yeah, he was here when I went to bed, and he's still here when I woke up. It's crazy. He was telling me last time.
I gotta go to work. I'm not even gonna get to sleep.
That's crazy. He was telling me, he's like, I'm going to study these long distance observations that you guys have been showing me, but he's like, if it turns out that you guys are right, he's like, what I'm going to do is it's much more plausible for me to just assume that the globe's the wrong size and it's actually got a bigger radius, And then I went over some math with him saying, like, look, in a lot of these observations, the radius would have to be millions of miles. He's like, yep. He's like, I would accept that over it being a flat Earth, just a giant, giant globe. And Cyclone just explained it in a way that made it seem like the most ridiculous claim. It was pretty funny.
Well, now instead of us living on the whole globe, we live on a portion of the globe, right?
Yeah, like 1% of the globe, and the rest is just all, I guess, undiscovered something.
And we're back to being a geocentric Earth again, and all the stars moving in that power line pattern over us.
Yeah, and on this tiny little section of the globe, that we have the North Pole and the South Pole. Just this one little section of the globe is crazy. Mental gymnastics at its finest. It's like anything but what a flat earther says.
Brother, my favorite are those kinds of people because, like, once you get them into a conversation, you can tell them anything that's the truth, and they'll tell you, "No, you're wrong, dude. You're wrong." Anything. You tell them 1 + 1 = 2. No, bro, you're wrong. No, let me Google it real quick. Hold on.
Yeah, it's crazy, isn't it? And then they'll say that, how do you know that the Earth curve calculator, they'll throw the Earth curvature calculators under the bus pretty quickly. I've noticed that. They'll throw any of the AIs under the bus. They'll throw Washington University straight under the bus.
It's a classic, what CB calls anything a flat earther says is wrong syndrome.
Yeah.
Those are my favorite people, man. I'm like, please, let me get you on a recording.
Hey, Mick, you there? Cups?
Yeah, man. What's up?
Yeah, I was looking over the what the K factor would have to be on the Great Salt Lake observation that I like to share, right? So it's 5-foot observation height, and then we can see shoreline to shoreline over 21 miles. Apparently the K factor would have to be 58 or something like that for that to work on a globe.
What?
Yeah.
That's weird. Because I thought the K, I guess it depends which refraction model you're using. Because one model that, I think it was the Walter Bislin one, it only goes up to 1, so it's normalized, right? Between -1 and 1.
Yeah.
So, I guess
the normal K factor is what, 0.13 or 0.13 to 0.17 or something like that? Is that right?
0.8%.
8 to 10%.
The standard, right, 7/6R, right, is 0.16 or 0.17, right? Because that's 1/6, right? So you tack on 1 extra 6, right? So at least in that in that model, that calculation, that's how it would be described.
Yeah, okay. I think I've only seen anti-flat earthers say that it's 7/6R. Most people that aren't anti-flat earthers seem to say it's like 8%, and then like 10% or a little bit more in extreme conditions. And that's what like ChatGPT and stuff seems to parrot, when it's trying to explain it. Let me try to find the math for you about the. What's that?
That 10%, right? Is that the overall effect that whatever the value would have, or is that the actual K itself? Right? Because it's just a coefficient.
Yeah, it would just increase the size of the globe of the radius by that percentage.
Right.
So it would, yeah. I'll just find. I thought you might be interested in. Okay, here we go. All right, so I'll read a little bit of it out. Okay, so all right, so I was talking to it. I said, okay, I have another observation over 21 miles Great Salt Lake, Utah. It's taken from 5-foot observation height, and we see the shoreline on the other side of the lake. No horizon at all is present over 21 miles. Is this possible on a globe with a radius of 3959 miles? It says short answer, no. Not under ordinary conditions on a globe. These numbers make that impossible without absurd refractive effects. And then it gives a whole bunch of math. And then it says, second. Right. Your eye foot is 5 foot above the surface. So the far shore would be about 294 feet below your line of sight. And then it says, for comparison, ordinary optical refraction corresponds to K values around 0.13 to 0.17.
Okay.
Even strong but natural ducks rarely produce anything remotely like K equals 58, right? Because that's the answer it came up with. It would have to be K equals 58.8. So a required K near 59 is physically absurd for visible light in the atmosphere. Right. Yeah. So if refraction or ducting were responsible, you would normally see telltale distortions, vertical stretching, inverted mirage, stacked replicas shimmering, or rapid change with small motion or time. A clear, undistorted, continuous shoreline seen from 21 miles away with a 5-foot eye height is not consistent with geometric hiding plus normal atmospheric refraction.
I see.
Yeah, it's absurd. Even when I was asking it about the one that they say, oh, this is what it should look like. They show the white swan, right? The one where the horizon's near platform hill house at about 6 miles, right? And even in that one, it says, you would need extreme conditions near ducting to even just be able to have that situation present.
I mean, I would put into question the model that K goes into. Because like I said before, anything over 1, I mean, I'm not even sure. I'd be curious what that is. Because, for example, right, in the side text, I posted a calculation I did using the Walter Bislin calculator, modeling the oil rig in the Black Swan. And what it tells me is in order to get the Black Swan to be in full view, like we actually see it in the image, at a 1-foot observer height, we would need a refractive index of 0.989182. Right? Like it's still high. Kind of like 58 is high, right? But it's bounded between -1 and 1, or 0 and 1. Right? Because in this model, the way he does the calculation, there's there's a division somewhere where he takes 1 and he subtracts K from it, and then all this stuff, right? So if you get in that model, if you're dividing by 1 minus something, that 1 minus something cannot be 0, otherwise you get an undefined quotient, right? So in such a case, the way that model interprets that is quote unquote an infinite radius, right? So at a refractive index of 1 in this input thing would yield a planar surface. You follow? But even with this,
no, I got you. Yeah,
0.989182 gives an apparent radius, as you see on the right side there, an apparent radius of 365,900 miles. Even with a small value like that, less than 1. So I wonder what that 58's all about. I mean,
I'm just looking into it now, actually.
Yeah, okay. Because we all know these chat GPTs and stuff like that, they hallucinate, they say shit. There was a guy that came in here not long ago. He was arguing with AI. They were talking about, the parabolic approximation and how accurate it is and all that stuff. And that guy literally went to chat GPT and asked it to build a data table showing the comparison between the two, how accurate they were and all that stuff. And it gave a result. And then not 2 seconds later, or I'm exaggerating there, 5 minutes later, he asks a follow-up question, and the answer that came back contradicted the first one. Right?
Yeah, it's like that sometimes.
Exactly. So
I would also be cautious with the information they're giving you with Walter Bislin, right? Those guys are slimy.
Yeah. Yeah, I mean, this is just their model, right? The model itself, I mean, assuming they're not fudging the model, right? The philosophy behind the model, like the ray tracing and all that, that's slimy for sure. It's not exactly representative of reality. We know that there's an embedded R in it, all that stuff. Yeah, we get that, right? But the math, I think the math would check out. I don't think they would deliberately, fudge any numbers to misrepresent anything.
Yeah, so I think this is kind of how it works, right?
That's what I would start with.
So K equals 0.17 would be the refractivity coefficient, but K equals 1.17 would be the effective radius factor.
Yeah, 1.17. So you're adding your whole to the 1/6, so you get 7/6.
Right. I'll look into it a bit more today. I'll find some some sources and go through it all. Because it's interesting. I think the actual optical density gradient, which would primarily be caused by a vertical temperature gradient differential, right? Like what the temperature would have to be, the inversion, right? What the meteorological conditions would have to be would be near impossible, I think.
Yeah.
For these situations to occur.
Well, that was certainly one thing that was pointed out in the Walter Bislin article that he wrote following up on this whole black swan thing. There's a data chart kind of pointing out the wide swing of temperature required over a short distance to produce the theoretical situation that would create, this thing according to his model. And Indio was going over. He's like, dude, that's like a 20 or 15 to 20 degree, Fahrenheit or Celsius or whatever, in a matter of like 10 meters or something, 10 feet or whatever.
Yeah.
Right? Like, like that doesn't happen. You know what I mean?
It doesn't happen, especially when you have, like, that's why I like to use this Dr. John Dee example. If you have a look at the example that I'm putting in the side chat, the great thing about this is he went all in on just checking all of the details about everything else on the day, right? He's got multiple weather reports, but he's also got the temperature of the water and the temperature of the air. And the temperature of the water and the temperature of the air are only 1 degree different.
Right on.
So so it's very difficult. It would be near impossible to have some crazy change in temperature just going up, because he's taking it from 3.5 foot. In the side chat just there, that's the...
Yeah, I see that. That's crazy. You see the little tugboat behind the fucking...
Yeah, that's actually a big boat, right? That's 13.9 miles away on the ship tracking radar, and you shouldn't be able to see it at all. This is the boat here.
Crazy.
Yeah. So yes, the horizon should be 2.29 miles away. In this one. Right, that's the boat. It's a pretty big boat. And so this is the distance to the boat. 12 nautical miles. 12.1. So 13.9 miles. And then here's the Earth curvature calculator results. So it's a great observation, actually, this one.
Damn.
Yeah, even those windmills, they don't look that big when you're looking, in this observation. But if you have a look at a close up, I've got a close up of them here. They're actually freaking massive. Like, check this out.
Or are they 80, 90 feet tall or something?
Like, look at that boat compared to it. Like, they're actually massive. Yeah. Well, I don't know how tall they are exactly. I'll have to check that. I do have all that information here. But the bottom 52 feet should be physically obstructed behind the curvature of the Earth.
That's a good one.
Hey, y'all want to hear something wild that I heard one of my fellow flat Earth friends tell me? He's a former Marine. I say former, once a Marine, always Marine. He was telling me about how they use sextants for navigation, for celestial navigation. And that, like, a bubble sextant and a regular sextant, there is no difference in the way that they're measured. You just look at the horizon and you measure that. The dip angle that a lot of globers who like to make that argument apparently matches the distance from the observer's eye down to sea level. Like, if you went straight down beneath your feet, it's your elevation above sea level. And I need more context to understand that.
So could you repeat that? You cut out at least for me.
Yeah. So when you're taking an observational measurement for degrees on celestial navigation, right? You're taking an angle measurement to the star. The dip angle, when you look out to the horizon, they always talk about this dip angle.
Yeah.
The dip angle actually measures your eyes above sea level. So if you're 100 feet above sea level, your eyes match that dip angle.
Yeah, that's right.
Uh-huh. I don't know if that's 100% correct. I was just bringing it up, seeing if anybody else has anything to add on to that or knowledge or anything like that.
That's what I've heard.
It makes sense.
Yeah,
it makes sense why the horizon doesn't rise all the way to eye level. I always say it's like right below your eye.
I don't know about that. I would argue that it does essentially rise to eye level, but there are other factors that cause you not to be able to see the the horizon properly, because as you go up in altitude, it becomes a longer distance between you and the horizon. So you start to have like that optical, like that deck of opacity or whatever you want to call it, actually obstructing it. So from that distance, it can make it look like the horizon's actually closer. Here, Dr. John D actually has a little diagram here that kind of explains it pretty well. And if you have a look at all of those, if you go to flatearth.ws and they'll say, oh, look, the horizon dips below eye level drastically, and they'll show images and there's always this kind of obstruction, right? It's always like a hazy day or something like that. And it looks like the horizon's a bit lower, but it's just being blocked, I think, by, by the opaque opacity of the air, essentially, right? Like Dr. John D shows in this little demonstration here. And then also sometimes we can just have it's super common to have that mirroring effect on the horizon, so you can't really see where the proper horizon is anyway. I got a really good example of that. But what I'm saying, I need to find this footage, right? It's on Phuket Words channel, and I don't know why I can't find it anymore. But he gets a drone, right? And it's like a really amazing drone. And the drone just goes vertically, like straight up in the air, really, really, really high, and then back down again. And he's got multiple different locations where someone's done this. And they've drawn a red line across the complete, like right across the center of the frame. And you'll see that as he rises and rises and rises and comes back down again, the horizon just stays exactly on that red line. in the center frame the entire time. It doesn't deviate down or up or anything like that. It's perfect.
Yeah, have you heard me with my refraction argument?
Which one? Say it again.
Is there more refraction on a clear day or less refraction on a clear day?
Oh yeah, I hear that one a bit. Yeah.
And then obviously it's going to be there's less refraction on a clear day. Okay, can you see farther on a clear day, or can you see not so far on a clear day? Well, I can see farther on a clear day. So on a clear day, there's less refraction and you can see further. Great, appreciate it.
Yeah, it's on a clear day. Obviously, we can see further. Like that's like common sense. But there are some situations where you can have certain miraging effects that are very likely. Like the main times when they happen are when you have clear conditions, like sinking, for example. They usually say that happens when the conditions are very clear, right? And that's the kind of situation where we'll see like.
But that'll be like pressure. There'll be pressure changes in that area, right?
Yeah, usually it happens right during the night or early in the morning, and the reason it happens in certain areas is because you'll have the air temperature will cool down as it does overnight, but the water temperature stays pretty much the same.
A lot of energy to heat up a lot of water.
Exactly. So in the morning, if you go out to do the observation in the morning, the air temperature might be like a little bit lower than the water temperature, so it will create that band of warmer air just above the surface of the water, and then you'll have that sinking effect. So that can happen sometimes as well. But yeah, obviously, if it's a clearer day, you can see further. Like if you're going to go out at midday and it's not a clear day, or it's a clear day, obviously you're going to be able to see further. I don't know how the Globers like don't get that. That's ridiculous.
Yeah, I've been like me personally ever since I've seen the Rob Skiba video where he uses a Fresnel lens to demonstrate bottom-up obstruction. Not only does he demonstrate bottom-up obstruction, but the sun doesn't really lose angular size as it's moving away. So to me, that's telling me that on a flat surface, off in the distance, it could be that there's a point of atmospheric lensing occurring due to some kind of temperature or pressure differential. Could be even turbulent airflow, not even laminar airflow, right? Some kind of atmospheric condition that's occurring, or even all three together, that's creating this lensing effect, and then everything beyond that becomes refracted. And because of that temperature inversion or that pressure inversion, the gradient inverts, and now you get a deflection upward towards the sky, which all you need is like 1.33 degrees of change, and over thousands of miles. Like that's significant.
Yeah,
and that would create a sun bottom-up obstruction. And then not only that, but if it's happening at the point where the land is starting to cool down, like you said, or in the twilight and everything, where the land is starting to cool down, that would explain that. Like as the sun is going through this lensing effect in the atmos, the light is also reaching the limitations in air, and it's now dissipating because it can no longer push through the air.
Yeah, definitely. I've been looking into that as well. It's an interesting topic. How they if you set up a lens and then you move something away on a flat surface, it just starts to disappear bottom up, and it doesn't change in size, in angular size much. And like those demonstrations show, when you move a light away, it does the exact same thing as what we see in a sunset.
Mm-hmm.
Yeah.
Or if you notice, but when the boats go over the horizon, they tend to be the same size. They don't tend to get smaller and smaller. They might dip down, but the features of the boat that are still visible tend to be the same size, or maybe even start to get a little bit larger. And
check this one out.
A magnification is a feature of refraction.
Yeah, exactly. I've got the citations for miraging. The first line of the citation from the American Meteorological Society talks about how the atmosphere can act as a lens. So have a look at this observation. I think you'll like this one because it's kind of analogous. So this is the boat that's in the observation, and it's called the Mandarin Arrow. And on the ship tracking app in this observation, right, that's just a random picture of the ship, so you know what it looks like. But this is the ship, right? It's anchored, and it's what is it? 12.4 nautical miles away. So I don't know what that is, like 14 miles or 15 miles or something like that. Okay, so this guy goes in the morning, and he's just standing on the a bank on the shoreline, maybe 10 foot above the surface. But in the morning, this is what we can see of the ship, right? You can only see that top section, and the whole bottom of the ship's completely looks like it's obstructed behind the horizon, right? And this is like
Yeah, but if you look really close at the image, like if you zoom in on it, you can see a little streak of mirroring happening
You
at the
can.
horizon.
You can, because this is bordering between sinking and inferior, like proper inferior mirage. And sinking's just according to the mainstream, right? Sinking is just a form of inferior mirage, where something that would normally be visible on the horizon apparently sinks beneath it. Once you start getting a little bit steeper of a temperature differential, that's when you start getting that total internal reflection, which is that mirroring effect, right? And we see a little bit in between, right? Just regular sinking, and it's starting to look a bit like an inferior mirage. But what's interesting about this is he stays there, right? And as the day goes on, the air temperature heats up. Okay, so the air temperature will start to become like warmer than the band of air just above the surface of the water. And this is the same boat 4 hours later. Same position, it's anchored, exact same boat, right? The one in the background there. So it's not actually hidden at all behind anything. It's just an optical effect. It's just a miraging effect. Matches the definition of sinking perfectly. So yeah, in sinking, they say that it usually happens early in the morning or during the night and in very clear conditions. And when you have a slightly warmer temperature down low, and then it gets cooler as you go higher. And they say it makes the horizon appear much closer than in the absence of the mirage. So that's exactly what we see in this image here. So yeah, I think there's a bit of that like lensing type effect as well happening here, because it looks blown up in a bit as well. Like it looks like it's kind of towering a little bit, especially compared to the bottom image. I'll post the video that this is from, because it shows the entire sort of time lapse of, because he keeps zooming in on it as the day keeps going ahead. But I like to show this one because it shows that, like, yeah, it looks like the boat's obstructed bottom up, but it's not really. It's just due to the weather conditions, just an optical effect, not the curvature of the Earth.
No.
Hey, yo, Will. Oh,
What's up, Nova?
what's up?
What brings you over into this room, man?
What?
What brings you over into this room in here that you're in? What shape do you think the Earth is?
Flat.
Right on, man.
Gotta be flat, I guess. It makes sense. Look at the ground, you see it's flat.
Yeah, I agree. The Earth's too big to see curvature, right?
Yeah, exactly. Like, what's the point? It's my opinion. I can have whatever opinion I want.
Have you been in an airplane?
Yeah. Tons of airplanes. It's flat from an airplane. Look, even if the Earth were a globe, it would still look flat from an airplane because if you look at the mathematics, you would only see 0.1% of the surface area of the Earth from that height. So you wouldn't actually see a curve even if it was a globe. But yeah, I've been on tons of planes.
See the curve. That's not factual.
Yeah, so you wouldn't. So even Neil deGrasse Tyson, right? He hates flat Earth, right? He's a physicist, and he said that even from 8 times the height of an airplane, 300,000 feet, he said you wouldn't even see the curvature of the Earth from that height because you're not high enough off the surface to be able to see it. Right, so it's just the mathematics. And I don't know, like I've been in so many airplanes and I've never seen it. I'm always amazed how perfectly flat it looks. And we even had a pilot in here a few days ago, right? He was a globe earther as well, commercial pilot. And he said you don't see the curvature from an airplane. Maybe in certain models of airplanes, hold on a second, right? Maybe in certain models of airplanes, they can have a particular type of window that's a big, fat, round glass that's triple layered. You might think that you're seeing curvature because you're looking through a big round lens, but you wouldn't mathematically see it from that height. So
Yeah.
Hey, what if I showed you a video? What if I showed you a video from an airplane where it's a commercial because the airplane goes up during a solar eclipse, and while they're flying through the solar eclipse and watching the solar eclipse from the airplane at 40,000 feet, the horizon is flat. And it literally shows it flat in the video.
Yeah, I think we have enough proof.
yeah, so I'm uploading a time lapse of a flight, right? So it shows like a time lapse condensed, a long flight, condensed down into a short video. And you can see the horizon the whole time, right? He's looking out the window and you don't see any curvature. It doesn't mean that the Earth is flat, right? That's not proof of that. It's just you wouldn't see it from that height. Right, there's a commercial flight right there in the side chat.
Here's also my commercial flight. I found this on accident, believe it or not. But they're advertising this airline, and everybody's like, "Oh, cool! Look at the solar eclipse!" And you can just tell not one of them is looking at the horizon when they go through the solar eclipse. Once the light gets removed from the solar eclipse, the horizon literally goes level. It's the coolest thing ever.
So what do you guys think, at the end of the world, what is it there? If the Earth is flat, there's got to be something on the edges, right?
I thought you said the Earth was flat.
Yeah, I mean, what are your thoughts on that? No, because there are so many explanations.
Yeah, whatever this world is, it's completely contained. So think of it more like a terrarium. There's no edge for you to jump off of. If you were to reach the edge, there's probably a wall there.
Like those video games that you actually play. Okay, that's the end of it. You can only play. That's not the non-playable area.
Not so much. When you play video games, sometimes when you reach the limit of your video game, you can see past the limit of your video game, but you run into a wall and your player can't advance anymore in that direction. So I wouldn't say it's like a video game.
Interesting.
Hello. Hey, Sheepdog, that video is freaking amazing, man. Right? That shows it looks like there's curvature. And then you can see that it was just an optical effect. And at the end of the video, it's completely flat across the horizon. That's a really, really good example, man. How people could be tricked into thinking that they're seeing curvature sometimes, right? Because you look at the thumbnail, it looks, oh, I can see the curvature, right? Even Scarlett said, look, I can see from that video the Earth is not flat. But Scarlett, go to the end of the video, right? You can see it's completely flat.
The last 6 seconds. Matter of fact, I'll post the end of the video for everybody. Just
I'm gonna save that one. Hello.
What's up, man?
Hey, how are you?
Good. How
Good,
are
bro.
you?
How are you?
Yeah, I'm fine. Thanks. So, what's the topic that we're talking right now?
Oh, we're talking about the Earth.
We're talking about how high do you have to be to see the curvature of the Earth, if there was curvature.
Is it possible to count?
It's possible to count.
Yeah. Is it possible to measure the height?
Well, we can only get so high, right? So, I mean, any height that we can get to, we just see a flat horizon. So even the Blue Origin, right? There was an astronaut that went up on the Blue Origin, and that goes up to 62 miles. That's about 350,000 feet. And she did an interview after the flight, and she said that she was disappointed she didn't get to see the curvature of the Earth. She was hoping that she would see the curvature of the Earth, but they didn't go high enough. And she did an interview where she was talking about that with Fox News. So, so even Neil deGrasse Tyson said that he did the calculations and he doesn't think that you would see the curvature from that height. So, we can only go up to the height of 30,000, 40,000 feet on a plane, or we can send up a weather balloon as civilians, right, to about 120,000 feet. And when we put a camera on the weather balloon at that height, we just see a flat horizon. So I don't think it's not proof that the Earth's not a globe, but that's what we observe, a flat horizon from any height that we can independently validate.
Okay, but it seems you have huge in-depth knowledge about it, right?
Say that again.
You're expert on this domain,
What did you say?
Probably. Sorry.
What did he say? What did you say?
I just say to him that probably he's expert on this domain. I mean, DG is expert, and maybe probably he have sufficient knowledge about this matter. But unfortunately, I don't have that much knowledge that he's talking about. But I know a little bit about it.
Yeah, well, Paul Larson, director of a planetarium in where's the operator? Is it Ohio? I can't remember now. But he's he's ex-director. He's not the current director, but he was the director of one of America's largest planetariums, and he said that as long as you're at an altitude above the surface, right, and your line of sight does not extend to see the whole one side of Earth, right? So your vision, your line of sight and your vision is limited, right? Either by what they think is the curvature of the Earth, or just the optics, right? Your eyes aren't being unable to resolve any more surface because they're not powerful enough to see that far, right? Either way, right? It's going to draw a circle around you in 360 degrees, right? That's going to be the limitation of your view, right? You're not going to be seeing the full circumference of the Earth. So as long as that's happening, right, you can draw a circle around you, and then if you can slice a piece out of Earth, right, out of your globe, so that you've got a section that comes off the side of the globe, right, and now you've got this. That's going to be a flat area, right? That's basically what you're going to see in your field of vision. Is just a flat horizon around you, right, in a 360 degree.
Correct. Yeah. By the way, brother, probably you're from US, right? Are you from United States?
No, man, I'm not from no United States. No, I'm from Australia.
Oh, Australia. Okay.
That was racist, T-Dub.
What, you don't like my accent?
Totally, I
Yeah,
like
but
the
it's
way
kind of
it
tough to recognize you that you're from the different country. But I guess you were like English is your native language. That's why I just asked you that. Probably you're from US or Canada, but as you're from Australia, that's right. That's right.
That's correct. Yeah, I speak Australian. No, English.
Australian means
Yeah.
it's English, right? In Australia,
Yeah,
they're
yeah.
speaking English. Your
Kinda.
mother tongue in English, right?
so odd
Yeah,
to
it
have
is.
an upside down flat earther.
And where are you from?
Yep. You are asking me? Are you asking me?
What country? Yeah, country, yeah.
Okay. Okay, sorry. Yeah, I'm from Bangladesh. English is not my first language. Even it's not the second language. It's third language in Bangladesh, and I'm just trying
Oh,
to develop it. So
Bangladesh?
that's why I have some lackings about it. Sorry,
Oh, I think we've spoken before, haven't we? Yeah, you're from Bangladesh, did you say?
Bangladesh, right? Yep. You were
Right.
right.
So that's you speak Bengalese? I don't
Bengali?
know.
Is that the
Bengali,
Bengali.
right? Bengali.
yeah?
Bengali, right? You're right. You're right.
Bengali,
And
right.
what other language do you speak besides that and English?
We speak Bengali, and then second, most of the people speak in English over there, and the official language is English here.
Oh, really?
Okay. Wow.
Yeah, right. It's
And you
near
said
to
you
India.
speak
It's
a
a
third
neighbor country of
language?
India. Sorry.
Yeah, yeah. You said you also speak a third language?
Hindi?
Third language. A lot of people. Some of the people speaking Hindi as well, but it's the
Ah,
fiction
yeah,
and
yeah.
tiny amount of people.
Yeah, yeah, gotcha. Yeah, well, that's impressive to be able to speak three languages.
More than 95% people speaking Bengali here, and the 5% speaking English. Those who are expert and mature enough and educated, and very often people say speaking English here.
Yeah. Yeah, you have good English.
Yeah, thank you so much. By the way, where are you from, brother? Did you?
Australia.
Oh, still you were from Australia. Both of us from Australia. That's cool. That's cool.
Mm-hmm.
So, are you working with like any sort of astronomy and this sort of physics related subject, or it seems you were like expert on this domain? That's why I'm asking.
I spent a lot of time learning about cameras and photography and optics. I've also spent a lot of time looking into the specific arguments related to this topic. Yeah, so I mean, I used to work in animation, computer animation, and I also was a professional product photographer for 10 years as well. So I know a little bit about optics and that kind of thing, but specifically, you know, I've done a lot of independent research on this particular topic. Of flat Earth versus globe Earth, right? All the arguments, learning. What's that?
Yeah, you know, photography and animation. It's a creative skills. So that seems you are creative enough, right? Those are the creative skills.
Yeah, yes and no. I mean, yeah, I mean, I don't do that anymore. I just run my own businesses now.
Yeah. So what do you do right now? Are still you are a photographer and animation expert?
No. I run on some online businesses. Yeah.
Oh, got you. Thank you so much, bro. You were so kind.
Yeah, no problem.
Okay, someone sent a second video in our chat section. Probably we should watch this. But do you like to talk about this sort of things like flood, the earth is flat or not, and then this kind of stuff?
Yes.
Okay, so are you feel comfortable to talk about this matter?
Yeah, sure. Ask me whatever you like about the topic.
So you know, different sort of people have different opinions that actually earth is flat or not. So what's your perspective about this matter? What do you think about it? And can you explain a bit, please?
Yep, sure. So I would say that the Earth has no measurable curvature, right? I don't claim to know the shape of the Earth, but it can't possibly be a globe because there's thousands and thousands of observations, including long-distance photography, laser tests, infrared photography, and all sorts of other different methods that have validated 100% that there cannot be any curvature, right? Because if the Earth were a globe, there would have to be a certain amount of curvature over distance. So if you go to a large body of water, right, to the ocean or to a giant lake, you can test for the curvature that would have to be there if the Earth were a globe, and it's not, right? The surface of water is completely flat over distance. And when I say completely flat, I mean it's, not curving at a specific rate, right, that would line up with the globe. It's not curving at all.
Okay, but I'm going to ask you some sort of like in-depth question about it. Like I'm really curious about to know that what scientific evidence shows that the Earth is round. People are saying that Earth is round, but what's the main scientific evidence? Can you tell me? Can you explain?
Yeah, so this isn't really a question of science, right? This is a question of a geometric claim, right? Mathematics, geometry, not necessarily a cause and effect relationship. Okay, so it's not really a science question. It's more of a measurement question, a mathematical question. So they tell us that the Earth is a certain size, right? So if you have a ball that's a certain size, it will have a radius value, and then you can calculate how much curvature there would have to be over a specific distance based on the radius value. Now we can easily do that with the globe and go out and test for the curvature that should be there, and it's not there.
Okay, got you. So the next thing is that, like, what proves the Earth is round?
Yeah, so there's no proof that the Earth is round, right? There's only claims that the Earth is round. There's not.
If I say the Earth is proven around satellite photos from space, the curve is horizon. Okay, the first at sea and the way experience day and night across the different time zone. So that's why people are saying that Earth is round. Some of the photos is taken by satellite. So what do you think about it? Is it misinformation or is it true?
Yeah, it's misinformation that people haven't really looked into properly, and it's also information that you can't validate here in reality. So if you're going to believe a picture from space showing curvature, that curvature would also have to be present when you go and test the Earth here on the ground. Okay, so if you have a 20-mile lake, for example, it would have to have about 300 foot of curvature.
But like some of the scientists, they are saying the Earth is round because we have photos from space. We see ships disappear bottom first of the horizon, and the time zones show Earth is curved shape. So what are you saying?
Well, the time zones just mean that you have different light in different places at different times, right? Right, that's all that means. That can happen over a flat surface as well. Boats, right? Boats over the horizon, we can recreate that on a flat surface and show the same thing happening, right? So we can have a small scale flat surface and we can make it look like an object disappears bottom up, right? So it's not due to the curvature, it's due to different conditions that can be present. Now, boats over the horizon, so we need to tackle these questions one at a time.
But the way you were explaining that the Earth is not curvature, some people don't believe the Earth round because they digest science and they follow conspiracy theory, or like rely on that they see on their eyes, and they may think the horizon looks flat or believe false information that they find on online. So are you agree with this statement? That's why maybe you're saying.
No, it's not just because it looks flat, right? It looks flat for everybody. And they'll just tell you that it looks flat because you're so small. What's that? Say that again?
Are you believe conspiracy theory?
No, this has nothing to do with conspiracy theories. Right? This has to do with real world empirical evidence. Testing what is supposed to be there according to the globe, and it's not there. Testable, repeatable, verifiable. Yeah. Not conspiracy theories.
But the thing is that if you search in, like, if you ask on Google or if you watch videos on YouTube, they are just show and they are just trying to prove that the earth is flat and it's round, it's curvature. So if your statement is different,
yeah, but we've tested the Earth properly, and there's no curvature, right? So I don't think that you're able to present any evidence that there is curvature. If you think you have,
no. They are just showing some of the evidence. They are showing some of the evidence, you know.
Okay, so maybe you're not looking into it correctly, and maybe you want to present it here, and we can have a look at it.
You know, as I have seen some of the like videos on YouTube, they are just showing some of the photos from space, the horizon. They are just showing time zone and like airplane routes.
So pick one, and let's go over it, and let's analyze it and scrutinize it.
Okay, so let's talk about photos from space. Astronauts and satellites have taken real images showing artists
okay, pick one, and then send it to me, and then let's go over it, and let's work out how you validated it, and let's go over the details. So pick your picture, and then we can go over the evidence.
Right now I don't have any photo, but as I have seen as I have watched some of the videos on YouTube, they are just saying that some of the astronauts, they are just taking photo from a satellite, and they are just saying that that's why they are saying
which satellite? Which satellite?
Yeah, there is some sort of satellite. I don't know because I'm not expert on this domain, but they are saying they have the real photo.
Okay, right. How did you validate that that's true?
They are saying they have real photo and they are showing the photo as well. So that's the reason.
Yeah. So you just have to believe them. Right? You can't independently validate that. You just have to trust them, right? It's just trust that you have.
Oh. So should I believe them or not? What do you think about it? What's your opinion?
Well, you should not just blindly believe people.
Okay, so can you explain a bit about this matter? Why I shouldn't believe blindly? Because I'm not gonna believe them blindly, because they are just showing their evidence, they are showing their photos and everything. So the way they present everything.
I mean, that's why I'm asking you, like, who is this that's doing this, and what height are they at? What camera are they using? Right, and how can we validate that this image is correct? So you agree that photos can be manipulated very easily, right?
Oh, right. It's true.
Yeah.
This is true.
And we know that people can lie, right? Like everybody agrees that the government tells lies.
But
right?
if I ask you that, if some sort of thing, if you see from NASA's YouTube channel, if NASA is showing you that we are finding some sort of thing, so will you believe or not? I'm talking about NASA.
Because I've looked into NASA, and NASA is lying a lot, right? They've been caught lying about a lot of things. Let me give you an example. Yeah, so
really, NASA is telling lie?
NASA, yeah. I don't think most people don't trust NASA, right? Like they faked the moon landings.
Oh, brother, you were just changing my mind. I thought NASA is the biggest space exploration company in all over the world, and they are the billion-dollar industry. So they are saying everything is true, and they have their like real evidence on this segment, and that they are doing
evidence?
This is. I don't know.
Have you looked at NASA footage before, dude? Have you actually looked at their footage? And have a look at the footage that I'm putting in the side chat. You want to tell me that this footage looks realistic to you? Can you see?
Is it NASA's photo that is sent on the chat section?
Yeah, look at this. This is official NASA footage, my friend. Right, this looks ridiculous.
But it looks made by AI or artificial intelligence.
Well, that's what they're telling is okay. So this is official NASA footage from the moon mission, Apollo 11.
Oh my god! But I don't believe it. It seems it's fake.
Well, you can look up well, it does look fake, doesn't it? Right. So you can look up the footage on NASA's YouTube channel or NASA's website. Right. This is what they're telling you. This is real footage from the moon.
Oh my gosh! Oh shit! How it possible? Because they are just like they are trying to showing themselves. It's the biggest like space exploration company across the globe. They are the multi-billion-dollar industries. You know, it's not a it's a B, and then like they are doing some sort of complex task. Their mission is all the mission and everything is so complex. So if they are just showing and if they are just spread the misinformation across the globe, so how we will believe others, brother? It's really a bad thing that we are seeing.
Yeah, so obviously the footage looks completely fake, right?
Right. Yeah, that's why I said in the beginning that it seems it's fake.
Yeah, so that's NASA's giving you fake footage, right? Why are you trusting NASA?
It seems, you know, it seems a give image, give. Like some sort of things is making made by AI and funny things. Like,
No, this is NASA footage. This is official NASA footage. You can look up the footage on NASA's YouTube channel, and they tell you that this is footage from the moon mission.
Oh, I can control myself, brother. Oh, I'm gonna laugh.
So this footage that you're saying is fake, NASA says that it's real.
Oh, but I don't believe it. If they are showing their real evidence behind it, so definitely I will believe. But if they sometimes, you know, they are not showing any sort of evidence, they are just saying it is true, but they are not showing you any sort of proof or
So look at the footage that I just put in the side chat, right? This is from NASA's official YouTube channel. Okay, so this is the ridiculous footage, right, that you're seeing that I've posted. Right, NASA says this is Apollo 11 landing on the moon. Right, they're the ones telling you that this is real. This footage that you say is fake or made by AI, this is NASA's telling you that this is the real footage, right? This footage came out in the 70s. Okay, there was no AI then, was there?
Oh, yeah, right. I'm watching this video right now, so it's the same thing that you sent.
It is, yeah.
Oh shit! So, just I'm so much curious to know about this matter. Actually, what's happening behind it to the space exploration, and then can you break down as a normal consumer? I don't have sufficient knowledge about this domain, and I'm not expert on this field. So, can you explain what should I do and what should I think about as a normal and as usual people?
Well, this is a topic that requires a lot of time and effort to be put into research. So you need to learn about the arguments. You need to study the long-distance observations that we have done, which you could do yourself if you wanted to do it, right? And learn about the globe as well. I mean, most people don't know anything about the globe. If I ask you, how big is the globe? You know, what's the radius value? How fast is the Earth spinning? How does this and that work, right? Like, you probably won't be able to answer all of these questions. You need to do research on the globe.
Yeah. Right, correct. Because I don't have.
You need to scrutinize the claims. Yeah, most people don't, right? Most people don't know, right? Most people just believe it's a globe because that's what they were taught when they were young. Okay, they've never thought about it, and they don't know any details technically about it. They just blindly believe it.
But you know, it's a complex topic. So how is it possible to gather all of the knowledge about it? Because it's so much complex. You know, astronauts and some sort of space exploration is a huge complex and mathematical terms behind it, geometry and others.
Well, it's not that difficult. I mean, if it's a globe, it should have curvature. Okay, where do you check for curvature? Over the surface of water. Okay, so you just need to look at the long distance observations, right? And go over them, study them. You can do them yourself if you need to, and you can see that there's no curvature.
Okay, I gotta go. I'll back within 2 minutes, and I'll talk with you. I have many things that I want to ask you. Okay, brother, please.
Okay.
You got him curious.
It's funny that most people have never seen the NASA footage, and you show it to them, and they don't believe that it could possibly be the NASA's footage.
Right. I know that's twice now. I've seen you show somebody, and they're like, "No, that's not real."
Yeah. That's good because NASA puts it right on their YouTube channel for everyone to laugh at. And they disable the comments section.
Yeah, can you guys hear me?
Yes.
Cool, man. Cool. I got a question for you guys, okay?
Yep.
It's a speculation question. Just because one of my coworkers that he's a cool dude, but he's a fucking globy, and honestly, man, like I've tried every different angle with him. And it's like I don't know, he hit me with this question. He was basically like, "Man, well, whether at the end of the day, whether it's flat or a globe, it's not really going to matter to me, because I have my life, this and that. It's just it wouldn't make a difference either way for me." So I was like, well, hold on a minute. I tried to slow him down a little bit and kind of rope it in. I was like, so what do you mean it wouldn't matter? He's like, well, I just don't think it would apply to anything. It wouldn't change anything. And to some extent, bro, he was kind of right. But at the same time, he's kind of wrong, and I could see the part where he was kind of right, but he also couldn't see the part where he was kind of wrong, if you get what I mean. Like it doesn't necessarily change everything for you, but at the same time it does. And I think you guys get what I'm saying. But what would you say? What would you guys say it changes the most for you? And feel free to answer however. If you don't want to answer it, fine, but just curious.
I'd say, oh, come on, bro, you're tapping out already? Really? Giving up that easily?
Yeah, that is kind of a tap out, isn't it?
Well, I'd say, it's not going to make a huge difference because you already experience the Earth as flat and stationary every single day of your life. Right? So you're already nothing. Why would anything change when you're already living on a flat Earth? But I'd say it changes the way you have your outlook, right, on the world, the way you look at it. It changes the way your skepticism about mainstream information. There's so many things, right? It changes. Like, there's so much research to be done, right? If they've lied about this, if they're wrong about this, right? Like, there's so much to find out, so much more to know about this place. I don't know. I think it's pretty important to know where you live. I don't get how people like, they're like, oh, I don't care. Like, I don't care if I'm being lied to. I don't care if I have a complete false sense of reality about where I'm actually living. I don't know. That's weird. But yeah, some people. It's a common cop out. It's a common cop out for people.
What you were just describing is fucking Stockholm syndrome, bro. Like, big
exactly.
Abuse me, daddy. Abuse me. Like, oh god.
Right. PS is back. What's going on, PS?
But you know, brother. Hello. Yeah, brother DJ. You know, it's very necessary to know, right? And to know about the like geometry and then the earth and then like the space and this sort of kind of stuff. But why in our university and in our education system, time just try to hide it. It's not essential. It's essential for everyone, but they're not teaching us the practical way. They are just giving us some sort of theory that we read and just answer to the exam. We are not learning any sort of practical knowledge about this matter. What's the reason behind it, brother?
Well, I'm not sure what the reason is, but I think most people that are teaching you at the university they're not lying to you. They genuinely believe that the Earth is a globe because that's what they learn in their textbooks. And then they teach it to the kids, and then some of the kids can become teachers, right? And then they'll teach it to more kids, right? And the cycle continues. But it's like you said, right? It's just a theoretical, mathematical concept that people are being taught as reality. They're not giving you the proof. They're just telling you the explanations.
Right. So we are not learning any sort of practical knowledge here.
Yeah, because if you go out and practically test the Earth, there's no curvature.
But don't you think that it's not necessary to learn practically about this art or about this matter? We need just theory conversation and theory reading. So what do you think about this matter?
Yeah, so if you just learn the theory, then you'll only have a belief, right? If you want to confirm that information is correct, you need to go and validate that information against the real world. So if they teach you that,
right?
If they teach you live on a ball, right, and the radius is 6,371 kilometers. That means that there should be curvature over distances of water. So if you go to a large body of water, you can calculate how much curvature there should be. And then if you test it, there's no curvature. So, right, so the theory doesn't match reality.
Right.
So,
but if you want to test practically, so you need that much practical knowledge. At the same time, you need practical infrastructure. But it's not possible to make like this sort of research lab or this kind of stuff because it's huge, complex, and it's like
it's not complex. It's not complex. It's not complex. If you go to a 20-mile lake, there should be 270 foot of curvature over that 20 miles. Right? You can go and test for that. That means that things in the distance should be hidden behind the curvature of the Earth, but they're not. Right? That means a horizon should be at a certain distance away from you, but it's not. Okay, so that doesn't it's not complicated. Right? If someone tells you they're 5 foot tall and then you measure them and they're 6 foot tall, right? You don't have to be a scientist to know that they were wrong and that claim was false, right? Because you've gone and measured the true height of that person.
What do you mean by I don't need to be a scientific to measure everything, to explain, to understand every sort of thing? I don't need to be a scientist about this?
Yeah, because this is just geometry. This is mathematics, right? That's not science. This is just mathematics, right? So it's not a scientific query. It's not a scientific claim. It's a geometric claim.
probably it's a part of science, but it's not the entire thing is not happening in the scientific theory, right? The
Yeah,
science is
so
the different thing.
geometry is just a branch of mathematics, not science, but you can use mathematics within science, right? But they are different things.
They can
Mathematics
connect
is
each other.
mathematics is a language of numbers, right? Natural science is to test the cause and effect relationship of a naturally observed phenomena. So it's completely different, right? So if you want to say, okay, so what's the reason that water boils, right? You could do a scientific experiment and work out scientifically why that happens, but that's different to measuring a surface area that should be curving at a certain rate, right? It's not science, it's geometry and measurement.
Oh, dude, you are truly talented, brother. Truly, genuinely talented, because like you were explaining everything smoothly, but at the very beginning, I thought maybe those who were read in our university books and those who were see in the NASA's YouTube channel or official Facebook or website. So maybe those are the true fact. But as you said, sometimes it can be false information as well. That can be fake information. So right now I'm
Yeah.
thinking, oh my gosh, you have genuine talent, brother, because you really know how you think and what is the proper way to think about this matter. Because when you see from NASA's YouTube channel, it's true. It's not like that. It can be false and it can be fake information as well, right?
Yeah, it can be, it needs to be analyzed. Yeah, we shouldn't just blindly believe everything that we get told by authority figures or so-called authority figures.
Right, correct. But I didn't know before. Thank you so much for correcting me. That was the best correction in my entire life, because it can be anyone. So if you see the authority figure, so it's not like that you have to believe blindly, because blindly believe it's the most dangerous thing that it can be like it can be very bad in your future life. Because to believe blindly any sort of things, definitely I'm not agree with this statement. But at the very beginning, when I just start the conversation with you, so that time I thought maybe if their authority figure is good, if they have the good community, if they are just the best, so that time we can follow easily. But it's not like that. Definitely we need to research about this knowledge. Definitely we should look around, and then we will get that is it true or not, right?
Right, yeah. No, I appreciate the way you think. Yeah. So, yeah, that's right. Just test, question all things, and then, use logic and look at the
Right.
empirical
We have to
evidence.
use our logic, and we have to think logically, not just theory or not just emotionally. Because emotion is a thing. Sometimes you can believe some sort of thing negatively or fake way, but when you think about this theory logically, so that time you are just trying to connect your logic into your brain, that what's actually happening, is it true or not, and that I'm believing right now, it can be fake. So that definitely I should a bit research about this matter, and then you will figure out actually what's happening and what's going right.
Right. And we can't know everything, right? We need to also understand what we can't validate. So some things we can't test. Like we can't test what is the sun? What is the sun? What size is the sun? What exactly is the sun made of? Exactly what distance is the sun from the earth? And a whole bunch of extra details. What medium is the sun in? We can't empirically validate that.
That time there is some sort of AI tool, and Google will assist you that how actually you just try to verify that you are thinking right now. Because to validate some sort of things, definitely there is some tools you can test with. Artificial intelligence nowadays is popular. At the same time, you can search on Google and you can watch videos on YouTube. When you see that everything is the same information and everyone saying the same information, and everything is like everything is goes with the same value, so definitely you can believe it. Because if you ask five people the same thing, the answer, if the answer is same from the 5 people, so definitely you have to believe that. But if you see that the 4 people's opinion is different, 3 people's opinion is different, so definitely there is something wrong, right?
Well, I mean, most people are just getting the same knowledge, the same information from the mainstream education system, so they might all be wrong. Could ask a million people. A million people might be wrong because they're all just repeating the same nonsense that they all learn. Doesn't really
right.
just because the majority. It's actually a fallacy, right? It's called appeal to majority. Right, and just because everyone else believes something, right, that doesn't therefore make it true. If everyone's learning from the same textbooks, right, they're all going to believe the same thing. And if the textbook information, what's that?
Right.
Go ahead.
It's complicated. It's kind of thing that you think about it. But some sort of things you have to believe, because if you are not believe anything, if you are just deserve all the time practical knowledge, practical, if you just say that, show me your results, show me your practical output, so that time it's kind of difficult to show everything practically. Probably you have to believe some sort of thing sometimes.
Yeah, but you should be able to admit that you don't know, right? That's just a belief, right? So anyone can believe anything they want to believe. That's fine, right? Each person's their own person. If you want to blindly believe something, that's fine, right? But if you want to claim that you know for a fact about something that you have as a belief, then that's different. Then we're going to ask for evidence. Right, so someone can believe in something, that's fine. But if you want to claim that belief is a fact, then we're going to ask you to validate that. So there's a big difference between believing something and actually knowing.
Sometimes it's not possible to validate everything.
Like what? What, for example, are you talking about?
Sometimes it's not possible to validate everything.
No, you don't have to validate everything. Okay, so give me an example.
Oh, sure.
So we're not talking about everything. We're talking about the if the Earth's a globe or not. So the curvature, that's what we're talking about right now. We can easily validate that, right? That there's no curvature. But there's the other things we can't validate.
Yeah.
So if we can't validate something, we'll say we can't validate that, so we don't know for sure.
Right. But your thinking process is not like a normal human being. The way you think, that is quite different. I just predicting right now, because your answer, your opinion, not goes like normal typical guy. Okay.
Well, most people just blindly believe whatever they get taught, and they don't question things.
Probably yes.
Yeah.
But
that's very dangerous, like you said earlier. It's very dangerous for humanity when people can just be told anything by an authority figure and they just blindly believe it. And then they think it's a bad thing to question anything that comes from the authority figure, right? That's when the humans run into danger.
But those who have authority figure, they are not giving you misinformation, right? They are not ready to give you misinformation. They are just giving the value.
You don't think authority figures could give you the wrong information?
Maybe you should go watch some Sabine Hossenfelder, who talks about how, and she's a theoretical physicist, she talks about the corruption involved within academia, where certain
ideas are pushed more than others because of political or commercial endeavors and incentives, right? And then scientists put their hands out for grant money and stuff and say, "Yeah, me. Here, I'll tell the world what you want them to think."
Yeah, so if authority figures are telling you that the Earth's a globe, and then you ask them how they know that, right? Ask them where's the empirical evidence? Who's gone out and actually measured that? Because when we go out and test it, it's not true, right? There's no curvature. This has been validated hundreds and hundreds, if not thousands and thousands of times. Authority figures, and in this sense, maybe like university professors, right? Their job is to regurgitate the information from the textbooks and feed it to you, right? And then your job is to take in that information and then remember it and then regurgitate that information on the text, on the tests, on the exams. And if you're very good at remembering that information from the textbooks, then you will pass, you will get a good grade. Questioning the core variables from the textbooks isn't going to be helpful for you in the university course, right? Right? If you're learning about the Earth and then you say, well, how do we know it's actually a globe, right? Your professor's going to probably get very angry with you, right? That's not going to be good. He wants you to take that as a fact, right, without questioning it, and then learn all about the assumed globe, and then regurgitate that information like a parrot, right? That's what parrots do. So they want people to be like parrots, or like sheep, right, where they just follow the herd of sheep. Damn, how long ago did that guy leave?
Oh, did he dip?
He must have dipped, yeah.
Oh, dang. Did I offend him? Maybe.
I don't know, man. He'll be back. He'll be back. He'll be thinking about this all day.
Hello there.
They lie. Why would they lie? Why would they lie? Why would they?
A lot of you fellas that choose the path of least resistance. I'm sharpening my teeth before I eat my victims. Pastors heliocentrics, preaching kids. It's the demons teaching nitwits, sadistic, scripted as wits said. I'm kidding, you're smitten, no vape hits. It's a religion, it's a decision to use your wisdom for mischief. So significant, calling dudes fake truthers. Since when does your word salad need to serve a mixed blend of perverting the heard words of a Christian? Then one day he just walked away for a lot of paper or pay-per-view. Maybe you just stop the danger that an awful stranger threatened to make your life a perpetual pain for all the days of existence. Cause all the games and angles of distance outweighed your God-ordained resistance. But I'm sure that the witsits deserve not to be victims. Plus the incentives of seeing your pictures on all of the TVs and pixels. DreamWorks and the scripts filled, need work and the rent's billed. To your groomers, as long as you sit still, I get ill even writing these lyrics. But I'm like the appearance of lightning and you hear it striking at your spirit, fighting with your tears. It's trying, it's so weary, your time has been nearing. Nice try on you steering some of your biggest fans away. Wait, kids, don't forget to behave. You don't gotta commit to be made into the depiction of a slave. They played your ass and I don't see any other way but ask, why would they lie? Why would they lie? Why would they not? They plot and derive by watching the Antarctic Amazon sky, and they know it's a mock. Jarian's picking both sides. He's got the flurfers divided and then they disguise, and now Duffy's devising a plot. You ask why they lying? From behind closed eyelids they enticing the brightest to get deprived in contrived confinement. Only way that Austin will survive this. What's that mean? They have to bribe him. They enticing the ones with word salad, cause they the brightest. The things they say are chimed in. PayPal or Cash App, you can buy him, and when confronted from behind, he gets to whine in. But the one time he vaped it from the sideline, bribed by the Zionists. Either that or they threaten his life and need some treacherous time shit. When the mic hits the sidewalk, chalk it up as a lost dog. Your time to shine is passed right by, kid. But regardless of your new assignment, I still love you, Austin. You're a snake, just like I is. Wait, did I say snake? I'm in a saint. I ain't saying my halo ain't been defiled. It's a fine line between being a highlight and the twilight denialist. Why would they lie? Maybe they don't mind the silence, but the sun seems to be the line that divides the community till they start fighting. And even if you told the truth, the Jews still might not like it. But homie, you still alright, kid. Why would they lie? Why would they lie? They lie. They lie. They lie. They
Yeah. seen this video just the time to watch it.
Hey, Lugwig, are you still here?
Yes, I am.
I was hoping you could explain your conclusions on your moving gyroscope thing.
Well, it's I've been carrying out some observations today and yesterday after the first time it stopped, which I think it ran for the longest the first time, interestingly. And then the second time it ran probably about 70% of the time. But this is the most interesting thing, is when I woke up today, it had stopped. And when I restarted it, it didn't even run for an hour, which I haven't observed before, that it's been able to stop itself. But I did also notice that the magnets had gone slightly off center from the amount of times I'd just repositioned the glass or knocked the gyro some small amount. So I've reset it to the most exacting point that I can, and it's in motion again. But I've also been noticing that close to midnight and close to midday, the inner gimbal starts acting really erratically. And as far as you can get midway between midday and midnight, it will gain its lowest incidence of swing. But it won't maintain that for very long unless it stops completely, which I've not actually observed. I've only woken up and found it stopped. So my cats could be stopping it. I don't even know.
So my understanding is it actually is like powered by two magnets or something. I guess I was confused on that.
Well, yeah, I mean powered in the sense that it stays in the field. But that's not power as much as structure as far as I understand it, but maybe it is defined mechanically. But like free suspended gyros that run on electricity, they're ones that are supposed to do what mine's able to do already, sitting on a table. But I might just not understand exactly what they're saying about gyros because it's a really complicated field, honestly.
Cool, thanks.
But yeah, the most interesting value that I'm drawing out of the observations I've done so far is that the stuff they say about gyros being affected by gravity is actually trackable according to proximity of the local bodies. I don't know if you can hear the thunder in my stuff, but yeah, Alfred's above me.
Wait, who's Alfred? I'm sorry, what?
Cyclone Alfred. It doesn't have much energy as far south and in as I am, but we're on like the edge of the front that's moving across.
Oh, right. We'll be safe for sure.
Well, if you want to look at my YouTube video, I've got an interesting phenomena with lightning that I derived with certain technologies that I developed, I want to say, along pathways of resonant metals and magnetic fields and things. So it's a 11 or 16-minute video or something.
Yeah, sure.
That's lightning patches.
That sounds interesting. I actually sleep with a magnet under my pillow, and it gives me interesting results. I'll just say that. So. Let's just say that I used to be haunted by really, really bad dreams. And now that I put the magnet there, my dreams are not, the haunting has gone away. I know it's a little weird, but.
Maybe you're supposed to get haunted in your dreams so you wake up.
Maybe. But it was really bad, though. I almost thought maybe I had a poltergeist or something. I don't know, but
well, let's say that based on your alignment with the magnetic components of your brain and the water that generates the like the field effect, it becomes physical through the water. The way that you're attuned to this is specific, like frequency attenuation, the way that a radio works. Depends what your brain is receiving, I guess. So I think there's a way to optimize our connection with what we understand as the source of our consciousness, which is like our own being. But other than that, we can connect to a lot of different things. And magnets are one of these things that naturally aligns your system so that you tune into yourself instead of all the other chaos.
yeah, I think I can't remember. I'd have to look at my research again on it, and the reason I put it on my pillow, but it was something about how it is supposed to help with the cell phone energies and stuff that you have to kind of sleep near and all that. Like it helps counter all that kind of stuff, like the negative cell phone stuff.
Yeah, I mean, it supports what I'm saying anyway, because natural magnets form really like bioavailable structures. I know it's not the right word. Biocongruent structures possibly is better. But emissions from like telecommunications, they're forms of radiation. So it's like microwaving the planet essentially, and it microwaves you slightly. It's just not enough to cook an egg, but you can see what happens. Like you look up videos of like people cooking with mobile phones, just putting 20 of them around an egg or something, or boil it. Crazy.
Yeah, it's kind of scary actually, but yeah. It's kind of funny. I actually got the magnets from my brother because he was telling me about. He's usually not into that kind of stuff, but like he looks at things logically, and he just like the whole magnet thing was kind of like pretty cool to him. And he's like, "Here's some magnets. You should like, look into it, and I'll let you decide what to do with it and all this." He was just like. Talk about how good these. He actually ordered these rare earth magnets and gave me one for Christmas and all this, and he's like really like not usually like conspiracy theory. Like he actually gets on to me for being a conspiracy theory about stuff, but on the magnet thing, he was like all gun ho on that. So.
Hello, everybody.
Hi.
What do you reckon? You'll
Hello,
have another go?
everybody.
There's a go.
Welcome.
Hello, hello. Welcome. Somebody's sound is very low.
Yours.
Can you guys hear that? That's the thunder like shaking my whole house.
Holy crap.
Pressure buffets as strong as earthquakes nearly.
Here in Oklahoma, we sometimes get that too, but go ahead. Yeah, be safe, man.
Yeah, so an interesting thing about magnetism, right, is like they've known for a long time that water is diamagnetic, but the old understandings of magnetism implied that it doesn't react to magnetic fields. We've found recently that it does. It's only attracted in one direction. Like, in other words, it polarizes only to one pole. And this is important because if the water reacted to two poles, our body couldn't maintain like homeostasis, right? And like water wouldn't find its level either, actually. So diamagnetism is really interesting. And I remember when the Flat Earth movement was in its infancy on basically just YouTube, and they used to have comment thread arguments days with people about how they try to tell me that the moon and gravity is moving the tides, and I'm trying to explain the nature of magnetic fields. And what I kept coming up against is water is not magnetic, and people used to chant this at me for a decade. It was one of the original catechisms, until it's like, yeah, understanding of magnetic fields advanced a little bit more than we were dealing with.
I mean, that would make sense because there really isn't that much particles that water actually would have in it that would make it magnetic. You know, there's like metal, there's like no metal or anything like that. You know.
Yeah, but
there
it
is
comes
a little
down to your
bit.
understanding of the function of what they call the full electromagnetic spectrum. Nothing is outside of that. So everything has a relationship to magnetism, and not all of them are just like inert forms of a relationship, if you like, or nullifiable.
Nullifiable.
Oh, you're saying it, so it might not just be just metal. It could be other things. Is that what you're referring to, or?
Well, that's what the modern re-understanding of what diamagnetism actually is involving. It's not all things are diamagnetic, obviously, but yeah, like just ferrous metals is not where magnetism begins and ends, and that was how they kind of operated on the understanding until the past. Well, I'm not sure exactly when the developments advanced, but I know it was in my lifetime. Like, so they knew what diamagnetism was for centuries, I think, but they re-understood it recently with better investigative tools.
Cool, that's interesting. I'll have to do more research on it myself. So.
But yeah, it's like when you asked about what I meant by nullified, it's quite interesting to look at gravity and try to find a place where it's not being nullified. Because for all other forces to express themselves, then gravity is obviously being nullified, and yet it's also meant to be dominant to all other forces. So how can it sit in this fundamental paradox of its own definition? And I'll show you a simple graph that explains what I mean with the most basic geometry possible. And it's all derived from radiant math. When you radiate, you come from a single point in all directions. So gravity is following an inverse relationship at all times to radiant laws. Yeah. So even when you flip the dynamic and have compression laws, gravity is still exerting force in the other direction. So how can it be simultaneously subservient to and dominant of all other forces, yet not observable?
Or in
T-Gross. Hold on a second. T-Gross, mute up, buddy. Or learn manners.
It's like Neil deGrasse Tyson's like, gravity pushes and it pulls. It's like, yeah, buddy, okay.
Quiet in here.
Because you were making popping and clicking sounds. So, do you have a question for the panel?
Your microphone is very low.
That'd be something out of the ordinary, wouldn't it?
Dan Hammer, your microphone is I can hardly hear you, and I've got your volume up to 200%.
Interesting.
Yeah, I hear you just fine, dude.
I hear him pretty good too.
I was going to say, everyone else is.
No, I hear everybody else fine except Dan Hammer.
Sounds like a you problem. Disconnect and reconnect, man.
No.
God, this is some low ass tier trolling, man. So he asked you, do you have any questions regarding the topic?
Oh, flat Earth. I think I've asked all of the questions before, but I'm wondering if, and every debate I've had in here, I've won. But I'm wondering if
Wait, what? BS, man. BS.
Okay, so we're gonna check that. Steelman,
No,
one
I feel
flat Earth.
good
No,
again.
no, no. Steelman, one flat Earth argument. Just one. So how do you know you won the debate when you don't even know what the other side's argument even
because
was?
it was multiple debates, and I'm trying to think of the one where it was the quickest I won.
No. If you don't understand the opposition's
Yes,
argument,
I can remember. I can tell you, calm down. Can you just relax and stop pressurizing me?
I am relaxed. I'm not the
Jesus.
one screaming.
But anyway, so using I think it's a gyroscope to measure the tectonic shifts on different parts of the planet, which is basically a big round rock.
Oh my
spherical.
god.
See, this is what I mean, and I'm not going to do it. The reason I'm here today is I want to listen to another person debate.
Okay, cool. Awesome. I don't know how you evaluated that you won if you don't know the arguments of the other side. So how did you evaluate it when you don't remember what the other side even said? Yeah, you got a problem, dude.
No, I'm playing chess. I'm just
you weren't listening. Yeah, same old troll. We do this all the time. You can just go
So
on.
everybody's a troll that doesn't agree.
No, you're a troll. I didn't say everyone's a troll.
Okay.
No, you're a troll. You're a troll.
Oh, you
Not
say
everyone.
troll. You think everybody's trolling?
No, I don't. I just think you're trolling. So you're straw manning me for the third time. No, that supports straw man. No, you're a troll. Not everybody, just you.
No, that's your assumption.
Listen.
Pretty solid.
I talked to you. I said, Steelman of flat Earth.
I'm listening.
I don't care. Just, okay, go on, listen. Go on mute, dude. Like that. See how that works? You're on mute. Listen.
Wow.
We have a term for people like that in Australia. Fucking wanker.
I thought it was cunt.
No.
I think cunt's American thing, and then wanker is like an Australian thing. But they're equivalent.
Actually, I remember a debate Indio had about tectonic shifting, and he asked him, how did you measure it? And that was the end.
I don't even know how you'd measure that with a gyro. How would you even do that?
Hey, T-Dub, you remember that drunk clown that we used to get, Cap Horn of Heaven? That sounds like him a little bit.
Yeah, I remember the name. I'm trying to put a voice to it. The name, though, like, link that accent and the name. But, yeah, I'm struggling with my memory.
Well, you don't want to debate. I should ask him how a gyro that measures rotation measures linear motion.
Oh, don't pressurize him too much.
Pressure.
Oh, shit.
How does he do that without a container?
Morvis. Because that's what he said, right? I'm playing chess.
Yeah, he's playing chess. What's the difference between the queen and the king in chess?
Is that metaphorical, or do you want the actual logical answer?
Yeah,
I think it has an anatomical answer.
One could feed a baby and one cat.
Well, you never know the answer nowadays, man.
Yeah, I'll tell you. I'll tell you what it is. I'll tell you what it is. A king can only move one space at a time, but that bitch can go anywhere she wants.
Nice, nice.
And your king can identify as a queen now.
I was thinking that too.
Oh,
Dude, that would be freaking hilarious to play that game, right? Get the king to the other end of the board and be like, I identify as a queen.
Actually, though, now that you say that, when you think about it, it's not the kings and the royals who are getting trans operations. It's the pawns in society.
All the pawns.
There you go.
And then the pawns become queens.
There you go.
Drag queens, but yeah.
She belongs to the streets.
Well, you got the furries too. I know we shouldn't be talking about this. So any piece could identify as a knight, right? Because the knight's really a horse.
Well, knights were never in the game to begin with anyway. Nobody knows who invented it, but the oldest version used elephants and things for Indian warfare strategies. You had the elephant and the chariot and the king on his camel. It's really weird.
Hey, Matrix, are you the one that just played that She's for the Streets?
Yeah.
Are you doing that with your PC? Like, are you using virtual audio jack or anything?
I'm using Voicemeter and running.
Oh yeah. Virtual audio jacks. It's the same thing. It's the same.
It's taken me a while to get it worked out, but
yeah, like I have it all installed, but I can't get it quite right. So it's like when I click like my sound devices, I got like like 52 freaking voice meter things. So it's like
that's hilarious. Indio, there's a way better one. It's really easy to set up. It's called SteelSeries, right? I was messing around with Voicemeter, but then I found out about SteelSeries, and it plays everything like straight through my mic. It's literally just tells you exactly how to set it up while you're installing it.
Awesome!
Yeah, SteelSeries.
SteelSeries to run.
Really?
It was it was glitchy for me. It was just that's why I went back to Voicemeter. The trick with Voicemeter: don't install the basic one, don't install the medium one. Get the potato, the top one, and run that. So much because it just everything's there in front of you, and they don't tell you. One of the nastiest things I've had is getting feedback. So you guys will hear yourselves through me. And that was the biggest problem with it, trying to get rid of that. So it's only taken me like on and off a couple of weeks, but I've got a program called Sound Show, and basically it's just a king size soundboard, and you just fill it up with sounds and just play them. And my problem is linking that through Voicemeter. And yeah, started off installing the basic one, thinking this is going to be basic, click it, send it. And just nothing but headaches. But yeah, it was yesterday I finally got it to go, so it's probably only taken me 3 months. Of
SteelSeries Sonar. Use that.
Yeah.
I mean, yeah, that's so easy. It's really good. You can actually enhance the quality of your mic as well.
Which one do I? There's a bunch of them, man. There's a bunch of apps.
SteelSeries Sonar. Let me check. Yeah, GG. It says GG.
Okay, I see it. Free download. What does that mean? Is it just free to download? Then I got to pay for it?
Yeah, it's completely free.
Okay. Now I got to uninstall this other shit.
Oh man, I didn't uninstall it, and when I go into like my microphone or playback options, there's like freaking 1,000 things to choose from.
Yeah, I can't do that, dude. That's too much clutter for me.
But SteelSeries is really easy. You go into SteelSeries and you set up your master, right? And then everything else kind of runs off these master controls, right? So when you set it up, it'll give you 3 options, right? Mic input, just choose your regular microphone. And then above that, it says Stream Mix, right? So you click SteelSeries Sonar Stream. Right, so in your computer or any like if you go to Discord, you go to your settings, right? You just hit SteelSeries Sonar Stream, right? And because and everything through SteelSeries will play through that SteelSeries Sonar Stream. And then
now will I be able to play like YouTube videos or clips or shit in VLC player and all that crap?
Yeah, anything I play through my computer just comes through my microphone. I've got AI bots hooked up to it, all sorts of stuff. Right? Even if I like open up this AI bot that I've got, right, it will listen to what you guys are saying, and it will respond to me, and it will also respond to the people in the panel. Like there's all sorts of crazy stuff.
Wow.
But yeah, any media you play through your computer, it will come straight through your
Peter had an AI bot doing that. It was fucking in real time, listening through the microphone, listening to the speaker or whatever, and turning our voice into text, dude. So he was basically having the AI stenographer fucking write down everything we said in this VC.
You've got to hear DJ's QE bot. Oh my god, it's hilarious.
QE bot.
Yeah, bro, I got a QE bot. It's
let's hear it, man.
He calls him. He refers to himself like we were teasing him, saying it's Broken Eraser. Now he refers to himself as Broken Eraser. He's like on the fence about the flat Earth thing. Apparently now, he was hardcore global last week, like real rude.
Probably see farther.
What's your opinion? Yeah.
Than
like
my eyes can see if I use binoculars or a telescope or something.
Yeah, absolutely. Yeah, you'd have to do the calculations, like work out what your elevation is, and then work out what the target in the distance is. Like if you got like a mountain range or a structure in the distance, there's like.
It seems like everybody would know that, though, if that actually worked.
Well, there's millions and millions of flat earthers now, right? And anyone that actually goes out and checks, right? They either ignore the evidence, right, and just pretend that didn't happen or something, or they become a flat earther.
I don't know, man. If everybody could see it, I think I don't think there would be
anyone
just
can
some
test
people
it.
I think
It's not just some
whole
people.
world would know.
Have you spoken to most people? Right? It's not something that they think about.
Well, I mean, there would be tons of videos online, and I mean, people would have.
All right. Let me say one thing, right? So that happened, right? So back in 2015, Nikon brought out these cameras that I'm talking about. People started making these observations in mass, right? And flat Earth became huge back in 2015, 2016. By 2016, flat Earth became the number one searched term on YouTube. It actually surpassed Donald Trump during the elections, right? That's how popular it was. Now, late 2016, Congress got together with YouTube and Google and Facebook, right? And they decided that they were going to completely censor the flat Earth information, right? And there's a video of the Congress meeting where they actually talk about it. Okay, so it got censored, and not only did they censor it, they actually replaced the flat Earth videos right? The proper flat Earth videos with just a propaganda playlist. And still to this day, that's what comes up when you type in flat Earth videos on YouTube.
Wow, that's insane.
Yeah, it's pretty crazy.
So, I don't know, man. I think if anybody looks through binoculars or a fucking telescope, they're going to see a lot of shit. But I get what you're saying, though. I mean, I think.
Yeah.
Yeah, I sent you a couple videos in the side chat here, just as an example. It's not mountains. I think I do have a video of someone zooming in on a mountain, but it just gives you
these cameras are crazy. Like what he's shown in the side chat is like, when he zoomed out, you can't see anything on the horizon. But when he zooms in, you can see these boats, right, that are completely impossible to even see when he's zoomed out. A lot of people say once the boat goes beyond the horizon, it's gone beyond the curvature of the Earth. But with these cameras, we can actually, we can zoom back in and bring the whole boat back to view.
But so it's supposed to look flat right there, right? Is that what you're saying? Like the water and stuff?
Yeah, any large body of water that you go to, it will look flat on the surface, and the horizon will be completely flat, obviously, unless there's waves or something like that. I can show you a long distance observation if you want.
I mean,
like
do you think
a good one?
You think maybe it's because just the Earth is so fucking gigantic that you wouldn't be able to see it?
Yeah, look, the Earth. That's what most people say. Like most people haven't considered this, right? So we can do the basic math, and we can work out how much curvature there should be over a certain distance based on the math. You can even go to Google now, and you could type in Earth curvature calculator, right? Flat Earthers did not make these. These are just based off the radius of the Earth, like based off the size of the Earth. And you can put in the height of the observer, right? And it will tell you how far away the horizon should be if the Earth's a globe. And then you can put in the distance of the object that you're looking at in the distance, and it will tell you how much it should be hidden behind the curvature of the Earth. So if you put in, for example, 20 miles, right, and you put in an observer height of 5 feet, it'll tell you the horizon should be about 2.73 miles away. And the shoreline, right, just say the shoreline 20 miles away is the target, right? It'll say that it'll be obstructed behind the horizon, like hidden by the curvature of the Earth, hidden behind the curvature of the Earth by about 200 feet or something like that. Yeah, so that's just based off the globe math, right? It's just geometry. It's not something that anyone debates against. It's just the math based on the size of the Earth that they tell us.
Wow.
Yeah, so any Earth curve calculator will tell you the same thing. You could even go on ChatGPT and ask it, how much would the shoreline be hidden, and it will tell you the same answer. It'll do the same math.
It's crazy. You would think there'd be all kinds of videos showing that,
There is, yeah. You want to see one? I mean, that's the thing, bro. Listen. All of the videos are videos by flat earthers showing that we can see too far. There's no videos from the globe side showing that, oh, look, yeah, the horizon is at 2.7 miles. It's a globe, right? Or like, oh, yeah, look, we can't see this object. It's hidden behind the curvature of the Earth, right? These videos don't exist.
Do you ever think that maybe the calculations might be off a little bit about what you're saying?
No, it's not possible for the calculations to be off because not even physicists from the globe side that we debate with say that the calculations are off. These are their calculations. Like these Earth curvature calculators, right? They're made by universities and they're made by like I can send you a link to Washington University and they'll tell you the exact formula. Right, because it's just basic geometry based off the radius value of the Earth.
I don't know, man. I'm still thinking that people might not be able to see that well. They can't see that well, and so
but many people can see just fine. That's why we're using optics, right? We're using
many can, most of them can.
What do you mean? You say people's vision might be not very good or something, and it allows them to see over the curvature of the Earth?
I guess.
Yeah, we can see around corners.
Yeah. I like it, yeah.
I mean,
can see around corners.
Yeah, my vision's not very good. I can see around corners. But yeah, that's basically what it is. Like, you can't see something on the other side of a hill, right? Because it's blocked by the hill. Same sort of thing.
I don't know, man.
Well, you haven't seen any evidence yet, so I would be still skeptical if I were you.
Yeah, I mean, if you were me, you'd be skeptical too. Yeah, you're right.
Yeah, dude, I came into this exactly the same. Like thinking it was the dumbest thing ever, and then someone makes some points. It's like, okay, that's interesting. Can I see some evidence? And then,
but if you came into anything and people gave you like points on it, like, would you believe anything, or is it just this one thing?
Well, it's not something that you have to believe, right? Because all of this stuff you can actually go out and do yourself, right? It's not like the globe side where you just kind of have to blindly believe in some space stories from NASA. You can actually check anything that we're telling you, and that's what we encourage people to do, right? That's the best thing people can do.
Wait. So you're saying we never went to the moon?
Bro, even if I believe the Earth was a globe, right? The Apollo missions were nonsense, dude. They were gifting freaking petrified wood as moon rocks, and the footage is just ridiculous looking.
I've heard
there's
that.
all the shadows are in. There's all these shadows in the wrong directions, and it's crazy. Like, yeah, that doesn't disprove the globe or the flat Earth or anything. NASA's full of shit, though. That's for sure.
I could go like way deep into this, but what you were saying, like, bro, there's way more evidence that we went to the moon than there's not. For real.
Really?
I disagree with that. I think there's a lot of fabricated evidence. I mean, you could just make a pile of 900 gigabytes, and if it's all fake, it's not evidence at all. So just because there's more, it's like, I don't know.
If you think about it, bro, if you think about it a little bit, you'll think that that we faked the moon landing. But if you really fucking think about it for a long time, you'll know that we actually went. There's way more evidence that we went.
No, sorry, my friend, I do apologise to interrupt you.
No,
when you think about it for a long time, that's all right, it's my fault. When you think about it for a long time and you think about the story that they tell you, the moon orbiting around the Earth in a vacuum where the Earth is an open system, you understand that situation couldn't exist because all the gas that we will breathe would follow laws of entropy and disperse into the vacuum around the gas. That's what entropy is, right? Gas dispersal into a vacuum, the mixing of ideal gases. All right, let me dial this down for you. You know what a car wheel is, right? A tyre.
No.
You know what a tyre is, dude. Come on. I'm trying to make it simple for you so you can follow me.
Tire. Oh, yeah. You're talking kind of weird, like with an accent.
Yeah, no,
I don't understand.
That's fine, bro. Yeah. And you understand that the reason why we understand the reason why the gas inside the tyre is under pressure is because it's inside a fixed volume. The gas wants to expand, but is pressing against the tyre. When you open the valve on the tyre, what happens to the high pressure inside the tyre?
Who knows?
The gas comes out, doesn't it? When you open the valve and there's higher pressure in the tyre than there is outside, the high pressure moves into the lower pressure environment, doesn't it?
If you say it does, and it has to. I mean, it definitely does.
It's like, have you ever popped a balloon or got a puncture in your tyre?
Fuck no.
No, okay. Never popped a balloon, never punctured a tyre. You understand I'm trying to explain to you that to keep gas in one place, you need to contain it.
I don't know anything about gas.
Okay.
There's that observation in the side. I mean, the demonstration in the side chat might help him get the point.
Yeah. Are you in? No, dear.
Okay.
Classic thermodynamics experiment.
Yeah, Israel D, can you see that little test in the side chat that I put there?
Let me try to check it out. Hold on. If I can figure it out, man. I don't get on Discord very often.
Yeah, I'll explain it. It's super simple concept.
Oh, in the middle, the thing in the middle, right?
It's like some chambers, and then one of the bottom one's got the brown gas in it.
So the vacuum is on top and O2 is on the bottom.
Yeah. Look, the general idea of this this little GIF is to the vacuum at the top would represent that outer space is claimed to be a vacuum chamber, right? Essentially, like a big vacuum, deep space vacuum. Okay, like a vacuum chamber, you know what that is. And then the bottom chamber is a gas pressure system. That's meant to represent what we're breathing here on the Earth. Okay, so it's separated, right, by the valve, right? The valve stopping the high pressure from filling the available space, right? So if you click play on the video, you'll see that as soon as he releases the valve, the high pressure instantly equalizes with the low pressure, right? Because gas fills available space. High pressure goes to low pressure. Yeah. Right, so now do you get the point the Jedi was making?
What were you talking about before that?
Well, we're talking about the idea that we can go to the moon. We're told that the Earth is a system that is open. That means there's no container around the gas. That situation where gas stays in one place requires a container. Now, if the situation that they're telling us that the moon is in a vacuum and so is the Earth, then the gas that we would breathe would be like in the demonstration, filling the available space. Because that's the law of nature. It always happens.
Right on, man.
So that's how I know that we didn't go to a moon if it's in a vacuum.
Yeah, you're right. We could never do that for sure.
Questions. I got questions. Can I ask a question?
Yo, what's your question?
Okay, I have two questions. One is not important, but I just want to know what is your guys' interest, which is what property changes in that system once you open the valve.
It's no change in energy. It's a change in entropy. So the gas that has kinetic energy given to it by temperature has constant collisions with the environment around it because it's moving. Now, the only reason why it can't expand is because it's in a closed system. When you open the system, there's no energy increase. There's an entropy increase, and the gas that has kinetic energy moves into the available volume.
Yes, the entropy increases. Can you tell me one property that decreases there?
Yeah, the pressure.
Nice, that's one. There's another one. The temperature will decrease there.
Okay.
Yeah. Those questions are not relevant. But the next one is, would the pressure on those two containers, assuming that is oriented vertically, be exactly the same?
Yeah, like Boyle's law. Yeah. Because now you just got a container of gas.
Yeah, but won't the container on top be slightly less pressurized than the one on the bottom?
No, not according to Boyle's law, no.
Right.
Even Avogadro's law.
What about reality? What according to reality?
In reality, no, this is not what we measure. I mean, we can measure sometimes a gradient in pressure, but you're talking about a fixed volume with an even temperature.
Right. So if I put a barometer on the bottom of
How big's the container, dude? Are you going to try and get to... There's a gas pressure gradient in the atmosphere.
No, I'm talking about just that experiment, because I think you're going to have a slightly lower pressure on the one.
Then you need to look into Boyle's law and Avogadro's law and Gay, because those are the experiments that went into the ideal gas formula. If you want to know about gas, you should check those experiments out.
Yeah, but like gas laws are idealized scenarios. They are not it's scalable laws that scale to any whatever.
So when the gas is not ideal.
Huh?
When a gas is not ideal.
I don't know, but that's not.
Oh, okay. You just seem to say this is not an ideal situation. Well, there's a difference between ideal and non-ideal gases, dude. If you're invoking the gases are not ideal, then that's a very specific situation.
Yeah, okay. Let me rephrase that. Those gas laws are for like ideal situations, small volumes.
All volumes.
Not all volumes. Those are not laws.
Any and all volumes. This is always what happens. Like, for example, the change in temperature. It's going to change. It's not dependent on the volume now, dude. It's going to be in all volumes.
I think you should double check that.
Okay. So what's the point of trying to get
questions? Yeah.
Sorry, DJ.
No, I was just asking if he has any more questions or if that was it.
Yeah, I think it's wrong to say that they're going to have the exact same pressure. You can
what are going to have the exact same pressure?
Enough.
What are all volumes? If you have the same amount of gas at the same temperature and you ratio the volume, so you keep making the container bigger and keep having the same proportion of gas at the same temperature, yeah. But if you want to change the situation, have a bigger container, but the same amount of gas, and the pressure is going to go down. Increase the temperature, the pressure will go up, but that won't increase the amount of gas molecules.
Yeah, I'm not talking about varying the pressure. I'm talking about varying the altitude. I'm saying with higher altitude, the pressure will drop.
Okay, so this is asking why is there a pressure gradient on the Earth?
Yeah, but no, this is for any scenario. It doesn't have to be.
Oh, for any scenario, you'll need scenario, you'll need a container. For any and all scenarios.
Yeah, regardless. That's not what I'm talking about. Yeah, like it's a bit relevant to my question. Like, assuming a container, you put a barometer on the bottom, and then you flip the container upside down, the barometer reads less.
Yeah, I've heard the claim for years, right? But I've never seen anyone provide a practical demonstration of that where all of the potential contributing factors have been accounted for, right? Like temperature and all sorts of there's a whole list of things, right, that can affect the gradient, right? But I think if it's a static system where the temperature's controlled and that kind of thing, it should be the same pressure throughout the container. I mean, have you got something that you want to present that shows like that gradient that you're talking about?
Yeah, you can do this with a phone that has a barometer. Like if you open the
no.
Have a barometer on your phone?
Yeah, I'm not
my
going
phone
to do
doesn't
it,
have a
dude.
barometer.
Look,
Otherwise,
I'm sitting here. It's 3:10 a.m.
They're getting annoyed. Right, it's either in very scientific situations, or are you talking about measuring the gradient of the already existing gas pressure that we breathe with a phone? Or have you got it in a controlled position where you've got a fixed volume and you are in control of the temperature and the amount of gas? Is this a controlled situation, or are you just dangling your phone in the sky?
I'm not doing that with my phone. I don't have a barometer.
Okay, so you brought up if I could measure with my phone that's got a barometer what? The change in your room, or when you go to the top floor, or in a controlled situation where you have a container and are in control of the amount of gas, what it is, what temperature it is, what situation are you talking about, dude?
Right. Okay. I'll describe that to you. Yeah, I haven't done the experiment, but do you think that if I have, let's say, a closed container, and I glue a barometer, sensitive barometer, on the bottom of the container, and then flip it upside down, you don't think I'm gonna get a lower pressure when the barometer is on the top?
No.
According to the rules that I mentioned earlier, and it's going to depend. It's going to be under very strict situations.
Do you want to? Yeah, no. I'll just describe the situation. I have a closed container. Let's say a glass box, and a sensitive barometer glued to the bottom of it, and then I flip it upside down, and then I flip it upside down again, and then I flip it upside down again. Every time, what I'm saying is every time it's on top, it's going to read less than
you haven't
when it's on
measured
the
the pressure. You've only got one measuring device at the moment. You haven't measured the top yet. You need to.
No, I'm saying I'm flipping the container upside down.
Then flip it.
Yeah, so I measure the pressure when it's on the bottom,
the
then I flip it upside
in
down.
your
Now it's on the top.
hypothetical example?
What?
How big's the container in your hypothetical example?
Let's say 1 meter long.
Okay. Well, let me know what you find out.
Okay. Are you guys willing to bet some money on this? Because if you are, I'll definitely do the setup.
Why would I want to bet money on it? I'm interested just to know what you find out. See, this is why I think you're being slimy. I think you want to make this into some kind of challenge. You've got some kind of gotcha somewhere. I don't quite believe what you're saying. Okay, so why are we putting money on it? Just go and do the experiment and tell us what happens.
Well, I'm not going to buy a sensitive barometer.
All right, well then, who cares?
All right. I mean, but I'm willing to put my money where my mouth is. Like, if you would bet, I would put my money.
Not buy a barometer.
What?
You said you don't have the money to buy a barometer.
I didn't say I
but
don't
you're
have
going to have money to put down on a bet. Are you still going to have enough money to buy the fucking barometer?
I do have enough money to buy the barometer. I said I'm not going to buy it for
and you said you're not going to waste your money.
Yeah, exactly. That would be just a waste of money. Yeah, but I'm willing to put my money where my mouth is. If there's a bet,
it's not a waste of money if you're interested. Go and spend the money on the barometer and figure it out for yourself. If you're interested, it doesn't seem that you actually are unless you put money on it. And you can prove something and take someone's money away. That's why I don't trust you.
Oh, it's not about trusting. Like, it's not about me being interested either.
Shut up, man.
Well, you can do it yourself. I could make the bet with you being the one that.
I don't want to bet. I want you to go and buy the barometer and do the experiment.
Yeah, I know you want that. That's the easy part.
Well, go and do it then.
I have to spend the money, and all you gotta do is just say you don't trust me. Because you already said.
Stop being a wanker. You've already contradicted yourself about spending money, not wanting to. But do you want to bet some money? Because I've obviously got lots of money.
What was the contradiction?
I just explained it to you, but you started talking through me. It's why I don't trust you.
No, you didn't point to any contradiction. I never said I didn't have the money.
You started talking through me. It's the betting of the money, but I don't want to waste my money and buy the equipment. It's like you're going round in circles, dude.
Why is that a contradiction?
Are you going to spend the money on the equipment?
Only if there's a potential profit there.
Then fuck off. It's not... How do I put this? I'm not interested in betting with you. I thought this would be to further your own knowledge. Wouldn't you like to know?
Knowledge.
So you've already done it?
No. I know enough about how that works.
How do you know?
I don't need to do it.
Oh, you don't need to do it?
Yeah, I know how physics works.
See, this is why I don't trust you. It feels like you've already done it.
No, you haven't.
Oh, but you already know. How do you know?
Well, the same way I know if I drop a rock from...
Believe, no.
Yeah, if I drop a rocket from the top of a building, I know it's going to hit the ground. I don't have to do that to know that. I know enough about physics.
I know gas expands, you fucking wanker. Why are you doing this? It's embarrassing for you.
Now you're speaking through me.
Yes, intentionally, because I can't put up with you being a wanker.
Well, that's not fair.
I've caught you out in your little fucking game. Go away.
Yes, says you.
Yeah, you already know, but I want to bet because I want to run the experiment. I'm not going to trust you, dude.
This is not about trust. Obviously, I'm not going to spend money.
Oh, it is. It is. And how shall I say it this time? Forked tongue has made me not trust you. Your very own words. You did that.
What? I did what? Okay, simple. Yeah, gases expand, but gases have weight. Those two things together necessarily give you a gradient. So I know what's going to be the outcome. So I don't have any issue betting. Yeah, people have done this already, not just on a closed container.
Why can't you present anything? I've been asking people for this for years, and no one's ever presented anything where all of the potential things that could create a gradient have been accounted for, right? Like temperatures and things like that. Like temperature differences inside the container, external temperature changes, vibration, movement.
I don't think
all sorts of different things. Micro leaks or micro leaks, altitude change, like all sorts of different things. I mean,
temperature wouldn't explain a uniform.
Yeah, it's all about
uniform drop in gas pressure in different conditions.
No, he's saying there would be a gradient, right? But so in a truly closed static system with no leaks or no temperature change, right? The PSI would remain the same.
And even if the temperature is uneven, I think like if you
that's my point.
I guess you're going to just shift the attention from me regardless on whether I'm speaking.
No, I'm not. That was the chat. That was what you said, right?
Let's focus on him.
No, we'd rather talk to the newbies. We've spoken to you thousands of times.
That's what I just said. Right? Let's focus on the newbie.
Yeah. All I was saying, like, we can finish it up quickly. Like, if you have a demonstration backing your claim, then show it, because I've been asking for it for years. No one's ever been able to show that, right? I'd like to see it if you had it. That's all.
I don't have.
Do you have it? No. You said people have already done it, right? So do you have
yes,
have you
people did it live doing these discussions with their phone.
Okay, so who did it, and do you have something I can look at of someone who did it where they have accounted for all of the variables? It doesn't sound like someone with a phone is the type of test that I'm looking for here. Right, I'm looking for something that's been done properly, where they've really accounted for everything that could cause a gradient. That's all.
Yeah, I don't think that could cause a gradient of pressure. That doesn't make a lot of sense. The pressure, like if you
wouldn't know because you've never done an experiment.
Let me finish my sentence, please.
No, because you wouldn't know, would you?
Oh, well, I have an argument. Can I put out my argument before?
You haven't done an experiment, so you wouldn't know.
Well, I have knowledge of physics.
Jedi, tell me about your experiment, bro.
Oh god, this guy's back.
Which one?
Tell me about your experiment.
Junior Pinhead, yeah, he's
which one?
Good luck.
Putting gas inside a container.
That this guy remembers me because I don't remember him.
Who the fuck are you?
You gotta love it when that happens.
This guy's useless.
Who are you and what do you want?
Just want to hear about your little experiment, bro.
Oh, you put gas inside a container. You have a temperature, and for example, you change the temperature, and you could. Yeah, see, you're just a prick.
All right, go.
Oh, the other guy we were talking to left while Bacon was making his bet proposal.
Yeah, there's a misconception here on what role the temperature can play here. If you have a container where one side is hot, the other side is cold, they're the same container, and the pressure is going to be the same on both sides. One being colder won't change the pressure with the container.
No, it's not. No, if you have one end of a container that's warmer than the other end of a container, by the amount of kinetic energy given to it by temperature, there's going to be more collisions where the gas has more energy. Where there is less energy, temperature, within the gas, there are less collisions.
No,
Do you not
because
understand
the
this?
colder one. No, that's wrong. Let me explain why it's wrong.
Do you think temperature increases and decreases pressure? Shut up. Do you think temperature changes pressure?
Yeah, I'll finish my sentence, then you ask another question.
Do you think temperature changes pressure?
Yes, it obviously does.
Okay,
but that's
so
not
where you have two dynamically different temperatures, by definition, you will have different pressures. Would you like the experiments?
That's
No, fuck you
not
then.
correct. If you have those two same temperatures in the same container, the pressure is going to be the same. The colder gas do have less. Hang on a second.
You change the conditions, dummy. At one end of the container
let me
is
finish one sentence.
At the other end of the container is cold. Right?
But the pressure is going to be the same on both sides.
No, it isn't, because the temperature is different.
Yes, the temperature is different, not the pressure.
Sorry, what changes pressure? Does temperature change pressure?
Right? Temperature can change pressure if you don't change the volume. Like if you have a fixed volume, if you have a fixed volume and you heat it up.
You should have skipped
How dumb are you? Yes or no?
What?
How dumb are you? Yes or no?
That's not a yes or no question.
I know. Well done. You're at least fucking smart. Does temperature affect pressure? For example, if I increase temperature, will it increase pressure?
If you keep the volume the same, yes.
Okay.
If you increase
the volume's always going to be the same. All right, let me put it like this. The volume's always going to be the same. The amount of gas is always going to be the same. I'm going to increase and decrease pressure. Sorry, temperature. Will that result in an increase and decrease in pressure?
If you do that within the same container, what happens is the volume of the heated up gas is going to increase, while the volume of the cold air is going to decrease.
The volume of the gas is in a container. It's going to have more collisions because there's no space, more space to fill.
There is, for the hot pressure is
in
going
a fixed container. Where's more volume inside a fixed volume?
If you allow me finish my answer, you're going to know the answer. I was about to say that. There's more volume for...
Where?
I'm trying to answer you. Can I finish my sentence before you start asking it again?
How is there more volume in a fixed volume?
I'm trying to answer you. Just stop interrupting.
Just fucking answer.
I'm answering. The
fuck
hot
off. That's it. No more chances.
Gain
Piss
more
off.
volume.
You're an idiot. An increase in temperature increases pressure. A decrease in temperature decreases pressure. If you have a large enough container where one end is hotter than the other, you will have a pressure differential because there will be more collisions where the temperature is hotter and less collisions where the temperature is colder.
Yeah. I mean, how can you even argue against that? That's obvious. Oh, he's muted. He's deafened. Oh no.
I don't understand why he's called out from back underneath the rock he crawled under. Why is he back?
Crazy.
Okay, what happens with the gas if I make it colder?
The pressure
what happens if I make a balloon? Okay, what happens if I make a balloon
That's
colder?
an expandable volume.
Sure, but what happens with the volume of the balloon if I make it colder?
The volume of the balloon goes down, but that's because it's
what
an
happens if I
expandable
increase
volume. Now let's have a fixed volume. That's why I'm asking you.
Then the volume won't change. Sure.
Yeah,
but
no shit. Will the pressure change if I increase the temperature?
Yes. If you don't change the volume, yes.
Good. So, if I have a long enough container where one end has a different temperature than the other end, will there be more pressure where there is more temperature?
No.
No?
That's bullshit.
No. Can I make my question now?
No, you can tell me why.
okay? Because the volume of the hot air increases while the volume of the colder air decreases. The total volume hasn't changed, but the hot air occupies more volume now, and the cold air occupies less volume now.
Shit. Have you got an experiment to back that up? Have you got an experiment to back that up?
Those are guess laws.
It's not, no. Have you got an experiment to back that up? Because I have several. I've got several demonstrations of gas gradients inside containers where there's a variation in temperature. You're making a claim that's counter to the experiment. Please provide the experiment.
Which experiment? Show the experiment violates what I said.
No. Provide it. Come on.
Oh, you said you have experiments contradicting what I said. Can I show? Can I see one?
You can provide the experiments that has given you the fucking knowledge, dude. I'll wait.
I'm using my understanding of physics.
Don't make
But you said you have an experiment.
unless I understand what I'm talking about, dude.
Yeah, I'm using my understanding of physics. You said you have experiments that contradict me. Can you show them?
Dude, no. You don't deserve it.
Okay, great.
Okay, bye. All right, give me 2 minutes. Being as he's gone, I'll stop hosting. There's some people I can't stand and shouldn't engage with, and he's definitely one of them.
Mm-hmm. Yeah, just words without meaning behind them.
Like it's just so obvious. Like the warmer half of the container's gas particles are going to move faster and going to push harder on the walls of the container, and the opposite will happen on the cold side. So they're going to push less. The guy's tripping.
Looks like we have the dumbest person ever to speak on the internet gracing us here, Mr. Booger Smoker.
Hooray.
That's something special.
I do like his profile picture. Unfortunately, he's dumb. Your profile picture's not dumb. How about that? I'll give you one there.
Yeah, the profile picture has a higher IQ than he does.
Ah, shit.
Did you get that sex change you were saving up for, Heretic?
Case in point. There he goes. Let's let him cook now.
He's not denying it, so I guess he did go through with it.
Yeah, see how easily this delusional nitwit convinces himself of stuff? It's just that easy. That's how he convinced himself of the globe.
Well, I'm glad you get to represent the trans community in here. Good for you.
He would have been less dumb if he hadn't taken my rage bait, but he fell right for it, like always.
I think you're the one that's raging, to be honest.
Really? I feel really mad, yeah. You're right. No, actually, I think Booger Smoker is just delusional, as always. Yep, that's what it is.
Must be that hormone treatments you're on, all the estrogen. It's alright, I forgive you.
What is your delusions? No, I don't think it works like that. I take a chemical and you get fucked up.
Your emotionality. Same with this Jedi guy. He's got emotional problems. He must be on estrogen too.
So it's just projection time?
It's testosterone. It's what men have. It makes us not agree with bullshit.
Right.
We're
You
less agreeable.
definitely have low testosterone, I can tell.
Oh, fuck off, dude.
Yeah, look how upset you get.
Just
How can you tell exactly?
It's anger. It's frustration.
Irritability, lack of self-control, inability to engage in a good-faith conversation.
Low T, and he wants everybody else to be like him, basically.
Yeah, that would be cool if it was original, but you're just saying what I said, so maybe think of something your own.
You didn't say that. Are you hallucinating now that you said
that? Like 3 times that you're trans and you're on estrogen, and I told this guy he has low T.
Yeah, you're low T, obviously.
He's getting emotional again. Don't worry, I'll mute myself so you don't have to
projecting the whole time. I mean, look, you got your pennies in a twist. Oh, he deafened. Look at that, he had to plug his ears, but he's the big man, the high T guy in here.
Oh, Booger, I want an emotional
You also took the rage
title. Give me one.
Yeah.
Oh, you can't hear me? Oh, no.
Yeah, he plugged his ears. It was all getting to be too much for him. At least he knows when he's got to, take a little time out. Little timeoutsy. I'll be okay. Did you have your timeoutsy? Feel better now? You gonna be okay? Gonna be okay, Booger?
Hold on, Booger. You need to give me an emotional title. What's mine? You give me an original one. Come on. I know you got one.
I don't even know who you are, dude. I've never even spoken to you, so, yeah.
Well, that's okay. I mean, you just make it up no matter who you're speaking to, so what does it matter?
No, yours is earned.
You wouldn't know. You're absolutely delusional. Like, just to the hilt. So anyway, just go ahead and make it up like you always do. Your whole worldview is delusional, so you don't need to know who you're dealing with.
Oh, you know my worldview?
Well, I've spoken to you enough to have some idea.
Oh, what's my worldview?
You think you're living on a spinning ball with gas stuck to it in a vacuum chamber, all kinds of insane, hilarious nonsense.
It's not inside of a vacuum chamber, no.
I'd imagine your worldview is the government never lies.
What's it inside of? It's not inside of a vacuum chamber. What's it inside of?
Inside of? I mean, I guess you could say the universe?
Was it a vacuum?
The universe is inside the universe.
It's a near vacuum. It's not a perfect vacuum, no.
Okay, yeah, but there's no such thing, so you don't even need to be that pedantic and tell us that.
It's certainly not a vacuum chamber.
So you said it's not a chamber. So are you claiming an uncontained vacuum then?
Yeah, in the way that you mean contained.
Can you evidence that? Can you demonstrate an uncontained vacuum?
Yeah, you can look into space anywhere around.
That'll be circular reasoning. That'll be circular reasoning, sir. Is that the best you got?
So if somebody told you, like, hey, can you point out a car, and they pointed at a car, you would say that is circular reasoning, just so I can understand?
Oh.
Because I think you don't understand what these terms are.
If you said, like, the car was made out of hay bales or something like that, and then you went, yeah, okay, I'm pointing at it, there it is, it's made out of hay, and I'm like, no, it's not. That would be circular reasoning. So that's what you just did. You conflated
no, but
your
I mean,
story.
if the car was made
hold
out
on,
of hay,
hold on a
and I
sec. I was
pointed
almost
at it,
there.
then
I
it
was
would
almost
be.
there. I was almost there. I know you had to cut off. I know you had to cut off that part where I was just getting to the end.
Oh,
so,
here we go with the emotionality. I'm going to let you do your emotional thing.
Yeah, this would have been done already. Just shut the fuck up. So it's when you point at the sky and then conflate the sky with the story.
Shut the fuck up.
Yeah, so you just shut
emotional.
the fuck up, dude. Yeah, no, I'm just. This would have been done already like 5 times ago. So if I point at the sky and then conflate my story with the sky conflate my story about the sky with the sky, then that would be circular reasoning, like what you've just done. Yeah, so don't conflate the story you have about the sky with the sky itself. They're distinct things. We're trying. Yeah.
The 5-year-old child is deafening himself and unmuting himself and indefinite. It's just being a child.
Okay, so he doesn't actually want to know what he's trying to argue with. Wow, what a complete moron.
No,
I
you
just
think he would at
want to
least
hear
want to
you
listen
yap,
to
Heretic,
understand.
to be honest. I just don't want to hear you yap.
Yeah, but I pointed out the error in your reasoning. Okay, so you have a story about something that you're conflating with that something, and that's the thing that needs to be verified. You can't just point at the thing and then declare that your story that you made up about it or somebody else made up for you is necessarily true. Okay, he can just go on mute. Yeah, let's just keep him like that.
Yeah, as soon as he deafened himself again, I'll just mute. I don't want to even listen. Okay. Don't get to talk either then.
Yeah, he did make it a lot harder to say that one last simple sentence than it should have been.
It's always right at the end, dude.
That seems to be all they can do.
Yeah. I don't want you to get to the humiliating parts of that story. No, don't finish it. I look stupid.
Yeah, it's like if I was claiming a horse is a unicorn and I'm like, oh, prove that. And I just point back at the horse and say, see, it's a unicorn. That's what this moron just did. See, it's a vacuum. No, I don't see vacuum. I don't see a void of nothingness there. That's not what I necessarily see. I don't know what the fuck it is. You got a claim of specificity about what it is that's still lacking any substantiation.
It's quite hard to say. Well done. Quite a lot of S's in there. Alright, is there anybody else we can talk to? Anyone else at all? Here's Coomstones.
So have you guys figured out what causes the gas pressure gradient yet?
Yeah. I've been in here a while. I've just been listening.
Why would we make a claim about gas pressure gradient necessarily? Just, giving us gas pressure is already conceding the point. A force that necessarily depends on a container by definition. So, I mean, once we have that, who really cares about a gradient of it? We already proved what we set out to.
Why does it necessitate what does the gas pressure prove?
Well, okay, so you changed your, all right, you're not going to ask that first thing you were going to ask. Well, it's, gas pressure, we can just swap it out for the definition itself, which is force exerted upon the walls of a container by gas.
I'm not really interested in definitions. I'm interested in what the gas pressure proves.
Well, that's what the gas pressure is a force on the walls of a container. So we're already talking about a container just saying that.
What is the argument? just say that?
If gas pressure, then container.
Okay. So how do you logically deduce that?
Modus ponens.
Go on.
Well, I just did, basically. That was it. If gas pressure, then container. Gas pressure, therefore container.
Okay, but why? Why?
Well, it's an antecedent consequent relationship.
Yeah, why?
Well, because it's required. The container has to be there first in order to have the force on the container, right? Right. I mean, how are you going to get a force on a container without first having a container? Like, I mean, what can I do to spell this out any better?
Okay. So you're saying the force on the container proves the container?
Yeah, it's an antecedent.
Okay.
Container would be the antecedent.
So how have you proved the container?
Right? Well, the force on the
there is
container.
force being pressed against it.
Yeah.
Yeah. So how have you proved the container? That the force is being.
There's a force on the container, right?
No. That's the thing
What do you
we're
mean?
trying to figure out.
There's not gas pressure?
Oh no.
You're saying there's force on the container.
Wait, so there's not gas pressure, is what you're saying?
Now you're saying the force on the container proves the force on the container. Or proves the container.
Well, yeah,
So,
a container will
how
be an
have you
antecedent
proved-
to a. Well, I mean,
How have you
to have a
proven
force
that
on a
there is
container, you
force
must.
against this container?
Well, because you have gas pressure, right?
Yeah, I can. So I can imagine there's gas, pressing against me, against the ground, against anything else I hold.
Okay. So there's gas pressure, you said, right? Yeah, okay.
Yeah.
So we'll just swap the term gas pressure out for its literal definition, which is force exerted upon the walls of the container by gas. So
Well,
then,
now you're jumping ahead.
obviously, in order to have a force exerted upon the walls of a container, you would first need to have a container, yeah?
No, I'll have
Clearly.
agreed to, right? There's gas pressure against me.
Okay. Gas pressure.
There's
So
gas,
that's force
bouncing off of
exerted
me.
by gas. Okay, yeah, right. So that's force exerted by gas
There's
upon
gas
the walls of its container. So you just
pressing
said there's
against the ground.
Yeah, you just said there's
Right.
force
You're saying
exerted
there's
by
gas,
gas
it's a
upon the walls of
container.
its container. Yeah, you just said gas pressure. So that's force exerted by gas
Okay,
upon
well,
the
if you
walls
don't
of
like
its
the
container.
if you don't like the term pressure, okay, we
Well, I
can
like it just fine.
change
What
that
are you
out.
talking
So
about?
there's gas pressing against me. Okay, most people will call it gas pressure.
Yeah, no, I'm just
You're
making
like
sure for
implying
clarity
something
we
else
understand
behind
what we're actually saying when we say gas pressure, right?
Okay.
So we're talking
So there's
about
gas
a force
pressing against
exerted
me.
upon. Yeah,
There's gas pressing against the ground.
Yeah.
But you're saying there's gas pressing against a container.
yeah. So the ground will be the
Have you proven
container.
the container?
Yeah. So the ground
Okay,
will
so
be
there's
part
gas
of the
pressing
container.
against the ground.
Yeah,
That's part of the container.
that'll be part of the container. Yeah.
Okay, where's the rest of the container?
Around it, all around, because gas fills its available volume. Yeah.
Okay. So have you proven that?
Yeah, that would be the antecedent of the force.
Okay, but hold on. You're assuming the container.
No, it's gas pressure, right? We already have understood together here now that there is gas pressure, right? So instead of just saying
Yeah,
gas
well, I
pressure,
can
we could just
so
say
I can agree
we
that
could
there's
just
gas
say
pressing
force
against me in
exerted
the
by
ground.
gas upon the walls of its container, right? Because that's the same thing, right? We just swap that out. Gas pressure for the
No,
definition.
you're
of gas
making
pressure.
a logical leap. Okay.
No, we're not, because
Your
we're talking about
conclusion
gas
does
pressure.
not follow from your premises.
What are you talking about?
Okay. So we've
My
got
conclusion
gas,
that there's a container does
gas
not
pressing
follow
against
from.
things. Okay.
Yeah, my conclusion that there's a
You seem to
container.
think that gas
hold on.
calling this gas pressure implies like a container around the world. I don't agree
Yeah,
with
because
that.
what's gas pressure?
So I can
what's
see
gas pressure? Yeah,
well,
because
that is
what's
when
gas
gas
pressure?
presses against things.
No, it's more specific than that.
Yes. Well, that's
No,
what I understand
no,
it to be.
Well, okay, here, just let me cite the definition for you because you're confused. One
Look,
second.
I don't need you to cite something.
One second. Yeah, I will
I
cite
don't care
it for
about
you.
this appealing to
You're
definition.
confused.
Okay.
Yeah, you're confused. One second.
No, I'm not confused.
I
You're
don't
just
care about the
lying.
definitions that the terms are using.
I do. Okay, well, that's what we're talking about. So I understand gas pressure as when gas is pressing against something.
Not just something. It'll be the walls of its container, or else you won't have the gas pressure.
Okay, well, you're assuming you're saying it's the walls of a container. Okay.
Yeah, no, I'm
So
not
then I
saying
don't agree
that.
we have gas pressure.
No, I'm not saying that. My citations are saying that. One sec.
Okay. So do you agree with every citation?
Yeah, if there's demonstration to support it, yeah. Because that's true. That's a fair point.
Okay.
Anybody,
So have you demonstrated
anybody can
this?
just say anything. Yeah.
Have you demonstrated that there's a container?
Well, we've demonstrated that you'll need a container for gas. gas pressure.
Around the entire Earth?
Well, if you want to cause gas pressure, you're going to need a container or pre-existing gas pressure, which will have to be contained in the first place.
Around the entire Earth?
Well, duh. How else is the gas going to remain in the same volume?
Okay. So have you proven this container around the entire Earth?
Okay, so it's an antecedent-consequent relationship.
So now you're going in circles.
Yeah, so to have the conversation is circular because you just keep asking for answers that you already got. So we have to keep resetting.
No, you're
but
not really
okay, here we go. Pressure of gas. Okay, so here we go. Pressure of gas. That would be gas pressure, just reworded, right? Is the force that the gas exerts on the walls of its container. Chemistry department, Elmhurst EDU. Yeah. So, okay, so if we're going to have
we've got gas pressing against me, against the ground, against you.
Yeah. So if we're gonna have a force exerted upon the walls of a container, we're first gonna need what?
Sorry, my mic stopped working for some reason.
Yeah.
It's weird.
We're first gonna need what? Yeah. Okay. So force exerted upon the walls of a container, you'll first need what?
So strange. I don't understand what's happening.
Okay. Well, he's cooked. Next. Hi, Opus. How's it going?
I'm doing all right.
Are you here to provide us your opus of globe proof?
I'm not here to prove anything. Just listen to the arguments.
Okay. Let's see if we can bring back somebody totally insane for you to listen to. 1 second.
No, I've listened to enough insanity.
Well, if you want to hear people defend the globe Earth, there's no way around listening to some insanity.
I know. I watched like 5 Simon Dan videos in a row.
Yeah. Okay, so you know.
I'm just like, yeah. I've heard. I don't know if I've heard all of the silly arguments, but I mean, I've heard a lot of them. And
yeah, it's tough.
all right, so are you Globers?
No. No way.
You are a flat earther?
Well, it's the only way to be.
Well, that's
water lies flat, so I got no choice. I'm stuck here in this world of flat water.
I mean, the only way to be is demonstrably untrue, but okay.
Well, I mean, I'm just saying that, yeah, I mean, I've got no Earth to exist on, as far as I know, but the flat one here, so. Guess it makes me a flat earther.
What do you think that the Earth looks like?
Like what you see outside.
No, I mean, like, does it go on forever? Or is there an edge?
Well, now you're asking me to imagine stuff for you. I'm sure your imagination works well enough to get it done.
No, I just want to know how you model the whole thing in your brain.
I don't. I just don't.
Oh.
What about you?
Me? Oh, I've got a very clear idea of what the Earth looks like. But that's
Why?
okay.
Based on what?
My own travels, my own experiences, pictures, education, principles, a ton of different reasons. But that's
So you
okay.
traveled all over the place, and you surveyed it, you measured it, and you found like some sort of shape to it.
I've literally circumnavigated the globe.
The globe?
Yes.
What globe? How'd you know that you were circumnavigating a globe? I told you that that was a globe that you were traveling around. What gave it away?
How do we know that we've got a container?
Is there gas pressure?
Against the container? I don't know.
No,
Can you define gas pressure?
Can you prove it?
Okay, well, can you define gas pressure?
What do you mean? Define gas
define the container?
Can you define gas pressure? Yes or no?
There is not a container. That's a fallacious argument.
Okay, guys, that was your last chance. We're going to talk to somebody new. If you're going to deflect from questions like that, you're just going to sit on the side.
I'm answering the question. There is no container.
Well, okay. I asked him to define gas pressure, so that wasn't the question. Do you want to try again?
Gas pressure is what you get from. It's a function of gravity.
Oh, can you cite that definition and back it with demonstration?
Yes. When you. Okay. Let me ask you a question.
With gravity, frick, where do we begin? Okay, I mean, what's gravity?
Gravity.
And we need citation and demonstration. My God, holy smokes!
Gravity is gravity is literally the bending of space-time.
Okay, at least you're correct within your own lore. Okay, at least you're internally consistent at this point. I appreciate that much. Okay, now what we would need is, fuck the citation part. Let's just have an experimental demonstration of bending and warping of space-time causing gas pressure. Could we have that? Well, I mean, that'll necessitate citation anyway, so just give me what you got.
Okay. What do you? I mean, that's a really big subject.
Well, why would you claim something that can't be demonstrated like that?
Demonstrated? What do you mean?
Somebody wanted demonstration of like an enclosure causing gas pressure. That would be easy to provide, right? I wouldn't have to scratch my head and be like, man, it's a big question. But somebody says the conceptual medium of space-time interacts with the physical world and causes gas particles to compress. Well, I mean,
the demonstration, the demonstrations would have to be within. I mean, I don't even know how I would do that within a pressurized system, because anything I could do on Earth, you already have a pressure affecting everything. Therefore, yes, you need a container on Earth to create gas pressure, but that's not. Because when you open the container, gas pressure will cause anything inside of it to try to find a sense of equilibrium. So I don't know how how I would be able to demonstrate that.
So you can only demonstrate gas pressure being caused by a container. So that's why we say it's an antecedent.
That doesn't make the premise untrue.
What premise?
We are able to demonstrate these things in microcosm outside of Earth's immediate atmosphere.
Okay, what things are those exactly?
We are able to show the basic principles and understand, so that we can demonstrate piece by piece how it all works. Can you demonstrate?
What are you talking about specifically, though? What are you able to demonstrate? Did you say beyond Earth's atmosphere?
We're able to demonstrate the effects of a gravitational field.
Okay, we are, like you and me.
Okay. How do you think that? Okay, so you are of the opinion that
who's able to do that?
No, let me finish. You are of the assumption that density is what causes things to fall down.
Why are you asking me about what I think causes things to fall down? No, I'm just going to stop you right there because you're going off the beaten path here. That's not what we're even talking about.
That's because the questions that you're asking are just.
That's not even what we're talking about. We're talking about gases right now. How do you contain them? Obviously, with a physical enclosure. You said a conceptual medium.
You do not need to contain them.
Well, that's just rabidly insane.
You don't need to contain. You don't need to. No, you don't need a containment.
What are you talking about? For gas pressure?
The gravity itself holds things in, which is also why we have certain elements that do escape over time.
Okay, so you don't need a containment for gas. Are you saying you don't need a containment for gas pressure?
You don't need a containment for gas pressure on a globe.
Okay.
No, you don't.
Okay, all right, on a globe. Well, that's fiction, so we don't need to worry about that. So what you said, okay, gas pressure, I'll just cite the definition because you wouldn't or couldn't or whatever. The pressure of a gas is the force that the gas exerts on the walls of its container. You're telling me that you can have a force exerted on the walls of a container without a container?
The definition you're giving. Why don't you tell me the entirety of what that says?
Yeah, my citation, its entirety, says the pressure of a gas is the force that the gas exerts on the walls of its container.
What type of pressure? What is the type? What is the actual type of pressure?
The gas pressure.
Generic gas pressure. It doesn't have any other qualifications for that.
Gas pressure.
You are either uneducated or dishonest.
What are you talking about? I just cited a university and gave you citation. I just gave you a definition from a university. How is that uneducated?
Because
I mean, earlier, just a minute ago, you said that a force which is defined by the walls of its container could be caused without a container by a conceptual medium that you can't demonstrate in the physical world.
On Earth,
I mean, who's uneducated here?
On Earth.
Well, where else are you going to demonstrate things? Where else are you going to demonstrate things, Einstein? On the moon? What are you talking about, dude?
Yeah, maybe.
No, not maybe. You're not going to demonstrate anything anywhere but Earth. Duh. I mean, unless you'd like to prove me wrong, go ahead. I'll hold your beer. Go on now.
Are you familiar with what's I forget what they used to call it, but it's a water sprinkler. You dip it in the water, right? And you put your thumb over an opening, you pull it up, and then you let go, and the water falls out. Why does the water fall out?
Because there's a buildup. It comes out.
There's a buildup. No.
Well, you said you're cutting off the flow, right?
No.
I don't know what you're talking about.
This water sprinkler it's a sprinkler on one end. It's a ball that's got a long tube. You stick it in the water. You put your thumb over the top of it. You lift it up and you let go of it, and the water then comes out only after you lift up. Or better yet, a straw. You stick a straw in your soda. You pick it up.
Holy shit! Okay, so we're talking about liquid.
Why does the water come out? Why does the water come out?
Because there's a space for it to fill.
No.
What are you talking about then?
Yeah, we can't have this conversation because you don't know basic physics. Therefore, I can't talk to you about advanced physics.
That's not why the water moves out. Because there's not a space for... Okay, yeah, run away. I mean, you made an opening for it to move to, so... The same thing that happens with gas if it's not contained. There's an available space, it just goes into it. Duh. Was that you, Raiden, on your alt? Sounded a little bit like you. I guess. Well, we have the other dumbest speaker ever to disgrace the internet now gracing us. That's Simple Jack. Welcome, Simple Jack. It's an honor to be in the presence of such stupidity.
Who was the guy was he talking about the guy earlier, just the last one, that you pick up a straw and you hold soda and the soda doesn't exit your straw if you hold the top?
That didn't even sound like the same thing that he was talking about with the hose.
Yeah, I know. I went back to I just went back to try to listen to it again, and then at some point he says, "You don't know physics," and then leaves.
Was he talking about suction? Is that what he was trying to get to?
Or negative pressure? So is the Earth negatively pressurized or something? I mean, it's too bad he left, but yeah, I have no clue, really. I mean, it'd be great. Do you remember what his name was? I can look again.
Opus.
Bogus?
Opus.
Oh, yeah, Opus, yeah.
I don't know. I mean, I thought he did a pretty bad job of describing, his scenario there.
Oh, yeah, it was a hot mess. That's what I think maybe that was his goal. Was his goal just to be, a hot mess, and then when you somehow didn't give the answer that he was thinking,
I thought he was talking about when you do that thing where you cover the end of the hose, to spray the water further, you cause more pressure or whatever, right? And yeah.
Yeah, like where if you put your thumb over the end of the hose.
That's what I kind of got from what he was saying. I wasn't really sure, but I don't know. And then he was like, you cover the hose and then you stop covering it and then the water comes out. Why is that? Because you gave it an area that it could move into? I don't know.
Yeah. Do you remember what his PFP looked like? Because there's a bunch of different opuses on the server.
I tagged it.
Okay.
What's up, guys?
Well, we had somebody say that gas pressure, physical phenomenon, is caused by non-physical, conceptual space-time interacting with the physical world.
I wish I had a little bit more context in that because I have no clue. I have no clue what that's about.
Globe Earth and space, crazy fucking sci-fi nonsense that these, fanatics
Well,
believe in.
I'm not flat Earth, but
But I mean, surely you have the sense to see that water lies flat, and that gas pressure must be contained, literally by definition of what gas pressure is.
Depending on how big the sorry, I forgot the word. It's late. It's not going to come to me.
That's okay. Don't worry. As long as I can pick up what you're putting down, it's all good.
Yeah, it depends on how big the body of water is. That's what I was looking for. Because if it's like an ocean, there is curvature on an ocean.
No, there's not.
I mean, yeah, you can see it.
All right, go ahead.
There is an
evidence.
Image.
Yeah, show us measurement of the.
Hold on.
Okay.
Water. It was like the ocean, and then I spelled that shit wrong.
Let's see a demonstration. Because as far as I know, that's just a thing people can say, but not a thing that people can evidence. Oh, the power lines Pontchartrain is what you're talking about. Yeah, I already know what you're going to Google.
Yeah, that. I saw that the other day, bro. That shit's cool as hell, bro.
Well, we see some sort of effect of the power lines appearing to dip off, but the water line itself is perfectly straight, flat, horizontal, straight across. I don't see any indication of any curvature of any water there at all.
That kind of shows that it's curving because you can't see past the water there, can you?
No, I don't think it does show that at all. Not being able to see something doesn't necessitate a curve. No, not at all. There's all sorts of optical reasons for why you can't see something. And I mean, we got other video from that same location where you see straight across the entire lake, which you shouldn't be able to do if there's a curvature drop there. So either way, you got yeah.
Could you link me that? That'd be sick.
Okay, 1 sec. Yep. Here it is on a different day, and those power lines don't look anything like that. It kind of just looked more linear there. And you can see all the way across, which there should be enough curvature that you wouldn't be able to do that. Looks like just another flat body of water. Some sort of lighting effect or something on that day. Miraging. Some sort of miraging type of effect. Or what? Well, I mean, that's just it. Yeah, the video quality is so bad, and yet you can still see this distance, which far exceeds that, which would be geometrically possible on the globe. So even with shitty optics and shitty quality, we can still debunk the globe. That's crazy.
Oh, here we go. Nah, that didn't help at all. I mean, it would have been helpful if I could actually see what was going on, but it's, bro, I can't even. I don't have good eyes.
Dude, you can see the other shoreline. Okay, let's see. How far across is Lake Pontchartrain there? Let's get the numbers up again, because it's been a while since I looked at this. 1 sec.
Also, you have to account for altitude, by the way. It looks like he's on top of one of the power lines. Or not on top, like he's like at the middle.
Oh, he does.
At like at the middle height of one, around somewhere.
Oh, let's get his observer height. He'll give it. Let me just skim the video again.
I don't feel like having a debate right now, so I'll come in tomorrow, probably at like maybe 5.
You've got some liquid courage in you.
To do. I'll come over at the weekend. I love talking to y'all guys. It's fun, man. Anyway, I'll see y'all.
All right. I love how they say, or how they bring up that the quality is shit. Because even in shit quality, you can still see more than what you should on a globe. I don't even need any decent equipment to debunk this thing. I could have my beer goggles on and see further than what the globe would allow me to. It's that easy. Using a beer bottle as a telescope. Oh, I'm not seeing further than I should with enough clarity. I need a nicer video. It's got to be pretty, or else the globe isn't debunked.
Good afternoon, everybody.
GB.
Oh my god, it's Crit. I'm not sure if he's here, but Crit, I'd like to introduce you to my friend Coom Staines.
Sounds like a degenerate.
Yeah, that name is pretty bad.
He's not a bad guy.
He is a bad guy.
Just because you bad guy doesn't mean you have to be bad guy.
Has he said anything yet that's bad?
Yes, his name.
No, I mean his character when he actually
Why don't you change my name if you have a problem with it? I literally don't have permission to change it.
Bro, you can change your name per Discord server even. Not even your profile, not even your account name, your server name.
He can't. You have to be a certain rank on the server.
Exactly.
So what? This server forces you to use your Discord name or what?
Yes.
Not until you hit a certain rank.
Oh, so I can change my name now?
What? Oh yeah, look at
I'm like
because you have a
rank
high
10.
rank in the server.
Oh. So does it just default to your profile name or does it default
Yeah.
to your account name?
Whatever I think it's your profile name.
Oh, well, good thing I picked a normal name.
Who's going to debate the final experiment here?
The final.
What's that?
What was the
final
experiment?
The last battle?
There was no experiment.
What's the final experiment? I never heard of that before.
Do you guys know what I'm asking? Will Duffy has put out an invitation to people to come debate the final experiment.
Wasn't that finalized like almost a year ago? Did they finalize that?
So I'm just wondering if anybody here plans to go debate it. Debate
what? What's there to
You're
debate?
talking about the Antarctica thing, right?
Yeah, you
What's
guys
the
know
debate?
what I'm talking.
Yeah,
you know what I'm talking about.
What's the
You know what I'm
debate? What's the debate about? What versus what? Did God make it? Did God do it? Did God part the clouds? Did he?
He's talking about an scientific expedition.
No, this is about a social experiment that really had nothing to do with anything other than that. So that's over. That the social experiment's done, and that happened almost like 9 months ago. So at this point, how is there still a debate? How is final not final?
Sounds like
at some point you gotta quit hitting the snooze button on that 15 minutes of fame.
No, I think this is going to be the end.
But
you've been saying that this is the end ever since that happened 9 months ago.
No, I mean the end of what? What would be the end of? Yeah.
Yeah, it's a final experiment that conclusively shows that the Earth can't be flat.
It can't be
an experiment. Really? What was a naturally observed phenomenon? What's the independent variable?
Yeah, I mean you don't have to worry about that. But okay, so it can't be a flat. What is that? What's a flat?
It has to be slightly curved. Then
I didn't say that. I didn't say a flat. Crit.
What is it then?
It falsifies the flat Earth. Crit.
What is that? Can I see that? What's a flat Earth?
Uh-huh.
Do you have that?
Falsifies the flat Earth.
I was just wondering.
Going to space.
Where's the flat Earth in the final experiment? Where was that part?
It sounds like a lot of cope there, Chris.
Yeah, I mean, I'm just curious. Where is it at? Where's that flat Earth part of the final experiment? Where was that at?
I was only asking.
A bunch of flat Earthers, and the flat Earthers all conceded.
I was only asking if people were going to debate it with
What's there to debate?
Will Duffy.
Debate what?
I was not asking. I was not asking that. No, I don't.
Well, he knows where to find us. If he wants to debate, he knows exactly where we're at.
He gave an invitation, which you apparently are aware of.
No, I'm not aware of anything this guy talks about at all.
Oh, okay.
Just that he keeps somehow. I would say that. Are we still going to be talking about William Duffy after this, or is this final?
Yeah, it's going to be final there that the Earth is definitely not flat.
Which is what you started with already.
So I looked into this, and they have proven that the Earth is not flat because they have the sun is out at full midnight. So either their clocks are wrong or flat Earthers are wrong.
Yeah.
Well, no, because their claim was the sun wouldn't set on a flat Earth. It's not possible for the sun to set on a flat Earth.
And that's true. It's not
you
possible.
Didn't see the sunset, so you proved the flat Earth.
That's not how things work. That's not how.
Yeah, you said the sun can't set on the flat Earth. It's not possible for the sun to set.
That's not what I said.
Yeah, that's what you said before. You said that on your flat Earth. On your flat Earth, the sun can't set.
You're misquoting, Crit.
Okay, does the sun set on the flat Earth, or the sun doesn't set?
That was not the test.
Which one? Okay, does the sun set on flat Earth, or the sun doesn't set on the flat Earth?
You seem to be.
Well, there's got to be one or the other. Which one is it? Does the sun set, or it doesn't set?
You seem to be really triggered, Crit.
Okay, I can be whatever you want me to be. No problem.
Stop.
What's the claim? On the flat Earth, does the sun set or the sun doesn't set?
This is kind of an indication of guilt, isn't it? When you react like this, Crit.
It can be that too. So on the flat Earth, we got a sun and the flat Earth. On the flat Earth, does the sun set or it doesn't set? This is your flat Earth now we're talking about, not mine. On your flat Earth, what does the sun do? Nothing? The sun just not relevant?
Yeah, you're just asking a question that wasn't asked.
Yeah, so it's being asked right now. So you're going to observe the sun.
Yeah,
you're going to observe the sun. Yeah, so you're going to go to Antarctica
you're being
and observe
dishonest.
the sun.
You're being dishonest.
You're going to go to Antarctica and observe the sun. What will the sun do on the flat Earth?
That wasn't the hypothesis, Crit.
It doesn't. Okay, so it doesn't do anything. Okay, got it.
No, that's not true either, Crit.
Okay, so it does something. Okay, what does the sun do on the flat Earth?
Your constant deception here
does it do?
Your constant deception here indicates, kind of a guilty conscience.
Okay, sure, it can indicate whatever you want, no problem at all. That is not a problem. So now on your flat Earth, what does the sun do? Does it set or does it not set on your flat Earth?
That's not the hypothesis, Crit. And you know it.
So what does it do? What would it do? Nothing or something?
It's not the hypothesis, Crit.
Nothing at all?
Be more civil about this. Like, you just keep asking him the same thing.
Crit
we got to figure out what's going on here. Which one is it? Does it set or it doesn't set?
Obviously, it sets on flat Earth and round Earth.
Okay, can I see how that happens? How does the sun set? How does the sun set on the flat?
Because
how does the sun set on the flat Earth?
It doesn't
he's
matter
not going to
how it
allow you to
happens.
talk.
It doesn't matter how it
Deeply
happens.
triggered
It happens
because Crit
sun goes away.
knows that the Earth Crit knows that the Earth is not flat.
It doesn't matter how it happens. The sun goes away on flat Earth, on round Earth, on every model.
Yeah, but that's
it
the
doesn't
question.
matter. It happens.
On a flat Earth, where does the sun go? When it's nighttime?
Where does it go?
Like, where does it go? Does it go the other side of the flat Earth, or where does it go?
It doesn't.
Yeah, where does it go?
It does go
none of
away
this is the
one way
question.
or another.
Right, so none of this has anything to do with the question I asked.
Okay, I'm going to just post the question.
Yeah.
What's the question?
So the question is, do you plan on debating Will Duffy?
What's the debate? About what? Young Earth creationism?
Right. You can go to his channel and listen to the announcement where he invites people.
Yeah, no, thank you.
Right, so you have no interest.
Unless I know what the debate is, I'm not going to just show up and be like, hey, I heard
you're
there's
going to
a
have to
debate
go there.
here.
Yeah, to find out,
it's like a mystery box. It's like a secret Santa.
It's not a mystery, Crit.
You don't know for sure. You have to pass. You have to debate before you know what the debate's about. So you can't prepare. You can't know anything about what's going on. You just gotta show up and say, "Hey, there's a debate." They're like, "Yeah." What's the debate about?
You can pretend.
There's
you can pretend you don't know anything about it. You can pretend you don't know anything about it, Crit.
What's the debate about? What's the topic?
Yeah, you can pretend you don't know. That's okay.
Is there a debate topic or not?
Getting any? All right, I'll take over for a second. They went to the Antarctic with like 50 people who all live streamed the sun being not setting for 24 hours straight.
Yeah, I don't know what that's about. Okay, so what's the debate about? What's the topic? The topic would be now the flat.
See?
What does that mean?
Sofa? See?
What is that? What is that, Brenda? What are we looking at here?
He's massively triggered. He knows that he doesn't have anything. He knows that he can't do it.
It's not a problem. So what's
That's
the
why
debate?
he has to talk over me so he can shut me up.
Just
because he can't handle it.
I want you to talk. Tell me
You're
what the
talking over
debate
me.
topic.
You're talking over me, Crit.
What's the debate topic? Just tell me the topic.
Crit.
That's it.
Crit, you're talking over me.
Okay, tell me the topic.
The
topic is what?
Are you going to interrupt me again?
Brenda, stop behaving like a news mate.
So I'm not the one, Mr.
All right, never mind. When you're ready to when you're ready to let me know what the topic of the debate is, we're good. Let's move forward. Because otherwise, you're just avoiding the topic. Your own topic. Your own. Like, hey guys, there's a debate on some dude's YouTube channel. Really? Wow. Okay. So, what's the topic? I don't know. You gotta go there to figure it out. Why would I waste the click? Yeah, Sofa, dude, what's going on? Are you okay?
Bro, why can't anyone actually like say something intelligent here? You guys are just going like, well, what is that?
I don't know what that means. Can you spell it out?
All right, I'm trying
Well,
to make.
Crit wants to get his point.
My point was that how could these people factually have seen the sun for 24 hours straight in Antarctica without a tilted Earth? And they did see.
Well, where's a tilted Earth then? Where's that at? Where's a tilted Earth at?
You need the Earth to be tilted for the sun to not set, like even in geometry.
Or a flat Earth, the sun wouldn't set either.
Why, how would the sun not set on a flat Earth?
That's what we've been told. We've been told since 2015 that flat earthers can't explain the sunset, and it's not possible for the sun to set on the flat Earth.
Because sun can set however it wants. Like if there's a flat Earth, that means that God's doing it because it isn't just a magically floating like flat plane. So that means it must be God, which means it doesn't matter how the sun is disappearing. It's however God feels.
That's William Duffy. William Duffy, on the Globe side, is a young Earth creationist, mega church super pastor. That's the guy representing your Globetard, a young Earth creationist. Why would I take your side seriously when your top debater is a young Earth creationist, mega church super pastor? Why would I take you seriously?
Isn't that like a straw man? I don't even know who this guy is.
It's not a straw man. I'm letting you know that the guy you want me to debate is a young Earth creationist.
I didn't say I wanted you to debate him, and I didn't know he was religious. I thought he was an atheist, like science guy.
Well, no, atheists are anti-science.
Yeah, but also
because atheists talk about belief systems. Belief is not required in science.
Yeah, I guess.
In science, all you need is evidence. No beliefs.
That's it. Yeah.
Yes, but the way you get that evidence is books and writing.
They don't believe in something that's irrelevant. It doesn't matter. You're supposed, if anything, you're supposed to factor out your belief systems, not factor them in. So atheism are science denialists. They can't even follow some kind of scientific method because they've already baked in belief.
So I'd say science is a belief because the empirical evidence is a fact, but you don't have access to that. You don't have access to most of the 99% of all experiments other than like buoyancy, thermodynamics. You can do that at home easily, but everything else, you're just reading a book. And, you know, the experiment's correct. It is true, but you have to just believe it or do it yourself. But you can easily experiment that like hot flows to cold.
Did Brenda run off?
No.
Okay, well, get Brenda back in here. Shit.
But like science itself is kind of a belief because I don't have like enough time to do every experiment.
What do you got time for?
Well, like if I drop something, it goes down, and that's a fact no matter what. On where I live, if I drop something, it goes down. Period.
Yeah, and how has it been proved? Throughout science.
Newton's
laws. And nowadays you can prove things way easier due to the help of quantum computers. Calculating the possibility of stuff happening and shit, you know.
A quantum computer proves things?
No, not that, but like, for example, let's say you have like a scenario and you want to see like how likely this the outcome is, you know. And you can like ask it, I don't know, like 1 million times, then it will give you an answer, like, I don't know, 60% no and 40% yes. And based on that, you can, like, kind of think, like, oh, is it really worth thinking about that whatsoever? Then people are still trying to search for evidence for such a thing. Sorry if my English is not the best. I am very tired at the moment.
I missed out on like the last 2 minutes.
Yeah. What is the experiment? What is that? What's the experiment going to be?
That if I drop something, it will always go down 100% of the time, no matter what. So we can
you lost
say
me.
that if
you lost me here.
I'm saying,
so what's the experiment?
In my house.
Experiment's dropping something.
Yeah, if I drop something, every time I've ever dropped something, it goes down. So therefore, if you drop things, they go down on Earth where I live. And you don't need, like, there's empirical science. I don't even need a theory or to explain why it happens, but you can like accurately predict how fast it's going to fall in a vacuum, etc. And you don't need to explain why or if God's doing it or not. It can just be a fact.
God did it.
What?
So God can do things?
Well, sure. I'm just saying it doesn't matter if God did it or not, or why it's happening or not. It happens. Perfectly the same every time. So, therefore, things are attracted to other things for some reason.
Not only for some reason, but because of gravity.
Well, I agree with gravity. I'm a scientist, but I'm just saying you don't even need science and books and all of this. You can just experimentally verify something, and that's just how it is, and there's no way to argue against it. You can argue against the model and what space-time and all of this, but you can't argue the effect. But I see lots of people that are like so anti-science that they don't even want to agree with the effect. They're like, no, actually, like, things don't even go down.
Down to the?
Yeah, and it's like either God's doing it or this is the way the universe is. Either way, it's the same thing. It's the same effect.
Not everything goes down.
Are things going down to the or up to the?
They are attracting to other things because we can actually test that, like even in the 1800s.
So what is being attracted to what?
Mass is attracting mass magically from infinite distance somehow.
What experiment has shown that mass attracts mass?
Give me a second. I forget. It's a French one.
You mean Foucault's pendulum, dude?
Yeah, exactly. And no, the Cavendish experiment.
Sorry, not Foucault's. Yeah, Cavendish. My bad.
Yeah, and modern, much better Cavendish experiments also have been done.
Do you know why the Cavendish experiment was originally created? Have you ever done research on that?
I've read the whole
because
thing.
Because I can tell you right now, it wasn't to show that mass attracts mass.
What does it show then? In your opinion?
I'm pretty sure that they tried to use that to determine the density of the Earth or the mass of the Earth.
That's just a side effect of like the experiment. The experiment proved a couple of things, actually.
It was someone ping Brenda. Let's see if we can get a conversation about this final experiment debate thing.
You guys know what prediction. It is?
I'm just kind of curious. Where was the flat Earth in it? Like, can someone show me this flat Earth?
Okay, here's what happened. They brought like 30 flat Earth, famous, like fairly high level flat Earth researchers. This rich guy
not flat
brought
Earth.
them
Okay,
to.
I'm not talking about people. Okay, listen very carefully to my question. Show me the flat Earth in the final experiment, not people, not like where what someone's did or what someone said. I want to see the flat Earth part of the final experiment. That's it. Nothing else. Nothing more. Okay. So supposedly was the flat Earth versus a globe Earth.
Right.
They won't show the globe Earth. They'll never show that. So can I see the flat Earth?
The globe Earth, like logically.
They never showed it though. Where's the globe? Where was that?
What are we supposed? You don't believe in rockets, so how are we supposed to show it?
What does that mean? I don't believe in
space
rockets.
travel or satellites.
Okay, what does that mean? I don't believe in space.
If we send a rocket up, here's Earth, here's a picture of it, then you're just going to say that's fake. So how am I supposed to show you the globe?
Okay, don't worry about that. Just where, since he won't show the globe Earth, can I see the flat Earth?
All it was is an experiment to prove logically that the Earth cannot be flat. He doesn't.
Okay, can I see the flat Earth?
It's mathematical geometry.
Where's the flat Earth at? Where's that at?
It's mathematical geometry. They're doing the flat Earth cannot possibly
mathematical geometry. Okay, perfect. I love math. I love geometry. Can I see the flat Earth? Where's that at? Where's the flat Earth at?
I don't know what you mean. The experiment just proves that
they did an experiment that's supposedly going to show the flat Earth versus the globe Earth. They flat refuse to show anything related to a globe Earth. Can I see the flat Earth part? Where was that at?
What do you mean by see? Like a picture?
Like whatever it is, whatever you got.
All right, the experiment had nothing to do with flat Earth. All it did was prove that the Earth. All it did was prove
nothing.
The Earth.
Okay, there's nothing in there related to flat Earth.
The Earth. All it did was prove the Earth wasn't flat. It didn't prove that it's round.
How do you know
globe.
what it is? What is a flat Earth? What is that?
A completely flat plane.
Okay, can I see that?
How am I supposed to give you a picture of that?
I don't know. You had to have judged it versus something else. Where's that at?
We just have geometry. If the sun doesn't move, then the Earth cannot. If the sun doesn't move at all, then the Earth
the sun
cannot
doesn't
be flat.
move now. I see the sun move.
Right, but if you go to the North Pole, South Pole, the sun doesn't move in the summer.
It doesn't move. Really?
For a certain, like during summer equinox, it just basically doesn't move. Stays in the sky for 24 hours.
So they went there during the equinox?
Let me see.
You might want to look this up.
Yeah, I looked at the whole experiment.
No, they left before.
Right, but you don't get it. Their experiment doesn't.
Yeah, okay, I don't get it. Okay,
it doesn't prove that they're right and it's a globe. It just proves flat is wrong.
Okay, what flat? What's a flat? Where's that at?
It's not. They're not proving flat. They're disproving that flat is possible. Because
where is that? Where's the flat part?
Because if you have if you have the sun and the sun's moving over the flat Earth like that, like it says, it has to be moving. If the sun is completely frozen, if the sun is not moving, the only way to explain that is that the Earth is tilted.
Okay, so the sun does move.
The sun is under flat Earth. The sun, obviously, under both flat Earth and globe Earth, the sun is moving.
So sun moves. Okay, then what happens?
Okay, for flat Earth, the sun is moving. The model is the sun moves over you. The Earth is a flat plane, and the sun moves over us, or God's sun. So if they went to the North Pole and the sun doesn't move, then geometry-wise, this Earth cannot be flat. It doesn't have to be round. It doesn't have to be a globe, but it can't be perfectly flat if the sun's stuck. You get it? It's like a geometry proof that they're just proof that it can't be perfectly flat, like no matter what.
Okay, where's that at? Perfectly flat.
They're just proving it's not perfectly flat because of geometry.
Okay, where is that at?
I don't know what you mean. Where is it at? They don't know where it's at. They're just proving it can't be this way.
So it can't be perfectly flat.
Right. It could still be like not actually a globe though under this model.
So it's curved then.
Yeah, it has to have some amount of curve.
So where's that curvature at?
We don't know. All we know, all this experiment proves is there must be a curve. No matter what, there has to be a curve geometry-wise.
Where would the curve be?
Doesn't matter. Who know? Well, we know. I know. We have lots of science for this. We're talking only about this one experiment. All this experiment does is prove the Earth must have some amount of curve.
Where is it at? Where's the curve at?
They couldn't prove that.
Uh-oh.
Doesn't matter. It's proven that it must have some curve by the laws of geometry.
Where would the curve be at?
The experiment didn't have to prove that. It doesn't have to win on everything. It just has to win at one thing.
Let me get this straight. It has to be curved, but you don't have to prove it's actually curved.
Right, because there's no way
So
for
we
it
just
to be
have
flat.
to believe, right?
There's no way for it to be flat and for the sun to stay in the sky permanently all day. It's not geometrically compatible.
Because
if it was flat and the sun was moving across it, there would never be a time when the sun was out permanently.
That's true.
Okay, so the sun does set on a flat Earth. Can I see that?
If the Earth is the sun doesn't set on flat Earth because we.
Okay, so they went to Antarctica. The sun didn't set. Okay, so that's
even
flat
if the
Earth.
Earth was flat, it still didn't set.
Okay, so it doesn't set on a flat Earth.
It doesn't set on a flat Earth or on a globe Earth.
Okay, so what did the sun do?
If you're tilted enough, you can see the sun forever.
Forever.
Yeah, if you're on a globe and if the globe is tilted enough towards the sun,
a globe,
the sun
where's the
never
globe
goes
at?
away.
Crit, are you special needs with all these constant questions? You sound like you're like disabled.
Okay, that's all right. I can be disabled, no problem. So where is it? Where's the experiment at then? It did what versus what?
It showed that the sun, because the sun is never setting for a full 24 hours in Antarctica in the equinox, therefore the Earth has to have some amount of curve.
No equinox. They didn't do it in the equinox.
Well, they did it near then, and that means that the Earth must have some amount of curve. It can be a small amount. The Earth could be fucking way bigger than you say it is with a smaller curve. It could but it has to have some curve, or else the sun would set in Antarctica, or eventually.
I think you beat him.
This is a hot mess.
Yeah, bro, the semicircle Earthers are winning against the...
Where is the debate here? Because the question was that flat Earthers need to go to some YouTube channel because they've been invited to debate a topic, but no one knows what the topic is. They've never been, they don't know where it's at or what the topic is about. They can't show you what would be the two different versions of flat Earth or globe Earth. They can't show you what the flat Earth is, and they can't show you what the globe Earth is. The only thing they can do is they can make a claim that the Earth can't be flat, but it can be curved, but they don't show the curve and they don't show flat.
Yeah, now you got it. You finally got it. It wasn't that complicated. It took you 30 minutes, but you finally understood.
This is
you finally grasped the concept. It took you so long to understand something so simple.
It's a hot mess.
That's what they did.
That is a hot.
So let me ask you a question, Crit. When you go and you make an observation, does a singular observation need to answer all of your questions about the nature of reality, or could it be specific to one question?
Yeah, it's the same answer.
Okay, so you can make an experiment just to answer one specific piece of reality. You can make an observation about one specific part of reality at a time. You don't need to answer every question with one observation.
On the
do you understand that concept? Or do you think that every observation needs to answer every single question?
Is it an experiment or an observation?
It's an observation. Do you think every observation needs to answer every single question? Yes or no?
It's an experiment or an observation?
Okay, are you going to answer the question? Or are you just going to sit here and keep playing 20 questions, asking questions, and not answering any? I already answered your question. Are you going to listen? Yeah, you need to shut your mouth and be able to listen because you're acting like a petulant child. So listen, here's the question. Here's the question, Crit. You've already asked your 30 fucking questions in a row. You're asking the same questions over and over.
You already asked
so now is the question.
Listen, observation, mate.
Does an observation need to answer every single one of your questions, or could it be specific?
Is it an experiment?
No, this is what you're trying to figure out because you're slow.
It's an observation. You said that.
It's non-experiment.
This has been made clear to everybody with more than 60 IQ, but apparently for you, it's very complicated stuff. This is no wonder you think the Earth is flat. You can't even have a basic conversation in track.
An observation. Now there's
no Crit. Obviously, speaking with you, Crit, is literally like worse than speaking with a child. Like you are literally disabled mentally. You are mentally disabled. There is no wonder. Yeah, there is no wonder that you can't. There's no wonder you can't grasp this. You ask the same question 40 times in a row. You get the answer, and you just keep asking the same question, just like a retard.
You're mentally disabled.
Yeah.
You want
that's what I said about you. See, now you're just repeating what I'm saying because you literally have no original thoughts of your own.
Go to a YouTube channel to debate a final experiment.
The YouTube channel. Who cares?
You are literally a broken record. You are literally a poster child of fucking Dunning-Kruger effect, bro. You are a literal retard. I can hear it in the way you speak too, with your fucking little weird voice.
Absolutely,
you keep mentioning the YouTube shit that no one's ever brought up. Like, stop.
Yeah, that's what the whole topic.
He literally has to just sit there and rant and say the same thing, ask the same question 60 times in a row because he's got nothing. This guy's entire personality is literally the flat Earth. If the Earth ever got proven to be round, he would literally have to kill himself.
Final experiment. That's the topic.
For the love of God, please get off of your high throne and get in touch with reality, okay?
Okay, yeah, ditto.
Be honest. Are you rage baiting? Or are you being dead ass?
No, he can't be honest. The dude is literally 60 IQ.
There's no way
Stop
you're
asking
being
him to be
serious
honest.
right now.
Yeah, go away then.
He is literally 60 IQ.
Crit, even fucking Beetlejuice is smarter than you.
Maybe he's just a solipsist.
So now you know that there isn't an experiment, there isn't a debate, there wasn't anything to talk about. It was just some random meth-fueled symposium by a young Earth creationist. So now you know, no thank you.
That guy's been gone for so long. Like, oh my God.
Bro, you are literally just arguing with the ghost. You are so stupid.
God.
You are so stupid.
Wow.
That guy left. The guy that brought up the final experiment thing, that was like 30 minutes ago. He's gone, you retard.
Oh, no.
Yeah, see, look at how you act. You literally act like a child. This is incredible.
I would give Crit
he's
some
gonna keep doing that whoa thing. Like he literally's got nothing in the chamber. He's literally shooting blank.
Is it an experiment or an observation?
Yeah.
It can't be. It can't be.
Call a vote.
But Crit,
bro, we need democracy in this room.
Wait, give Crit some credit because he hasn't muted somebody, and this is like the longest it's ever been since a mod didn't mute anybody.
Dude, like, what's the point of muting you guys?
I think Crit is too mentally challenged to be able to figure out how to mute somebody.
Oh no!
No.
But Crit,
here we go with the oh no. Literally, he literally cannot even think about his
you got me blocked. You self-muted in your own DMs. He self-muted. This is how stupid this guy is. He's always worried about moderation, and then he self-mutes in his own DMs.
Doesn't look like a self-mute.
Yeah, he self-mutes.
Why'd you remind him that
he's not a mod? You muted him in his. You muted him in this channel. Are you?
Now, while all you blowcards are having a fucking meltdown, it was not Crit that muted him. It was me, because you had a shot at the mods. You have a dig at one, you have a dig at them all. We will run the channel how we see fit. If anyone has a problem with that, no one's holding a gun to your head forcing you to be in here. So go away, little children.
You sound emotional.
No, I'm not emotional.
Like you got hurt.
My point is when somebody answers your question, why would you ask the question again?
I didn't ask the question
afterwards. Again. I wasn't talking to you.
We're talking to Crit.
Yeah. Because before you joined, he continuously asked like 20 fucking times, is it an experiment or an observation?
That's what I'm saying. You keep switching it. The problem is you're not consistent. You go from observation, then the next sentence you call an experiment, and then halfway through the sentence you switch it back to an observation.
This guy is muted.
It's amazing. You can't even stick. Which one is it? Is it a final experiment, or was it just a random observation that had nothing to do with anything? You got to pick which one. Make a decision. Stand on your toes like a man, and say yes. This was an experiment. Perfect.
Yeah, Boomer answered you like 5 times, and now he's muted, and he's been consistent.
How was an experiment?
Bro,
you gotta unmute.
He said it wasn't an experiment. He said quite literally and very clearly in plain English that it was an observation, not an experiment.
At that point, there's nothing to debate. All you did was make an observation. There's no debate there.
Yeah, you can debate an observation.
No, this is Newton's flaming sword. You have to do an experiment to debate, not an observation.
Why don't you unmute the guy that you're talking to? Why don't you debate the guy you're talking to, not mute him?
I wasn't talking to anybody.
Yeah. You're talking to Booger.
No, Booger's got me blocked. So, yeah, Booger is shit scared to talk to anybody.
Booger was talking to you. What do you mean? In messages, DMs doesn't matter.
He's talking to you up until he got muted.
Booger is freaking out.
No,
another mod jumped in. I told you. Another mod said, "Hey, this guy's too far gone." So,
right. So you're smart enough and brave enough. Wait, then disprove Booger, unmute him, and debate him.
Booger was actually just running away.
And this is what's going to happen in the very near future. I'm going to go through and mute the shit out of everyone and unlock you one at a time. If you wish to converse one at a time, please do so. I don't want to hear 6 of you talking at once. It's starting to piss me off. So, Sofa King, you're at the bottom of the list. You're first. Have you got any proof of curvature?
Yes. The final experiment were like 40 different people, and 20 of them were actual flat earthers that still are flat earthers. They had like 50 people. 30 of them were actual flat earthers who are still flat earthers now, who recorded the sun being up. 50 now. They recorded the sun being up for 24 hours with their own cameras, with independent flat earther cameras.
Okay, that's great. You do realise the sun's not the ground. We've measured the ground as flat, so you can point up to the sky and go, "Oh, look, sun, moon, stars, all you like." It doesn't prove the shape of the ground.
Wait, but we've measured that it can't be possibly flat, so we're at an
No. You've inferred that it can't be possible. What you've got to go and do, if you want to prove the shape of the ground, you measure the ground. You don't point up into the sky and then go, "Well, the sun's doing this, therefore the ground can only be a particular shape."
Okay, we've done that too. We've measured the loss in elevations between as the Earth is curving.
Where and when was this done?
They take 2 different areas and shoot a laser between them, and then or camera, and then they can see why is this building 30 feet lower, or why is the side of this?
Why would you be measuring a building? A building's man-made. Why wouldn't you measure a surface that's supposed to be flat?
Okay,
for example, water.
Sure. Yeah, sure. A lake. Lake Tahoe. You can't see over Lake Tahoe because it curves 20 feet down.
And how wide is Lake Tahoe?
At the place that they're measuring it, 25 miles.
So if it's 25 miles and it's only bending down 25 feet, where's the extra 200 foot that it should be bending down? Wouldn't you turn around and say that 20 feet that you've already got could be some kind of mirage effect?
No, we're using lasers and other actual measurement, like
I get that.
Wires.
This is what you're not understanding. Grab hold of an Earth curve calculator, and then when you shoot your laser at 20 miles, there should be a very specific distance between the laser and the water. Do you agree with that?
No, it can vary depending on how lumpy the crust is. of the Earth.
You're talking about water.
Right.
Excellent. So the water is supposed to be following the shape of the Earth. Yeah? Now, all we're doing when we shoot a laser across is creating a tangent to a circle. That's all it's supposed to be. Now, as you know, where that tangent touches the circle, some people call it the tangent point. From the tangent point, as you go further along that tangent, away from the tangent point, the gap between the tangent and the curve should increase. Do you agree with that? Yes or no?
So what you're saying is there would be...
No,
be able to see
I'll try again.
Wait.
You've got a circle. You put a straight line next to a circle, that's called a tangent. So where it touches, that's the tangent point. So as you go from the tangent further along the tangent line, away from the tangent point, the gap between the tangent and the circle will get bigger. So when you are 1 inch away from the tangent point, 2 inches away, 3 inches away, the gap should get bigger and bigger as you get further away. Do you agree with that? Yes or no?
Yes.
Excellent. It's very simple stuff. So when we go out into the real world and we start looking at tangent points, we take a laser and we shoot it across a large body of water. At 10 miles, there should be a 66-foot drop. This is assuming, of course, we're on a ball with a radius of 39, 59 miles. You go to 20 miles, it should be a 266-foot drop. You go to 30 miles, it should be a 600-foot drop. The issue is, my friend, we're not getting these numbers that we should be getting if the claimed radius is true and correct. That's the problem.
But we are
we're
getting
not.
some drop. We are getting some drop, so maybe that radius
Okay,
is
so
incorrect.
think about it logically. If you're expecting a 600-foot drop and you're out by 2 foot, do you class that as a win for the ballers? In light of how much times ballers have come in here and just squawked for a fraction every single time something doesn't line up.
Who's a baller?
You should expect, at 30 miles, you should expect a 600-foot drop. That's how much difference there should be between the laser and the water line. 600 feet, not 20 feet.
But what? Okay, so it doesn't matter if our version of how big the Earth is
It
wrong.
does matter.
It's still some
stop.
amount of curve.
You're defending a very particular radius. The alleged claim is 39, 59 miles. If you claim something else, that puts you into the flat earther camp. You're on our side now.
So, the Lake Tahoe does have the approximate amount of curve that it should have according to our model, though.
You didn't know what it was a minute ago, so all of a sudden now you're claiming a model.
Well, you told me that it was...
You said it was 20 feet drop. 20 feet over 20 miles. Jump on and look at an Earth curve calculator. You tell me how much drop there should be at 20 miles. We already know it should be 266.67 feet.
Yeah, it's 267.
And you're saying it's 20 feet.
No.
So where's the other 247 feet?
All right, I said it was at least 20 feet. It's 220, and it's reduced by 14% because the lake itself is slightly lumpy. And the shore is slightly
The
higher
lake
on one
itself
side.
is lumpy.
Like, not the water, the
So
line.
post up where you got this information from.
So, what? What do you mean?
In the side chat,
it.
post
I personally verified it myself with a laser at Real Lake Tahoe in California.
So you got no. All I've got is your word. That's it.
Yes. And
observable, measurable, repeatable. So basically, you're just coming in here saying, "I think this, therefore it's true." Done. Fuck off the rest of it. That's it.
It is repeatable. It is observable and measurable.
So who's repeated it?
Me.
So you've repeated this multiple times. So you've got no video footage that you can put up for us? No photos that you can put up for us? Absolutely nothing. You've gone out there and the first known person in history to ever actually measure this is curvature, not just calculate, measure. You are the first person in history and you never thought to take one fucking photo.
Well, it's not a photo. I couldn't even see that far. You need a laser for this. What do you mean
So how did you know what the laser was hitting at the opposite end?
You have a receiver.
Who was the receiver?
Person on the other side with a balloon.
And who did this?
Me and a friend.
You know what I'm calling? Bullshit.
So let's, all right, assume
no, don't talk that, but I'm fucking calling bullshit. I think you're a lying sack of shit. There you go. Sold.
All right, if you stop saying I'm lying, assume I actually did this and got the correct results. Could I believe...
I'm not assuming. I'm calling you out. You're a liar.
All right.
Matrix, are you having a fucking stroke at this point, or what is happening?
All right, you don't have to believe me, but if I saw this information and did test it and repeated it and did the test correctly, I could believe the Earth has some curve, some amount. I'm not going to extrapolate the curve that we got to the whole fucking planet. But
when did you do this?
It has some curve. In 2018.
So let me get this straight. You've been coming in and out of here for the last multiple weeks, and you've never ever brought this shit up before. Why not?
What do you mean? I haven't.
Because you're a lying sack of crap. We know why.
I've been talking about fucking laser. I've been talking about fucking laser measurements the whole time I've been here, and you guys won't listen. You guys won't listen to my weather.
You're full of shit because you'd back it up with something.
I've talked.
Anyone of our guys here will back up any of the laser tests that have been put down.
Okay, mate, let me give you another example, okay?
I literally talked to the ISS space station, bro. I'm high-level fucking space hobbyist.
Yeah, you're right. Next.
Mate, let me ask you a question, okay? Let's assume
who's talking?
you stand at the harbor...
I'm on my phone. Who is talking?
Colin. Kerbal Space Program without any milk.
That's what we're after.
So, let me ask you a question, right? Let's say you're standing at the harbor of, I don't know, Greece, okay? And
what am I doing?
Or just standing at the harbor with a very, very good goggles or like telescope. I don't fucking care. Something that can like see the distance very, very far. Like let's say, I don't know, 100 miles or something. You know, like some shit you would use to like look at stars with. All right, and you looking at a ship, okay, and the ship is sailing away. Sailing away.
Why would I need a high-powered optic to do this? I can just stand at the beach and watch ships sail away. Congratulations. Awesome.
No, what I'm saying is, over the time, you will see that you can see less and less of the ship.
Excellent. Do you know why this happens?
Yeah, because the Earth is not flat.
Wrong. What happens is, now we're going to break it down nice and easy. While you're having a meltdown, you can just mute yourself up for a second and have a listen. So what happens is, when you watch the ship sailing away, you're not talking at the moment. Colin, just hold up for a second. I'll explain it to you. It's very, very simple. First of all, you've got this thing called perspective. So what happens is, as things get further away, they appear... You finished now? You had your little meltdown? Okay, right.
Yes, sir.
So as things get further away, they appear to get smaller, as per perspective. You know that. We all agree with it. We don't have a problem with it. Now, what happens is, because of you being a lot smaller than that great big ship, your eye line is slightly above ground level or water level. So I'm going to assume you're 6 foot tall. So that means your eye line is 6 foot above the water. Now, we have this effect called foreshortening. So what happens is, everything shrinks at a consistent rate as it gets further away. But the problem is, because your eye line is at the lower portion of the ship, in this case is what you're witnessing, because everything shrinks at a consistent rate from the top, from the bottom, from the left, from the right, because you're closer to the bottom, it will appear to disappear bottom up. And that's all that happens. Everything still shrinks as per perspective, but because you're closer to the bottom of it, that will appear to disappear first. If your eye line, if you actually are higher elevated and looking horizontal, as ships get further away, they disappear from the top down and also all other weird shit. So, yeah, it's just called foreshortening. That's all. Not
potential flat Earth. I think that probably would happen, but that still doesn't prove that we're on a fucking flat Earth.
It still doesn't prove for your side that you're on a ball type. So you coming in going, that doesn't prove we're on a flat surface. I mean, the reason we say that, the reason we say that is because we can actually generate this exact same effect on a flat surface. That's how we know it's not from a ball. It is from. It's just an optical effect. If we can replicate it on a flat surface and do it on a flat surface, that means there's some other cause to that effect.
There would be an optical illusion that would make the bottom disappear a little bit.
Excellent. So it's not curvature then.
Just because of the refraction of light around matter.
Because of the refraction. We weren't even talking about refraction. We were talking about perspective.
We're talking about how light bends around matter.
No, we wasn't. We were talking about perspective. How things get smaller as they get further away.
Where the bottom would become more distorted than the top.
No, that's not what we were talking about. Your ears are obviously painted on.
That's essentially what would happen, though. So.
Well, that's your assumption. So now you've got to go and validate that, verify it, put some kind of evidence in side chat. Post up some kind of evidence in side chat.
It's just funny. It's funny.
It might be funny, but you still haven't backed your claim.
No, keep going. Keep being funny.
We'll just listen to your comedy side of it.
I mean, mate, can you give me like any scientifically proven study that the Earth is flat?
Someone wanted a scientific study for what? I couldn't hear. That other rude person cut you off.
The Earth is flat.
What field of science deals with shapes, Colin?
With shapes?
What field of science deals with shapes, Colin?
I don't know. My English ain't the best to state that. I think geometry is the right answer in English. I don't know.
Is geometry a field of science? No. So why would I magically pull out of my right pocket a scientifically validated something to prove it's flat?
Let me translate that. Let me translate that in English.
Isn't it amazing how when they want to put forward their bullshit, they can all speak fluent English, but when someone explains something to them, all of a sudden it's,
Mate, I'm German, it's 5 in the fucking morning, okay? I'm tired, it's 5 in the fucking morning and I'm arguing with nooses, okay?
Thanks a lot. You are after a scientific study that proves this. Science doesn't study shapes. That's what I'm trying to get through your head. You measure for shapes. But anyways, Crit, my lunch break's over. I've got to go, man. All right. If you'd like to continue slapping, if they misbehave, just nuke them. All right,
yeah, we're trying to figure out what we're dealing with here. Is it? Do we got an experiment going on? Do we got an observation going on? What do we got? Don't know.
Wait, you still talking to Booger or what?
No, I mean just I was never talking to Booger.
No, you were, but then you got muted.
No, I wasn't.
Yes, you were.
No, I wasn't. No.
The fuck?
This guy is just denying exactly.
Are you calling all of us schizophrenic right now, or what?
Yeah. I was talking to just anyone in the room who wanted to know. Yeah, I'm not going to talk to Booger because Booger already says that I'm harassing him. My God, he had to block me. So if he was talking to me, that's different than me talking to him. So
Bro,
I don't know what's going on.
Yeah,
it's okay. Is. I can be coping. I can whatever you want to fill in. These just random meth fueled hit the crack pipe. Just say crit is X. No problem. I did whatever it is. Just put a check mark into it, and we'll move on from it. Okay. There's no need to harp on it. Any subjective bullshit. Crit is doing X. Crit is X. Whatever you want, just make it up. Just have fun with it.
But you're accusing other people of being disingenuous when you're literally being disingenuous.
You could say Crit's accused you. Crit's done this. All that. Okay, now we got all that all the way. All that's over with. Do we got an observation? Is there an experiment going on? Is there a debate? What is on the table right now? Does anyone even know? Or no one does know?
Hilfe.
Or maybe it's not possible to know. Or someone would want to know, but they can't figure it out.
What do you think that Australian guy does for a job?
Whatever it is, it doesn't matter. We only have to worry about.
It'd be wild to be his I would love to be his coworker and just listen to him screaming into his mic.
Oh, this guy. Yeah. Yeah, bro, imagine working with this lunatic and then you just fucking hear him in his lunch break screaming around me like,
"You're an idiot, the earth is flat." Just over and over.
Oh, shit's hilarious.
So just some more random derps. Okay, got it.
What are you talking about?
No observation, no experiment, just like, huh?
Oh, well, you didn't want to answer the original question, so we just talked about other stuff.
Yeah, same answer as before.
No, yeah, it's fine. No problem.
Yeah.
Then don't feel the need to talk then. I don't know. To tell you.
Same answer as before. That's the best part, is that the same answer to exactly the same questions. And then tomorrow, all over again.
You know, you may think it's funny to listen to him rage, but what's even funnier is listening to a couple of people who can't even tell the difference between an observation and an experiment, or certain people who seem to think that measuring a surface is considered science.
But you know what's even funnier?
Yeah, you're stupidity.
Hearing a guy screaming, "Is it observation or an experiment?" for the 20th fucking time, even though he's been answered that for 20 times.
Which one is it?
Bro. Booger said like 15 times when you were just spazzing. He said an observation, and then every time he said an observation, you'd say, "What is it? An observation?"
Exactly.
What? An observation of the Earth, or what? Of what? The sky? Of the sun?
I mean, isn't this like recorded 24/7 on YouTube? Can't you just like replay Crit spazzing while Booger is answering him over and over?
That's why we should just
Wait, is this recorded?
Yeah, the 24/7 live up top. Yeah.
You gotta be shitting me.
Yeah, I don't know how long you had to go back. Like, I don't know, 15 minutes or something.
Or something. Yeah.
It's delayed.
Wait, you've got a YouTube channel, Crit?
Yeah. No. It's up top. 24/7 live, flat Earth. It's like a bot.
Oh my god.
Oh yeah, it's hilarious just to go back and listen to it.
Wait, where can I see? Oh, there. Ah, no.
Wait, why won't it let me click on it?
21 active viewers. Fucking hell.
So you agree the final experiment then isn't an experiment, right?
Yeah. And it was an observation of not the Earth, but somehow tells them about the Earth. And then they'll change their mind right after that because it is about the Earth now. You're like, oh, really? I thought you just said it wasn't. And it's back to an experiment again. You're like, huh?
You guys keep flipping, so we just want a firm answer. Just want to confirm your answer that it's definitely not science and not an experiment. That's all. Yes, Taz, not an experiment, just observation.
Is it an experiment or an observation?
Or neither. It's a debate, a final debate, or maybe a discussion.
A final solution.
Well, so now tomorrow we got the same thing again. You're going to come in here. Hey, flat earthers. You're like, what up? There's a young Earth creationist. Okay. And he did an experiment. Oh, okay. What was an experiment? Well, it wasn't an experiment. It was an observation. Okay. Well, cool. What did he observe? Nothing. Okay. Then what? Well, now he wants to debate nothing on his YouTube channel. Okay, well, what would be the topic? The sun. Okay, what about the sun? Well, on a flat Earth, the sun wouldn't set. In a globe Earth, the sun would set. Okay.
What's the shape of the sun?
What's the experiment going to be with that? How are you going to experiment? We're going to go to Antarctica and watch the sun not
Honestly,
set.
that's a good...
Okay,
what's
good.
The shape?
So
what's the shape of the sun?
Lexi actually had a good question.
You got the sun
Lexi
not
actually had a
setting.
good question.
So is that a
What
flat
shape is
Earth
the
or a
sun?
globe Earth? And you're like, well, it's a flat
He
Earth.
heard you.
but
He's just
really
moving
a
on.
globe Earth
Yeah,
because,
he's just a broken disc.
because it's some reason. There's got a reason there, but that reason is just elusive.
Can you just tell me what the shape
of the question?
Yeah, I told you the same answer as before.
What? Okay.
You didn't answer that. You just ignored it.
Totally different question. Not even
Yeah,
asked.
totally different question. Okay, so totally different answer then.
This nigga's retarded, bro. What the fuck?
He really is.
Yeah, you ended up cracking. So now you know. See, you know
mate, listen,
that I
okay,
will not
please
ask
answer
anything because you're retarded. Meanwhile, you keep asking the same questions.
Retarded? That is very far-fetched.
I asked you what shape is the sun. Nobody else said that in like the best
Same
half hour we've been here.
as before.
What is the same answer? What does that mean?
Yeah, your observation experiment, your meth-fueled symposium, your discussion.
I'm not even talking about any of that.
You're back to an experiment again, back to a debate about the sun, that is about the sun. That's not about the Earth. That's something totally different.
Shit. You are on the forefront of scientific thought and breakthrough. Holy crap.
Same answer. That's the same answer.
The planets, the Earth is not a planet. That's a false premise. When you say other, like the Earth is a planet, like those lights in the sky. No. The Earth is not a planet, dude.
Yeah, my mind is just blowing right now. So, damn.
You have to make a separation. Listen, see here. You have to separate the thing that we see in reality, right? There is the Earth, there is the waters across, there is the medium that we're in, the sky, the clouds, the gas pressure, all of these things that we experience. We also observe the sun, the moon, the luminaries. All of these things that we see in reality, the real, observable, physical world, right? You have to be careful when you look at misrepresentations of that, like cartoons, drawings, right? Graphics, right? When you look at that stuff and they are misrepresenting what we observe in nature, you have to be careful in believing that those misrepresentations are actually the thing that you're looking at in nature. You see what you get what I'm saying? Do you get it? The cartoons that you see of the planets and when you draw the sun and you draw it and you paint it and you draw the planets and you make a painting about the planets, that painting is not the observable phenomena. It's not the realist level. Zahir.
Just a minute, please.
So yeah, you're gonna see depictions, people making these solar system drawings, cartoons. That's not what we observe in reality. Those are misrepresentations. Well, welcome to anybody. If you guys want to speak, ask questions. Sahir is taking a break. Sahir friend was here trying to overspeak a little bit, but I don't know if he's still here or gone.
Yeah, the thing we have to go to the root of the questions is are we gonna follow the scientific method here? So,
for what? Yes, we can follow the scientific method, but for what? What are you trying to if you want to use the scientific method, first you need an observable phenomena, and you want to try to determine the cause of that effect that you're observing. So what are we observing, and what are you trying to establish?
What are you trying to figure out? What are you using the scientific method to find out?
If he knows what it is first.
I mean, yeah. Man, you just don't. Just,
let's see. Let him speak.
Too much. You speak fast. Obviously, I'm not an English native speaker, so I'm
what are you going to use the scientific method for?
So there is an hypothesis, and the hypothesis is, for example, the Earth is flat, and there is
wrong. That's a statement, not a hypothesis. A hypothesis will be a question.
This is a hypothesis is not a question. You have to formulate it in a way of a statement.
No, it'll be an if-then. It'll be right. Okay, it'll be an if-then statement. And if I do X, Y will happen.
So, of course,
if I do X, Y won't happen.
So here. Listen to here. So here, listen, bro. The scientific method will establish. You use it to establish how is a cause of the cause of an effect. The geometry of something, like the flatness or the roundness of something, that is a what is question, not a how is. There is a difference between how and what So if you measure your table in your house, or you measure your feet or your height, you don't need science for that. You need geometry, measurements. You use geometry, measurements, not science.
Yeah, well, geometry is also science. Everything that you can use to understand real world is science.
No, you can use geometry. You can use geometry, but that's not science.
You have an hypothesis that the Earth is round, or the hypothesis.
No, that's not a hypothesis. That's an idea. No, it's not a hypothesis, bro. Stop. It's not a scientific hypothesis.
Whatever. Listen.
It's not a scientific hypothesis. It's. You're wondering? Yeah, sure. Okay, you've looked out at the world and you've thought, wonder if it's curving. What are you going to do to find out?
You need a hypothesis to in order.
No. Stop with the hypothesis stuff, because no, bro, stop. It's not. You've looked out at the world and you're wondering if it's curving and if you're actually on a big ball. What are you going to do to find out?
You have to use measurements.
Well, I want to hear what he is going to do.
I know, but we have to guide him. Because this guy, I mean...
No, he seems to think he knows it all already. Let's hear what he's got to say.
He doesn't.
Well, let's hear what he's going to say anyway. What are you going to do to find out if the Earth's a globe or not?
Wait a minute. I'm just going to paste you in the chat. Damn, my damn internet. Let's say if I can. Just wait.
So you found something on the internet, you're going to share it with us? Go ahead, share it. You can share stuff if you want.
I'm going to share. This is the definition of hypothesis, and is a proposed explanation made on the basis of a limited evidence at the starting point of further investigation. So, a hypothesis, it is a statement. An incomplete statement, maybe. You don't have the evidence yet, but you need a hypothesis in order to do the scientist method. So, if you're arguing that the definition of hypothesis is something else, you're lying. You're actually lying.
No. It's the place that you're gonna use it at, because the scientific method. You're saying that you're trying to use the scientific method to measure, to establish an aspect of a geometry of something, and that's not that you use measurements for that.
I start speaking about the scientific method, and I say, let's make an hypothesis, and the hypothesis is Earth is flat, and you jump over.
That's not a hypothesis.
Hypothesis is not that. Because
it's not.
The definition of hypothesis is a supposition. It is. In English.
You need listen. It's not just a hypothesis. You need a valid hypothesis, because you can. If I say that I hypothesize, anyways, you need a valid hypothesis. The geometry of the world is not a scientific question; it's a geometrical question.
For example, you have the hypothesis that atoms exist. So, but you can.
Bro, just stick to the shape. Just stick to the shape of the Earth. Don't go there.
What?
Just stick to the ground, to the shape of the Earth. Don't go to atoms. We're not gonna talk about that.
I'm talking about the scientific method. So if you apply,
you won't be using it. You won't be using it because you need an if-then statement.
The scientific method in order
you need. What's the three? Are you going to be? Okay. How do you adjudicate a scientific hypothesis? What do you do to find out if your hypothesis is correct or not?
You just very hostile.
No, bro. Answer this question. Answer this question. What will you be doing? No, I'm going to ask you a question. You're going to answer this question only. You're not going to finish your thought or continue on with your blah blah and getting things incorrect. I want to ask you a question. What is done after formulating a scientific hypothesis? What do you need to do to find out if your scientific hypothesis is correct or incorrect? What do you do?
You have to be able to validate it. You have to be proposition.
Yeah. What do you do? What do you do? There's something you do. There's something that a scientist does after they've formulated a scientific hypothesis.
You make
an experiment, dude. An experiment.
You're going to do an experiment. Exactly. You're going to do an experiment.
An experiment isn't. Yeah, but you have to make a prediction.
All right. What are the three constituent parts? What are the three constituent parts of a scientific experiment?
Dude, you're just crazy.
What are the three constituent parts of a scientific experiment?
Pick me, I know.
And say here, if you follow this, you're gonna be able to come to a logical conclusions about this topic, because it's obvious that you think that you can use science to establish the shape of something, and no, you just follow this, bro. Just bring it to a conclusion.
I think I scared him. Sorry, man. I think I scared him away.
No, whatever.
I think I might. Who were you talking to? Was it Zahir?
He's gone.
Yeah, I grilled him the other day.
Oh, so you guys already had a piece of him. I went on a piece of him, but he wasn't. I don't know.
Just yesterday. Yep. Yeah, it's amazing how many people don't understand what the scientific method involves, what an experiment involves with your hypothesis and your independent and dependent variables. The independent is what can be manipulated, and the dependent is the cause of the manipulated variable. So it's those three things, and it escapes people.
Yeah, he was asking for a link to the home server, I think. I tried to DM him one, but it didn't go through because he's not accepting DMs. T-Dub, what are you up to, man? You weren't happy with that Zaire fellow.
He's feeding the birds. He has a bunch of birds around him. I can hear the birds sometimes.
I had a wonderful day. It was filled with lots of work and cleaning up other people's messes. It's pretty interesting.
Good job.
Very humbling day. But yeah, here we are. 11:32 East Coast time.
Here we are in the Void, and Void just joined us. Go ahead, Void. You can ask your questions to John. Go ahead.
No, I have nothing to say about flat Earth or something. I'm just here to listen.
Oh,
all right.
Yeah.
Welcome.
I could start a conversation with a statement though. So like, can you? I've heard some people saying that when Earth is flat, it's not a plate. It's not like a wide area that is just flat. It has a shape. So can you explain the shape of flat Earth?
No, flat is an aspect of a shape. You can have a square, right? And the square, you can have a cube, right? A cube, and the cube has how many sides? Sides.
Yes.
So one side of the cube, that cube is flat, right? It has many flat sides. But the surface of the Earth or the waters across, since it's not curving and it stays within a certain altitude or lower altitude or high altitude based on the sea level, mean sea level, it's observably a flat plane that is not curving. But it's not. That's not a shape. People are not making a claim of a shape of the whole of the construct of existence because we lack the outside frame of reference, like a God's eye view from the outside of it to say, look, this is the shape of it. This is the shape of the whole construct.
That makes sense.
We don't have that. We don't have that to be able to make that claim.
Yes, but okay, so you're not sure what shape the Earth is, but what about gravity, though? How can you explain gravity? So gravity is centered in one point, supposedly, and the globe.
No. Gravity is your claim. Gravity is the globe claim. How about you explain it? Don't ask us
He
to
was going to
explain
say
your
something,
claim.
but guys, he was going to say something about gravity. Go ahead and say what you were going to say about gravity.
Yeah, I'm sorry. Who just talked and tried to flame? Whatever. Listen, I'm just gonna skip. So gravity, in my explanation, is just like, so the Earth is a globe. Why? Because gravity exists. That's my explanation for gravity, and gravity is centered in one point, like in Earth. So
what type of that's some type of logic? That is some type of logical fallacy, though, because you're saying even though you haven't checked that if the Earth is a globe, because you will have to, to make the first statement that you said, Earth is a globe because of gravity, right? Well, did you check Earth if it was a globe in the first place, right? You didn't, so you're just making a baseless assertion that you don't have any evidence for. You see, and then whatever follow after that, it's part of the fallacy that you just made. You cannot come to a logical conclusion about the first statement or the last statement.
Okay, but do you believe in the observable universe? Do you believe that there's an observable universe?
No, we don't. I don't. Certainly not. No believing going on. Can't go there. So obviously, I'm not going to be believing it. And if I could go there and confirm it, then it wouldn't be a belief. It would be I know. So the answer is no believing at all. And gravity. Wait a minute. Let me just finish off what I'm trying to say, please. And as for gravity, there are two schools of thoughts to remember. You've got Newtonian and Einsteinian. And the current gravity today is the Einsteinian theory, which wasn't proven. It superseded Sir Isaac Newton's theory, which he did not agree with. He didn't agree with the mass attracting mass. And gravity hasn't been proven. And as Jemsy said, before you can even talk about gravity, you would first need to establish that the Earth is a globe. And since you haven't done that, you're committing a lot of fallacies at the moment. I'll stop there.
But you also have specific gravity, Jim. You also have specific gravity, which came before Newtonian.
Right. Yeah. I tend not to mention that one, but yeah. Specific
That's the one. That's the one.
My point was okay. So let me start from the beginning to just like clarify my point here. So when you have a scope or when you have something that the thing that you look at and observe the universe or look at planets, you can see like when you look at the moon, for example, the moon is a globe. It's roundy, right? You can see that it's roundy from just looking at it. So you observe the moon, and then you ask yourself, why is it roundy? And then why is it changing its place? So there must be a reason, and that's how he made
That's
his
not
theory.
due to gravity. Hang on. That's not due to gravity. Hang on. It's not due to gravity. And looking at the moon and guessing and hoping doesn't prove that the Earth is a globe. You see, because when you're on the globe,
Void for a bit. I've been trying to.
You've been talking. Let me just add these few more words. When you actually look at it, I know you want to get in there, Jemsy. You will in just a sec. When you're on the Earth, you have to measure the Earth. That's all. Carry on. Go ahead.
My bad, Void. About your question about the universe, right? You're asking, do you believe the observable universe? So we have the realist level, the natural physical world that we all exist and operate in, right? We have that. We can check it, experience it, we can verify it, we can do a lot of things. We know so many things about it, right?
Yeah.
Then, and you mentioned the sun, the moon, right? We have that observable phenomena that we can observe, but we cannot verify it, because you and I, and no man that has existed that I know of, has been to the sun, to the moon. That observable phenomena is not accessible to us. Whatever they gave you as a misrepresentation, like the cartoons, the drawings, the graphics, the movies that they gave you about the sun, the moon, the planets, that stuff is not the realist level. It's not the real thing that we're observing. So you gotta make a separation between the real thing and the fantasy side, the misrepresentation of things. When people tell you, when we observe water, water is a good example, right? When we observe water in reality, the real water that we all can go to and check and see the water, the physics of water, how it operates, and we can do things with water, right? And then someone gives you a misrepresentation of water, and they making claims about the physics of water that nobody can verify. Like water is in the outside of a spinning sphere in a vacuum, right? That the globe claim. No one can verify that water can actually do what they show you in the cartoon. In the outside of a sphere, in a vacuum, we know that water will evaporate. In reality, if you put water in a vacuum, water will evaporate. But they show you a misrepresentation of Earth that is not curving. They show you curving Earth. They show you the water painted blue, right, around the sphere. We don't have that in reality. Water doesn't do that. We have the gas pressure to show you the clouds, right, around the sphere in a vacuum. You cannot have that without a container. So that we have the like you were asking about the universe. We have the realist level, and then we have man-made doctrines and cartoons and movies about whatever ideas they want to sell you. And project. Go ahead.
Hello. Okay, so wow, thank you so much, Jimsy. So what I'm doing right now is I'm trying to understand the theory of flat Earth. You know, to try to negotiate something, you need to understand it first. So
I'll tell you something real quick about that. So real quick, just flat Earth. I mean, people, the world, the Earth is many things, right? It's not two words. It's not flat Earth. Those words that we put on the paper and we write down, that's a description of a surface, an aspect of the surface. And there's so many other topics that you can talk about. The sun is not flat Earth. The moon is not flat Earth. The containment got thrown. That's not, you know, the flat Earth is the surface. That's why people are telling you, okay, the claim is that the surface of the Earth is curving. We go and checked if it was curving, and we came to find out that it's not curving. That it's actually a horizontal frame of reference, and people use the term flat to describe it. So there you go. Go ahead.
Okay. So another question could be, can you send? Do you believe, or do you think that Elon Musk or anyone could send missiles to space or satellites? And what's the difference? Because there are satellites now. Can you explain why there could be satellites?
So we do have technology, and again, we do have technology. We have electromagnetic tethering. We have quantum levitation. We have high altitude balloons, high altitude aircraft. Right? We have that. That's real. We can launch rockets. We can launch rockets very high up. But the idea that they gave you, the vacuum of space, that cannot be. That cannot exist. That's like telling you that Narnia exists, right? You know the girl in the movie, she's real. She's a real girl, and the boys are real, right? But the setting that they went to, Narnia, the talking lion, the witch, and waging war against all these monsters, that's a fantasy set. Okay, so when they show you a rocket, and you see a rocket, the rocket is real. When they show you a satellite and a balloon, the satellite and the balloon and the devices that are built are real. But when they tell you that these things are going to Narnia or outer space that cannot exist because it will violate natural law because we have a gas pressure, and they're telling you that they're going to a vacuum of space that is next to our high pressure system, if that was the case, you and I wouldn't be able to breathe air, bro. Because gas pressure is the force that the gases exert on the walls of its container. And they're telling you that there is no container, that they're leaving this high pressure system and going to a super low pressure system. And they're showing you cartoons about it. And it's just, okay, so you asked about Elon Musk. Yeah, they have rockets. They send the rockets, cartoons about it. That's about Elon Musk. Yeah, they have rockets. They send the rockets. They do certain studies up there, and they do whatever they do. And then there is another version of that, which is the fantasy version, that they show you Hollywood settings, Narnia settings, and they tell you, look, this is what we're doing here in outer space or whatever.
Oh, no.
But you can look at a bunch of that stuff that they show you, and that stuff is Hollywood, Disney, bro, Disney.
Yes. Apart from the fantasies, I was asking a very simple question, which is, do you believe that a missile could go to outer space or not? So you said yes.
No, outer space doesn't exist. No, outer space doesn't exist.
So there's no space. You believe that there's no space?
There is no outer space. Their setting that they're telling you doesn't exist, cannot exist.
I have a follow-up question here. So if there's no outer space, how do you explain other planets existing?
Made up movies about that stuff. That's the fantasy side of things.
Yeah,
when they tell you this stuff, you're talking about the outer space thingy. Those mediums. This is a good moment to say there are unknowns. There are wonders, right? The sun will be a wonder. The moon will be a wonder. The cause and effect mechanisms of the luminaries, of the clock of the sky that is never late. What is that? That's a wonder, an unknown, because you and we don't have access to that stuff. We don't have how do you say, the patents, not the patents, the build, the schematics of the heavens above. We don't have the schematics, so I cannot tell you how that operates. What is it? Listen. I'm trying to tell you, these are unknowns. The medium.
Okay, but you could. I mean, you could look at.
Let me tell you. Let me finish this. The medium that the sun is in, that the moon is in, that the planets are in, are unknown to you and I. The medium that is between the sun and you, you don't know. I don't know. The medium that is behind the sun and behind the luminaries, that's an unknown as well. We don't know that.
Okay,
we cannot go there and check it.
Okay, but you just said that you could send missiles to outer. You could send missiles, but do you mean that these missiles did not even get out of Earth's
They will stay within the contained environment that we're in. We are in a contained environment, and there are limitations. Like the ground has a limitation. There's also a limitation up in the sky, like a ceiling. You can call it a ceiling or whatever. People say containment. Some cosmologists say firmament. The Bible says firmament. There's many names for it. Rakia. Some people say the dome. That will say a shape that we can observe the phenomena, but there's a lot of unknowns about that stuff. That's why people in here, they're gonna be very specific, and there's people with many knowledge about so many different topics.
Yes.
Lasers, communication systems, measurements about long distances, all those things that are here on the ground that we can check, do operate in reality. There's a big talk about that, and when you check down here, you can verify that the Earth is not a globe. The globe has been falsified in many ways. It hasn't been proven. It's just a baseless assertion. And the questions that you ask are good questions. It's just that there are unknowns. There are actually things that no man knows.
Yeah, there are unknowns, and then there are theories that people believe in to be true, but they are not true. They are not 100% true. People are just, making up theories to make everything logical, because if it's not logical, then it's not right. That's what human brain functions.
There are things that we know. Yeah, there are a lot of things that we know. There are unknowns, and then there is people assertions or claims or doctrines of men that they make stories, they write it on a paper, they make drawings, and they tell you, this is the story of creation and the story of the whole universe, and I have it in this book, and this is my idea. If you read it, you gotta believe it or whatever, right? There's that stuff as well. Like actual, like when you watch a movie or an anime or Lord of the Rings or Narnia, those write-ins are also, that's a fantasy setup. But there's also other books that people make claims about. This is reality, but it's not verifiable. There's a lot of stuff that is written that is not true, and people believe it's true, but it's not true. And there is also No, my bad. Yeah, that should be good for now, I guess. Yeah.
Yeah. So like I could state one answer for like just like my whole statement or what I believe in, since I was just asking questions and getting answers. My point of view is that if we go back a few hundred years and we think about Earth, or we think about how the universe functions, we're gonna have a lot of unknowns. As you said, there's a lot of question marks. You don't know what you're living on. You don't know. You can just observe around you. You can just look around you and try to get answers or try to make up theories. That's why scientists.
Oh, theory. No, theory. I wanted to correct you on theory. So listen. There are colloquial theories, like people write it on a piece of paper and they say, "I believe the sun works this way." That might be that. There is a scientific theory that. Okay, let me tell you this. A scientific theory, is something that is already established after repeated experiment and confirmed to be so. Okay. So the theory, what you call in a theory, like let's say the globe theory, that's not a theory. That's just a doctrine. So the word theory actually means that it has been established with the scientific method.
Okay, thank you for correcting me, but just like I'm just going to complete my point of view and then like.
Yeah, my bad. Go ahead.
Yeah. So the thing is, like, we observe the universe, we look at things around us, and then we start to come up with answers. Or, as you said, the colloquial theories or scientific theories, physics. I think you know all of that. So when we come to think of universe, Earth, we don't have any evidence. It's all just assumptions and built up assumptions. I'm not talking about the fantasies here, of course. Like, we're going to get to if we talk about the fantasies, we're going to start going into the brainwashing mechanism and stuff like that. So I'm not there. I'm just talking about the universe and how it observes the things and stuff like that. So when I look, for example, when the things that you had back then, maybe you could look at the sky, you can see the stars, you can see the moon. So you try to look at these things and try to make up a logical assumption. And then moreover, like when you have more technologies, they had that scope that can zoom 100 times, and then they could observe other planets. They could see Mars. They could see whatever, and then they had a observable universe of 7 planets and billions of stars. And then when time passes more, you can see that these are not just stars; these are actual other planets and other places, and then you go on and go on and go on. And these theories, or that you call assumptions, the theories of gravity and stuff like that, they're not just based on like someone just came up and said, "Oh, the Earth is globe," and people followed him. It's that we observed millions and millions of planets and stars in different shapes.
No, we don't. I gotta tell you, bro, we don't. Yeah. That's part of the doctrine that they actually tell you that they observing, like you said, millions of planets. That's not happening. That's not actually happening. That's part of the story, part of the doctrine. And when you say about gravity, what they claim, the warping and bending of space-time, that's just a concept. That's the warping and bending of space, space, width, length, right? You cannot grab length and width and put it in a cup and paint it, right? That's a concept. And time is another concept. So they're telling you that two concepts are put together and they're causing an effect in physicality. And they cannot even demonstrate it. It's just a doctrine, something on paper, written on paper, like a story.
Yeah. Okay. Yeah.
It has not been demonstrated. It has not been demonstrated with any demonstration in the physical and natural world.
Yeah. Okay. This is the fabric theory, right? The fabric of space. Yeah. Okay.
About the ancestors, people in the past that you mentioned, right? You know that people in the past used ground positions of the luminaries to do many things, like navigating across the world, right? They used the positions of the stars They drew angles, and they were able to navigate across the world very efficiently, tell their positions. And also, we have landmarks, like places on the ground, like builds on the ground that are aligned to the stars and the luminaries, right? To the sun, to the moon. And they did all of that in the past. So in the past, people knew, your ancestors, my ancestors, knew a bunch of these things, and they knew that the Earth, most of the cosmologists of the past, it wasn't globe Earth in the past. In the past, most people knew that the Earth was motionless, not curving, a contained environment, right? And that the luminaries were moving like clockwork, right? And they were able to align the luminaries to ground positions and structures in the ground. So people in the past knew these things, and today we have the odd ones that actually claim the nonsensical idea that the Earth is curving, complete nonsense, that is spinning, complete nonsense, and that is a high-pressure system without a container, complete nonsense. That's this cosmology is the nonsensical fantasy claim, the globe.
Yes. Okay. Yes.
Can I just add to that? The people that built those things, say, thousands of years ago, because of the precision that's claimed with the globe Earth, must have prophesized that they would align with us now, thousands of years later, and not lined up thousands of years ago. So,
yeah. Yeah, they lined it to today, 2025, but it wasn't lined back then. If the Earth was a globe.
Yeah. I mean, flat Earth is kind of makes sense, to be honest. Like, I used to think that flat earthers think that, oh, the Earth is a plate. That's it. That's my theory. Fuck yourself. So like now
that is what is called, my bad. That is what is called a strawman, and people build like a fictional version of a man. They make it out of straw, and they burn it easily. You can build a strawman easy and burn it easily. That's why when you let's say someone told you, flat earthers are stupid because they believe in this stupid idea. That stupid idea was in your head, in his head. And you're thinking, oh, this stupid idea is so stupid. Yeah, it's a stupid idea, but that's not what I'm saying. That's not what I'm claiming. That's not what the Earth is. Yeah. That's that stupid idea, that plate that people had in their heads. That's not what the Earth is. Because think about it. That plate is drawn by and is observed from an outside perspective. Whoever made that drawing is in the vacuum of space. Remember, I told you the vacuum is impossible because we have a contained environment, and it's also a drawing from an outside perspective, like a God's eye view. So whoever is drawing that, they're saying, "Oh my goodness, I have God's eye view, and this is how the Earth looks like." It's complete nonsense. So that's why it doesn't make any sense.
Somehow, yeah, sure.
So basically, just to add to that, the real thing to do for you, I think your name is Void. What you need to do is just go out into nature with your friends and try and take some curvature measurements. And when you don't find that curvature, but you're finding flat Earth, that's when you know, and the reality will sink in, and your life will change from that day. Okay, that's what you've got to do. Yeah.
All right, mate. All right, I'll try that. Absolutely. All right, thank you guys. I'm taking my leave now.
Have a good one, boy. Good talking to you.
Yeah, thanks for all the great questions. Very good. Hopefully you're going to go and check it out, aren't you?
Yeah, man.
You want to know the truth.
I'm gonna take my meter now. I'm going right now. Take care, guys.
Okay.
All right.
Bye-bye.
Bye-bye.
Yeah, well done, Jemsy. Yeah, he seemed to get the idea. He realizes that there was a lot of straw manning going on, and you finished it just right. He even understood the theories that people believe that are not real. He actually mentioned that, so that was good.
Yeah, he was receptive. He came to the topic in the past, and he met like the strawman versions of it. That's why he was thinking kind of like that way, like, oh, this is a stupid idea. But now that he spoke to a few people, he can imagine it a little better, I guess. Yeah.
Any other Globers in the house with questions? No? Okay, then relax.
If any Globers got any questions, you can direct your questions to Jin Sensei.
Hi, wakarimashita, mattemasu yo. What did I just say? Yes, I am waiting for your questions.
I just found out yesterday that in the Dominican Republic, in the Caribbean, there is a Japanese town called Ni Japan, I think it is. Let me check it again.
Ni Japan. Okay. Should be Nippon. Wow.
Yeah. They did it during the World War. They had like a bunch of people going to many countries, and one of those countries was the Dominican Republic.
Yeah. The Japanese have been there because they went there, one for the fishing and also to help build up the area as well, the Japanese. They were doing some construction work for the Dominican Republic there, by the way. Okay?
Yeah.
So the Japanese did visit many years ago. Yeah. I remember that. Reading about it. Yeah.
Interesting history.
Yeah. The Japanese are good at that. They've moved around the world and they bring their skills as well, of building and that, and their technologies just to help out. So they've got that. They've got what's called the Rotary Club. I was actually invited to give a speech at the Rotary Club. The differences between, England and Japan. And yeah, that went down well. I was invited twice. One by my kids' headmaster when they were at kindergarten. And then the other time was from one of my students who belonged to the Rotary Club, and I had to travel to that one. Yeah, so I gave 2 speeches. Yeah, and the question, one of these guys asked me, why is it that the Jaguar car doesn't perform well and it's hard to maintain? I said, that's a good question. You'll notice I'm driving a Nissan, I said. Very reliable. The Jaguar looks nice, but yeah, it's not a good maintenance car to maintain. I would never own one. Maybe the older versions, perhaps, but the one that he had, I wouldn't want to drive it. But yeah, he was pretty annoyed. Everyone laughed when he asked the question. Yeah, but they gave the answers, Speaking in Japanese, because they don't speak English, yeah. So I had to be fast on my feet to get those answers out.
The Jaguar is like an European brand, is it?
Well, the Jaguar is a British car, isn't it? Jaguar, the Jag. It's actually a British car, yeah. And they've got British racing history and pedigree, you see. And you find that when you go back at the beginning, the cars look nice, bit of a rust bucket though, tend to rust. And then the engineering, it's nothing like the Japanese, it's just nothing like the Japanese. It's old British standard of engineering. It works, but it's hard work. And when things go wrong, they go wrong badly. And you've got to do lots of oil leaks from the engine.
The British build it more for kind of like for the looks of it and looking like luxurious.
Yeah, the E-Type Jag was nice. Taking it from the Jaguar Racing. So they did the E-Type, really nice, with the glass back door and you open it up and get in. Nice car. But again, when things go wrong, it's very expensive to be repaired. I'd like to own the X13 Jaguar, really nice car. It's a racing car, of course, but it can be converted to drive on the streets. But again, it's handmade, mega money, V12. But then you can have the Jaguar body and put a Japanese engine in there, You know, I'd like to do that. Oh yeah. I'm that kind of guy. You know, because if I went for a British Jag, there's a lot of maintenance schedules coming up all the time. Do you want to be doing that? Not really, no. Japanese cars, you know, you put them in and you just keep running and they're reliable. But for the hobbyists and the purists who love all that, yeah, fine, you know. I just want to get, I've had so many Japanese bikes and Japanese cars, I'm spoilt now. I want to keep whacking at my toolkit every other day, you know what I mean? But there you are. They do look good, though. The Jaguars, they do look good. My brother runs a BMW after owning an Audi, so he prefers the German brands. I'm the Japanese brand. My other brother runs a Vauxhall, which is like a British and American and a German mix there. There you go, you know. Yeah.
I like the Lexus very much. Lexus.
Well, yeah, top brand, isn't it? Best built car, the Lexus. Yeah. When it debuted, yeah, it totally outperformed all the other brands. You know, the best performance that they did was they put a glass of water on the engine, on the rocker cover, put it there, and revved the engine to maximum. And you know, the water didn't even move in the glass. Okay?
Wow.
That's smooth engineering, all right? That was back in the 1995 era, 91 to 95. They put the glass of water on the engine, revved it to the max, and the water didn't even shimmer. They put it on the BMW, they put it on the Mercedes, they put it on the Jaguar, and the glass nearly fell off. Yeah, so that was a good selling point for the Japanese, yeah. And then that same Japanese car, after 10 years, they invited that same car back, and everything was silky smooth. Nothing had worn out. It had about 100,000 miles on it. It was a great performance, was just there. Everything still worked after 10 years usage. Yeah, man. The Lexus, brilliant car. From the day it came out to the present day. Toyota brand. It's Toyota, isn't it?
Yes. Yeah. Those Lexus, they're pretty comfy, very reliable. Good, decent on gas. They're pretty decent on gas as well.
Yeah, very economical. All singing, all dancing. I would like the SUV version of it. But again, it looks too pretty to be an SUV, but that's why I go for the Nissan, a bit more rugged look. I like the rugged look, and I'm not into the pretty SUV because you don't want to. So I'm going to go for it all the time. So I prefer the older cars, and they're solid and they're still reliable. I mean, my one is 26 years old, so you know it's nice, more than that. Actually, what am I talking about?
Nissan will make you a good vehicle. Nissan will make you a vehicle that it will be pretty similar to the standards of Toyota, but a little less expensive.
Yeah, that's right. Exactly. Yeah, because they take the same bases, you see, and chassis base. That's the beauty of it. And then I like my one because my one is coming up for 30 years old. Okay, still running, beautiful. I changed the suspension, struts only, of all four struts. Didn't touch the springs because the springs were still working beautifully. Yeah, man. Water pump replacement, head gasket replacement. What else did I do? A few linkage dealing with the suspension into the engine because it's a 4-wheel drive. A few linkage changes and that. Yeah, what wicked. You know, remember it's 29 years old. Love it.
Which Nissan do you have?
The Nissan Pathfinder. It was known in America. Here in Japan, same car. It's known as the Terrano, as in terrain, rough terrain, yeah.
Yes, they sell it in the Caribbean, in Puerto Rico. They sell it there, and lots of people love that car. From back then, yeah. in the 90s and the 2000s, I think.
There you go. Yeah, and my one was a 1996 model.
They will take some of those like up, like they were pretty good to go up the hills, like up the mountains or even rugged terrain.
Right. That's what it is. Yeah. They entered the Dakar Rally. People use them in the rally racing and everything. Beautiful car. It's comfortable. It's comfortable inside, but it's still rugged. The seats split down, and you can get all your push bikes in there. Because I used to take the mountain bike trek and get all the mountain bikes in the back. Yeah, man. Camping equipment, skiing equipment. I've got the roof rack.
What year is it?
It's 1996.
1996 Pathfinder.
Yeah, 29 years old.
Wow, that's a pretty car. Simple, but definitely. Yeah, that's a good. I like that style of car.
Yeah. It's a V6, 3.3 liter petrol engine. And the springs are slightly bigger than the standard, so it sits just that little bit higher off the ground, which is nice. And then the struts and that, so I've got it really well sorted out. And love the vehicle.
You have the spare tire outside too.
Yeah, the spare tires on the back on the tailgate. Yes,
that gives you more space inside.
Yeah, absolutely. Yeah. That's why I can get all the push bikes are in there. I put one in one way and then the other one in a reverse, one in one way and reverse. And I can get like 5 mountain bikes in the back with the front wheels removed, of course. Front wheels have to be removed. Yeah. So you take the front wheel off and then in they go, So sometimes we go mountain bike trekking and I do that. And then the wife puts then the other kids go in the wife's car because the back of the car's taken up. So I've got 2, It normally seats 5. But when I put the mountain bikes in, it's only going to seat 2. Yeah, love it. And then I go mountain bike trekking on my own. I love it then as well. Early in the morning.
1996 Pathfinder.
Yeah, Nissan Pathfinder, 1996. Registration plate number 911. 911 was an inside job. That's why I chose the number. Yeah.
You were able to pick it? To pick that number?
Yeah, I was able to pick it. Yeah. I wanted to pick the number for my motorbike as well. But apparently in Japan here, you can't pick your number plate for your motorbike, but you can for your car, which was a big disappointment. I thought, I could have 2 911s. Yeah. I loved it, man. The Pathfinder. What about you? What are you driving?
The last one I had, it was a RAV4.
I know that one. Yeah, that's a Toyota. That's really nice.
Yeah, but I bought it like brand new, 2020. Then I sold it because when I bought it, it was like right before COVID, right? And then after COVID, it went high. It went like way higher in value. So whatever I owned in it, I still had like a lot of value in the car. So I was able to sell it for a profit.
Oh, well done. Yeah,
so I sold it. Yeah, and now I drive a Mazda 6.
Okay, yeah, that's a nice car as well, the Mazda 6. On the same lines, SUV type, smaller, but nice, tight, neat. It's a very neat car, isn't it, that Mazda? Very neat from the outside looking and very neat on the inside, yeah. Well, is it black interior? Black.
It is black and it's gray outside. And I driven it from all across the East Coast, from Massachusetts, from New Hampshire, Massachusetts, towards the Key West of Florida, the more south point in the United States.
Yeah, that car was built for those kind of distances, and it's neat, it's economical, it's smooth, it's not noisy. That was easy for that car. That was a walk in the park. Mazda.
Oh yeah, easy.
Ultra reliable Mazdas. Ultra reliable.
And good in gas as well.
Yeah, I just said that. Yeah, very good fuel economy. Yeah, that's the thing. Japanese vehicles, they're very fuel efficient over the Americans because American cars are big, but they're now making their cars lighter themselves now. The Americans, so they're dropping the weight a little bit to get that fuel economy. But the Japanese have had that for a long time, a good 50 years. You know, but at the beginning of their career of motoring, they were known as rust buckets. Even though the engines were reliable, put that key in, it's going to start in winter, snow, you name it, it's going to start. There's no doubt about that. But they rust a lot. That was the problem.
Yeah.
Yeah, and then by the time we get to the early to mid 80s, that problem was taken care of. And by the time you get to the 90s, no rusting going on. Solid chassis, ultra reliable. Honda leading the way in Britain. That was, even though Toyota was the top brand, but in Britain, Honda because of the Honda racing. So most of the Brits like the Honda brands. Yeah. Yeah, so you even drive a Japanese car yourself, you see.
Yeah, I found them. I do like the American cars, but
so do I. Yeah.
It's just that I found, you always find good deals with the Japanese cars, and whenever there's time to fix and do maintenance on them, it's easy stuff.
Yeah, and it's not so often as well. You know, those maintenance come, not so common. It's rare. You know, if you look after them, they do just keep going. That's it. Treat them okay. But see, I do like the Ford Raptor. I like that one. Pickup truck thing. I love that vehicle. Would like to own one of those because I think they're really, really good looking and reliable, powerful, reliable. Yeah, and it's a Ford again. You can interchange parts with other models. That's the other thing, and still keep it going. So that's what
I've been wanting like a pickup truck, and I was looking at the Toyota Tundra, the Tundra.
Oh yeah. Another solid vehicle, made for the American market. That one.
Yeah. There is the Sequoia, the Toyota Sequoia.
Yeah.
As well. Really good ones. Yeah, I'm not gonna buy. I'm not gonna buy new cars anytime soon. There's so many good. There's so many good that you can get like a second hand in really good condition for a really good price. Because those monthly payments, and here in the US, you have to pay insurance. In the newer the car, the more insurance you have to pay.
Yeah, no, I don't do that. Yeah, we've only bought one new car. It was the El Grande. A multi-purpose vehicle with multi-personnel vehicle. It sat, let me see now how many, 1, 2, 3. So it was an 8-seater.
You'll be able to take a really good vacation once a year instead of doing the monthly payments.
I didn't. Yeah, we did the monthly payments with the new El Grande. My car paid out cash straight out, and I wasn't looking to buying a new car anyway, and I'm still not, because I find that the newer cars have too many sensors, and they're in awkward places when they go wrong, which I've noticed, and then they've got this massive crumple zone that they put in there. Big panels. You have a crack here. You've got to get a complete new unit for the bumper. Crap like that. I'm not into that at all. No, thank you,
bro. They want $700 a month for a car. Like not even like a luxury car. It's just like a mid-term car. Like not bad, but not luxurious. Just I don't know. That's too much money.
Yeah, $700. Yeah, that's silly, really. Yeah, that's mad money. Mini mortgage going on there.
Yeah. And then you have to put insurance on top of that.
Right, there you go. Yeah, that's why, no, I'm not really interested in a new car. Unless I won the lottery, then what I would do is redo the the Pathfinder, my Toronto, just get that sorted out, one or two things. And then I would like to, let's have a look, I'm looking at a sports car, like the Ford GT40, like those cars. Yeah, wouldn't mind owning one of those. Modern version, one of those would suit me nice. Yeah. Ford GT40. Le Mans looking. Yep. That'd be nice. That's it. That'd be just a play toy thing. Yeah, nice. Smiles for miles. You know what I mean?
It costs me, if I'm on it, $1 a kilometer.
Oh, that's nothing, is it? $1 a kilometer.
Yeah, $1 a kilometer if I'm ripping on
sorry,
it.
Yeah, that's fucking drinking, isn't it? Wow.
Oh, it's crazy.
$1 a kilometer. That's crazy.
Yeah, that's drinking. Yeah, give me the engine size again.
It's the stock is a 6.2, but I put a Demon Killer package in it.
That's a V8, yeah?
Yeah, supercharged.
Supercharged, yeah. That's a drinker. $1 a kilometer, you know what I mean? So you do 6 miles, that's $10.
Yep.
Fuck.
That's a car to impress the ladies or the friends.
Yeah. That's
I'm just like, I don't do it for that.
That's lunacy.
For my own
lunacy stuff.
I'm pretty sure Mercedes makes the
Mercedes. But the Hellcat's good. Yeah, nice looking. But yeah, that's expensive driving though. I mean, and the Germans are good at that, you know what I mean? Fuck. BMW motorbikes are getting expensive.
Yeah, if I'm actually like easy on the gas, it's pretty good. I think I get I can't remember what it is, like 20 miles per 1 liter or something like that. It's really reasonable if you're not on it and not speeding.
Yeah, if you're not pushing it hard.
Yeah.
Yeah. The second you punch it, it's got I think it has 3 fuel pumps.
Yeah. You've got a supercharger in there as well, so come on. Yeah. Designed to drink. And chuck out that power.
Bro, I've seen in the US so many like police chases behind, like people. I don't know if people steal those cars, but there's so many of those Hellcats that people are just running.
Joyriders.
Yeah, there's a big, huge thing about them being stolen. Like, they had to come out with like a whole anti-theft division just for that. I forget the name of it.
Yeah, because that would be a nightmare on the insurance, you see. Because if it's a popular car that's getting nicked, insurance companies don't want to touch it unless you're prepared to pay.
My insurance company actually wouldn't put collision on it. I had to go through like a special insurance to get collision put on it.
Wow.
Yeah, it's weird.
Yeah, that's what you want insurance for in the first place. Nuts. I generally go third party fire and theft. That's it. I never go fully comprehensive. I find that it's expensive one and a waste of money too, because if you're careful driver like me, then you're just throwing money to the wind.
Do you get animal impact with that?
Do I get what?
animal impact?
No, that doesn't really come up. No, I've never had that problem. So
Really?
no, I don't. I think if I hit an animal, I probably won't be covered. Probably won't be covered is what I would say there. And then I would have to seek. No, what it would happen would be that would be third party. You see, so I'd be looking to seek to the owner of the land to get my money. To get my meaning, and they would have to pay.
Yeah. But in Canada, there's deer. Like we hit 3 deer this year already.
Wow.
So
you see, that's probably why the collision. They don't want to know.
I've been looking at it because I'm in the northeast United States, and sometimes when you drive, you see the deer crossing the street, and that's so dangerous. I'm a careful driver. I don't drive too fast, but I can see how people just hit them because they go in the middle of the road, and that's it.
It's the same in the Mount Fuji area as well. So when I'm going to climb Mount Fuji, for example, I'm really careful because they do walk just across the road, and I'm going at like 3 o'clock in the morning, so it's dark. You know, you've got your headlights full on, but they tend not to cross at night. But I'm very cautious because I have seen 1 or 2 crossing anyway. But luckily for me, they've got across before I got to them. But yeah, not good. You know, no, if I hit a deer, then because I'm third party fire and theft, I'm not fully comprehensive, so I wouldn't be able to claim for that. That would be down to me.
Yeah, but you've been saving in car payments for 30 years, so you should be able to have some change in your pocket to buy another Pathfinder.
Definitely, yeah. That's what everyone says around here. Yeah, saving all that because they know what I do. I don't ever go fully comprehensive. Never know, Nick, because that's a waste of money. You know, it's not cheap anyway. And then when you do claim on your when you claim on your fully comprehensive, your insurance goes up the next year anyway because you made a claim. So you can't win anyway. Oh yeah. Same in Britain. Same in Britain. Right?
Here, animals are no fault, so your insurance doesn't go up. But the last deer I hit, my repair claim was $22,000 that the insurance had to pay.
That's a new car, surely.
No, it was a truck, like a F-150, a newer one. Yeah.
That's a lot of money.
He's saying that you can buy a new car for $22,000. You can buy 3 cars with that.
Yeah, and a motorbike. What are you going on with?
Yeah, no, not here.
That's crazy money. No, so if I hit a deer, it's going to be third-party claim, and that means I have to find a landowner first and foremost. And yeah, of course, the police would help you doing that anyway, you know, because they know who owns the land and that. And and then I get my money from the landowner because they should really. Yeah, go ahead.
The landowner doesn't own the deer, though. So how would that work?
Oh no, sometimes the landowners do own the deer as well. Here in Japan.
Oh, I see. Yeah, here there's no such thing as deer farms. They're all wild.
Yeah. So some of the deer, and then in the case of where they're wild and it's not fenced off properly, then you go to the prefecture and the town hall and then you claim off of them. Yeah.
Oh yeah, for sure. If it was like a cow here, that would be the same here.
Yeah, exactly. Because if you know it's dangerous, you could lose your life. So you know if the deers are going to be around, you've got to fence them off. Can't have them crossing. But anyway, big signs are up. Be careful, stag crossing and things like that. So already you're slowing down on the gas anyway. You know. So yeah, once I see the deer crossing and that, I just drop the speed. No point in being silly, and then just enjoy the scenery. Which is why, like I said, I've never had a problem colliding into any deers or anything like that. Either on my push bike, motorbike, or car.
Yeah, I was just going to say that. My buddy just hit a deer on his chopper, his bike, and he got hurt really bad, broke his neck.
Yeah, that's dangerous, you see. Yeah. No, yeah. Not as soon as I see the deer sign, I'm off the gas. Because I've seen these accidents and they're not good. Not good at all.
In Canada here, like the ditches, the grass gets really long. You can't see them until it's too late. Like there's no chance.
Yeah, which is why you got to go slowly. Yeah, you've just got to go slowly.
Yeah, but if you don't go the speed limit, then you get run off the road.
Well, I mean, no, I'm not going to, I'm going to keep the speed limit, whatever that might be. If it's 30 miles per hour, then it's 30 miles per hour. Generally, when there's deer crossing and that, the signs are up to drop speed as well anyway. You can't go L for leather. No, because that's a recipe for disaster. So the speed limits are dropped. So you're limited on your speed as well, Some places 20 miles an hour.
Yeah, here it's all 100 kilometers an hour, 110.
Yeah, you're lucky you got that. In America, I thought it was only up to 55 miles per hour top speed. In the US.
Many highways are going to be marked 65, even some I think 75, but in the fast lane, people go 80, 90, and the police, if you're in the fast lane and you're doing 80, 90, the police barely ever bother anybody with that.
Well, you're lucky because in Britain, they'd be bothering you, man. Definitely would be bothering you. You know what I mean?
Well, at least here in the Northeast, they rather people. Even in Florida, when I went to Florida, everybody was doing over 90 in the fast lane.
Yeah.
Yeah.
Not in Britain. You'd lose a license. The police are very strict on that. Maximum speed is 70. So if you're doing 90, that's 20 miles over the speed limit. You've lost your license right there for a year. Instant ban. Yeah.
I think here they prefer, even the police, they prefer people going a little faster than going slower.
Yeah.
But that's why you got like 4 lanes. You have the fast lane, and then you have the other lanes that you can go slow. In the fast lane, you cannot be going slow in the fast lane because everybody that wants to go fast, you
lose your license again. If you're driving slowly in the fast lane below the speed limit, you could lose your license there, or if not lose it, get points on it. For not driving at the speed limit, yeah. So you've got 3 lanes. You should always keep left unless you're going to be overtaken and you have to move right. So you use the lanes correctly. In England, you've got to do that way. Here in Japan, it's a bit more free and a bit more liberal, And I've taken the bike up to 183 miles an hour. Yeah. In the middle lane.
I'm a scary guy. The most I've done is like 110. That's it.
Yeah, 183 miles an hour. The reason for the middle lane is so I've got a choice of either going left or right if there's an incident. Do you understand? Right.
Yeah.
Got to have an escape route. Yeah. So it's got to be all calculated when you do that, those kind of speeds, because things are happening very rapid indeed. No room for error. Just no room on the motorbike.
Nah, the motorbike, better be careful. There's no room for error there.
No, not at all.
And if the person next to you makes an error, they also can hurt you.
This is what I'm talking about, yeah. So I'm generally doing those kind of speeds when it's nice and clear. I'm in the lead, I'm out of everybody's way. And remember, on the 5-lane, it comes up in seconds. 3.2 seconds, I'm up to 60 already. So by the time I've done like 20 seconds, I'm up to 160 already. Yeah. It's quick.
160 kilometers per hour, not miles.
No, miles per hour. Miles per hour.
160 miles per hour?
Yeah, I've done 183 miles per hour, yeah.
Damn.
Yeah, man. I did 165 on the motorway M1, okay? And I held it for all the way down to the end of the motorway. I got off, I'm onto the A roads now, and the police came along in a helicopter, right? They didn't know it was me, because when I was going the speed, I didn't see any helicopter around. But by the time I got into this area called Golders Green, the police came up to me and pulled me over. And they asked me, were you just on the M1? And I said, no. Didn't say yes. I said no. Then the other colleague was looking over the bike, checking it out, checking the tyres. And then they had to let me go because it wasn't me. I said, must have been some other bike.
Well, good thing that you say it wasn't you, because if not, they'll take you.
I'm not going to say it's me because that's automatic ban, isn't it? I'm not going to say it's me. They have to
Yeah,
prove
you
it.
don't want to incriminate yourself. You're not the police. You shouldn't be doing their jobs.
That's right. That's right. They had to prove it, and I was nowhere near the motorway when they stopped me.
No.
I don't know, mate. Hypothetically, if there was one, then yes.
Right. So why don't you think we haven't? I'm asking you. Listen, but everything's not an attack. It's a legitimate question. Don't feel emotional about it.
It's the question.
Why haven't they taken a long haul flight to go as far as they can go safely?
Okay.
To see how far they could go.
Who are they?
Because the Earth isn't flat.
Hold on, I want to know who they are.
A flat Earth society, a team of flat earthers that the community decides are the pillars of the community.
I mean, look, you're giggling through the fucking question.
I didn't giggle at all. Dude, you're literally
you fucking giggle and talk.
I didn't giggle. You're projecting. Roll the tape back. It's
I'm
on
letting
record.
you fucking speak, and I'm wanting to answer your question, but you keep giggling and talking.
I didn't giggle, but go ahead.
I can hear you smiling through your fucking tone, dude.
Oh, I'm smiling. Absolutely.
We are, dude. We're all fucking smiling. Because the argument's fucking hilarious, dude.
This is fucking hilarious.
Nobody takes it seriously.
Yeah.
Yo, Naxi.
Yo, son.
You think the Earth is flat?
Dude, I think it's a square, honestly. I got proof, too.
Yeah, that's valid. Actually, yeah, no, that's valid. I personally, as a sane human being, think the Earth is round, or is a ball at least. Just coming from somebody who doesn't have severe mental issues as generally over here.
I actually think we have a female planet, because how...
Yeah, so you think it's logical to believe in something that has never been proven?
Apologize.
Well, I mean, it's kind of been proven. You've flown up and seen a ball, dipshit.
All right, are we going to take you seriously? We're actually going to have a conversation, or are you just going to call people mentally deficient?
I mean, I could sit here and call you mentally deficient all day, or I could have a debate.
Just did. That's the fucking point. So should we have a reasonable conversation?
Use your big boy. Hey, use your inside voice. Use your inside spine.
No. You don't run this conversation. I do. Now, do you want to have one?
Oh, dude, see, my bro is the alpha. You get pussy, don't you? Yeah, you get a lot of pussy, don't you?
So there's no point talking to you. That's what you're saying.
Well, no, I can sit here and have a debate all day long, but if we're going to sit here and swear it out, okay,
let's do that. Then.
I got you.
Okay. So do you want me to start?
Yeah, I would like to start. So, explain to me. I actually did this the other day, and I think he's a mod. His name is Thray or something, or Trey or whatever the fuck. Let's start with the horizon. A lot of people think the horizon is because you have the optical illusion of the horizon, then you have the actual horizon, which would be the curvature. Explain that.
The actual horizon that would be the curvature. What?
So if you take a boat sailing out to sea, it appears with your naked eye. I'm too high for this shit, but it appears with your naked eye that it's going over the horizon and disappearing, or it's going over the curvature of the Earth. But if you take an optic, like somebody actually who thinks the Earth is flat told me this. If you take an optic, I actually made a very good point when he was saying this. If you take an optic, or if you take just a telescope or anything and look out there, the ship is still there. I mean, it's obviously still there, but eventually it will go over the curvature of the Earth and it'll not be visible anymore, no matter how much you zoom in, no matter how much it will still be.
What you've demonstrated is when you bring out an optic, you can see the boat again, and the horizon has moved now beyond the boat because you're able to open up the angles, make them wider, so you can resolve them. That's what the optic does. So it demonstrates that the horizon is the limitation of the optic's angle of view when looking horizontally across the surface. Because when you look more across the surface, the angles reduce until they enter an angle that the optic can't resolve. That's what the horizon is, the limitation of view across a horizontal surface.
Okay, so you admit the horizon is indeed real.
Yes, optical. You can see it. It's
Okay.
not physical, though. It's purely an optical phenomenon.
A horizon is an optical illusion that can only be with a spherical object.
No, I've just demonstrated to you with the limitation of angular perspective that that's exactly what you'd expect to see.
But
when
the
looking
horizon,
at distance, things reduce in angular size, don't they?
But the horizon is
that was a question.
Optical.
That was a question.
Oh, what? What was the question?
That was a question. Do I need to repeat the question to you?
Yes, please.
Okay. Do things reduce in angular size with distance?
I have no clue what that is, sir. But I am currently.
Do things look smaller the further away they get?
Oh, yes.
All right, good. So when you're looking with distance across a, isn't it? Until you can't see it anymore. That's what the horizon is. The limitation of angular view with distance across the surface.
Yeah, but that can only be a thing with a spherical object.
No, I've just demonstrated with perspective. Are you denying perspective? Do you think we shouldn't talk about perspective when we're looking at things?
Okay, we're backpedaling. Horizon.
I'm trying to make you address what's actually being said.
What? Hold on. Sorry, I was talking when you were talking. What did you say?
You can't understand shit, can you?
No, I mean,
I just demonstrated to you.
When you were talking. My bad.
Life.
Is the horizon
They are lying to us,
and
I'm asking you why they're lying to us, and you say it doesn't.
Why is the horizon?
Why does anyone lie? Moto, you said it was really
we can give you a bunch of reasons, and all of us probably have personal different spins on why would they lie. But Sporadic's right. If you don't like the reason that I give, or AG gives, or Matrix gives, or you're not convinced by that reason, is that going to have an effect on your empirical critical thinking? Because it doesn't matter what the motive is. It's either flat or it's not, or it's round, right? It's either a ball or it's not.
Yeah.
And it doesn't matter what the motive is to lie about it. Now, there is good, credible reasons, but we're not going to sit here and talk about that before we've established the facts. The facts are way more important than the speculation. You don't go to a crime scene and sit and argue about motive before you've decided whether a crime's taken place.
Yeah, that's true.
Right?
Yeah. I got that.
All right, so Genghis Khan was worshipped as a god, and he was deified. He's deified by one of his successors.
Well, there you go.
16th century. So, yep. I mean, and it got so bad that like the Russians came over and tried to convert them to Orthodox Christian.
By the people.
Huh?
Just by successors.
Yeah, successor Khans. You know what I mean?
And he had a bunch of successors.
Yeah. Yeah, one of the ruling successors turned it into a state religion, dude. So, yeah, I mean, if you want to continue on, like, denigrating us and what we have to say, because you're trying to nitpick, you know, the point being earlier, to revisit it, is you don't require a conspiracy theory if everybody believes something is true, like an urban myth. If everybody believes Bigfoot is true, people are not knowingly lying to you when they tell you that they think Bigfoot is true. All right, so people look around today for a one world religion. You know, people look around for that because it helps unite people of differences and pacify folks from different walks of life. I mean, a role of an emperor was often to amalgamate different cultures that he conquered so that they could play nicely together. And one of the tools of statecraft that emperors used back then that they still use today is called the noble lie. Noble meaning of royalty, the lie of the king. And the lie of the king took many forms, and one of the most popular forms was some kind of myth or religion about the people to get people to feel national pride and empowerment and to unite together despite their differences. I can't think of anything greater of a noble lie for this age than the prevailing cosmology that everybody believes in and has never experienced. And is even worse than that. Your own experience runs contrary to what they tell you is actually true. You know, examples are sunsets. Something as simple as a sunset highlights this. Right? I mean, you experience the sun setting, the sun moves throughout the sky, everybody sees this, but you're supposed to believe that you're stationary and the ball beneath you is rotating and you along with it. So when it comes to space, projecting space and power, I mean, this entire cosmology seems to be in fulfillment of a great noble lie. Look at what the International Space Station is. It's a program for international cooperation and diplomacy. Now, does this mean that they are concealing the true nature of Earth? That requires them actually knowing what it is in the first place. I don't think they do. I don't think many people involved in this do, because I think their goal is to project power, to project unity behind a false cosmology. Like people at NASA could still be thinking that they're trying to figure out how to do orbits. And we know for them it's a fruitless endeavor.
So how do you explain, like, in America it's day, in somewhere else it's night? How do you talk about the seasons? How do you like explain those?
I go with the explanations and the observations that have been throughout all of human history about this. You know, the sun has a migratory path in the sky throughout the year, so it imparts its energy differently on the surface throughout the year. And this causes growing seasons to differ throughout the year, depending where you are in relation to it. I mean, you can read like the Farmer's Almanac in America for a view on that. What people are looking for is an explanation beyond what they can actually experience. And that's where you start seeking religious experiences instead of what's based in reality. So, I mean, while you could go to other groups like ours and hear all kinds of crazy stories about what they believe could be true, our community is not in the business of offering alternative explanations like them. We're here to discuss what is empirically derived. Right. I mean, I could be somewhat flippant, right, and say someone asks, you know, how does the sun move? I could just say gravity. I mean, right? What's wrong with that? Yeah.
What are you laughing about?
Yeah, I mean, it's kind of funny, right? Like, call it the God of the gaps, right? If we don't know what something is, we'll make up a concept and insert it in to explain something that we can't discover for ourselves. So Einstein's relativity was just that, right? So when Michelson-Morley experiment was set up with interferometry to test to see if the Earth was moving, their interferometry test did not test that the Earth was moving at all. The results came in negative with a null result. So the God of the gaps moved in, Dr. Einstein, and said, you know what? You wouldn't be able to detect that anyway because space-time is contracting. So your very method of measurement is also being contracted and you have no way to tell. Total unfalsifiable pseudoscience. So in this case, hey, flat earther, what causes the sun to move? I could say, well, flat earth gravity.
I know
Yeah,
you
my
guys
friend,
hate gravity.
this is going to be good for you if you do embark on some of these questions in terms of understanding what critical thinking is. And I'd say that's one of the best benefits from engaging in the flat earth topic, is by actually using your critical thinking and questioning, well, what is gravity? What is Einsteinian relativity? Where is the direct evidence and proof of any of these claims? Because when you start to break this down and start using your own brain instead of just taking the mainstream narrative for granted, something very strange happens. There's a picture that is painted where you've realized now that the globe is a religion. It's no different from believing in any religion, completely faith-based, built on hearsay, with no direct evidence. And that doesn't on itself mean it's not
true. It has
true.
a little bit difference, like include here called science. Other religions, faith, they don't include science that much.
Yes, but when you say science, what do you mean?
Yeah, we have like all of these people talking about Earth is rounded, and most of them are scientists.
Right, but there's no science.
They're not saying it because God told them,
What's a scientist?
A person is like a study the topic.
What topic?
Studies a topic.
Depends on the topic.
Ambiguous, bit vague.
Depends on the topic. We have many different scientists.
Yeah, but there's no science or science experiment you can do to prove that the Earth is either spinning or curving. So when you say all of this science, what science are you talking about that helps us to prove the Earth's a ball?
Geometry, mathematics.
That's not science. Geometry proves. Mathematics is a language.
So mathematics is not a science, though?
No, it's not.
No,
it's not. Okay.
That's why they're called different things. They're different categories.
Yeah, just like art isn't engineering.
Okay.
So math is used within science, to express things, just like words are used to express things. That doesn't mean that language is everything or language is science, right? We just use language to express things. And math is a type of language. And geometry isn't science either. Geometry is measurement, and geometry actually proves the flat Earth, not the globe. So if you want to use geometry, you're going to find that we live on a flat stationary plane.
Right. And we can use geometry in very sophisticated ways. We can employ modern technology to perform measurements and calculations. And we can do all of this without invoking it as
is still science.
It's not. Sorry?
Mathematics is a science.
Mathematics can't be a science.
Well, you guys were laughing at me.
It's a language. It's not a science.
For the same reason English is science.
Right. Use math to develop models, and models describe things.
Okay, so just give me a yes or no answer. Is it science or not?
No. Math isn't science.
Not. For the fifth time, no.
Like, if you want to take it back to its etymological sense, right, where it's just like knowledge, right? I guess even then it's not. That's well, I guess you could have knowledge. Really, like math is more of a logic thing, right? Like a logic and
language.
Yeah, it's just numeracy. Really, it's like, how would you even explain this, Brady?
Yeah, I would say it is a language of quantifying things.
Right. Yeah. Quantification. Exactly. Yeah.
I liked the person who said logic. The logical relationships between things, but it's definitely not a science. Why do you keep saying that? We've told you like 5 times now. It's not a science.
I mean, we can give you an actual definition of science. You know, what if you're doing science, you're employing the scientific method. You're studying the presumed causes of naturally occurring effects. So science is all about studying that cause and effect relationship of things occurring in the natural world that you experience. So the cause of the sunrise is a different question than whether or not the Earth is measuring a specific way. You have to be comfortable with the idea that you can't know the causes of things. Usually, when you reach the end of that causative chain, the very beginning or top of it, you have what's called an axiom. So you could be on a rather fruitless endeavor in the study of certain causes. And that's fine. Like, what is the cause of what is the cause of me dropping a pencil, right, and it hitting the floor? Well, in one sense, I am the cause of it because I picked the pencil up. The pencil falling in this case was not naturally occurring, but I could be testing for the cause of why apples fall. Well, why does an apple fall? Well, the tree grew up and it bore fruit, and the fruit fell down back where the tree came from. So why is the tree doing that? Well, that's just what trees do. I mean, you plant the seed. Well, where'd the seed come from?
Are you finding this a lot to take in? Or are you busy, or what's with the silence?
I'm busy with mathematics.
Oh, that's lovely. In what field specifically, if you care to offer?
Being a science or not? Just...
What's that quote that we have? Something about its validity, it doesn't lie in experiment. It's not science in the sense that its validity doesn't lie in experiment. It's not how it works. So, yeah.
Well, I mean, there's a lot of like a ruling out of things. Like before you can actually maybe get to doing the science part, you're ruling out other possibilities until you have something you can experiment with. I think just the formation of an actual testable experiment itself can be very frustrating and take many, many hours, days, years even. Or if there's a specific variable that you need to measure and you don't yet have the technology to do that, to even begin your experiment, you got to go through an engineering process. So the formation, like there are entire graduate level courses on just experimental design. Like how do you design a scientific experiment? And that gets really deep into the philosophy of mathematics and the philosophy of science.
I think his head might have gone. Are you still with us?
Boom. Right. I mean, a lot of times, like you can criticize scientific proposals, experimental proposals, when you look at the logic and it doesn't flow, when potentially they're affirming the consequent, which is so often the case, or they're engaging in model reification, where they're assuming a certain outcome, designing a model and then testing reality against a model instead of a model against reality. There are a lot of critical errors, and it happens all the time. And it requires humility to accept when somebody points such errors out to you. And it also requires confidence on the part of those criticizing this in order to engage in criticism that may go against their own self-serving biases.
Hey, Sporadic, what do they call that when they're using models instead of reality and calling it science? What do they call that?
That might be pseudoscience for 500.
Yes, sir.
Yeah, reification. Taking something that you conjure up in your mind to be true, you've convinced yourself it has to be true, and you've dismissed all other possibilities, so a single cause fallacy, and then you submit this as a proposal. Right? So, the very solar system model itself is just an explanation, a description even, not even an explanation. It's a description. It's a descriptive model based off of kinematics. The kinematics of Kepler's ratios and periodicity. And you can take a kinematic model and you can assign actual dynamic forces to it, but that doesn't mean you've proven it to be the case. You've just back-engineered something based off of your own chosen perception of it. Like the celestial sphere model, right? I mean, we use the celestial sphere as a gigantic coordinate system called latitude and longitude, right? And there are 2 points of origin, one in the north and one in the south. This whole thing is a gigantic concept, right? It's based off of a subjective interpretation of how the heavens operate. And even though modern cosmology does not say that the heavens are in fact a celestial sphere, modern astronomy uses the celestial sphere. And knows that it's also not true. And just like we flat earthers know it's not true, but for different reasons.
They'll also conceive of the Earth as being an infinite plane too, from which they can take elevation angle measurements from.
Yeah. Or the paradox of the celestial sphere itself being a sphere of infinite radius, which would make it topologically indistinguishable from a flat surface. You like mathematics? The celestial sphere is a sphere of an infinite radius. What does that look like?
I think our friend dipped.
Yeah.
Fancy that. We frazzled him. Oh, well.
Frazzled dip? Oh,
definitely.
Yeah, I think the math, not science thing got him, was too much.
Seems to be a common thing.
Well, math is abstract, so wouldn't that make it a philosophy? Or more of a philosophy?
Yeah. I mean, everybody knows you can lie with statistics.
Yeah, it's just about ideas, isn't it?
Yeah, you can paint a picture with numbers.
Yeah,
that's what George Ellis was saying, wasn't he? He was saying, I can construct you a mathematically symmetrical universe with Earth at its center. Blah, 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 blah. Explains all the observations. He was boasting. And then poo-pooing on philosophy. Kind of. Oh, he said there's nothing wrong with it, but he thinks it's disingenuous that cosmologists don't make their audience aware of why they're saying the things that they do, that it's philosophically based, right?
How ironic. When you break it down, it's more about ideas than, I mean, it's not experimental, is it?
And then when they're intellectually dishonest, it's more like philosophistry.
I thought it was discomfort at the notion that Genghis Khan was worshipped and deified by Mongolian people. Like, that was just kind of out of place. What an unusual thing to get upset about.
He kind of thought he knew it all, didn't he? I like the new logo, Sporadic. Looks pretty cool.
Yes. I'm refreshing my brand.
Rebranding. That's good.
I'm going to start charging $5 for a cup of wisdom instead of $4.
A cup of wisdom. I like that. Some of these Globers have only got half cups.
Decaf.
They're on that wisdom light. Welcome to the newbies that joined. Good to have you in the channel. 24/7 Flat Earth. Hey, I don't know if 20 Cups is there or if anybody else has got any info on it, but 20 Cups brought up an experiment or an observation that was done in a vacuum chamber tower, and it demonstrated. Yeah, and he was saying that it demonstrated there were differences in the rate of drop depending on the density of an object. Does anyone have any more info on that?
Correct. I'll post the little video up for you. Going now. Loading.
Legend.
That's in Bremen, Germany. And I think it was university researchers that were doing it. And they were told that they couldn't go back to the vacuum test tower anymore after those results came out.
Couldn't imagine why.
Never. Yeah. No way. That's crazy. Yeah, because I've heard this said before, but I've not looked into it myself, and I think it's something that I really do need to be able to cite. It'd be great if there's a video. And so the conclusion was that it was more related to the density of the material rather than the weight of the object that showed the variation.
Well, that's a bit, I think, a step too far. They would just say that they've demonstrated that objects of different qualities actually drop at different rates. Like, that's
not verified. Yeah, I'm with you.
Yeah. I mean, it'd be great if we could make a stronger positive claim. I mean, there might be like an electrical component to this that may not be mass dependent.
Yeah, I've heard Necros likes to talk about that side of things, the electrical side of things. I just wish there was more experiments to look at.